Hey everyone, it is Caleb and welcome to your Python programming tutorial series. I am your host, and what in the world are we going to be covering for the next quadrillion videos? Well, pretty much I want you to become fluent in Python programming. So if you're just starting out, you're completely brand new and you need to take things a little slower, then I have a beginner Python programming series. We're going to cover some of those basics again, however, we're going to go in a lot more depth. So for example, for the first section of the series, we're going to deep dive lists, understand how to work with them, including nested lists and loops and all of these different things you need to know how to do. And from there, we're going to move on into the other data structures in Python. So we're going to talk about dictionaries and so forth. And then hopefully we'll get into object-oriented programming and building out some pretty cool apps. My approach here on YouTube is fairly simple. If you've seen it in my other videos, you probably know I try not to type anything that we do not comprehend. I want you to understand why we are typing stuff and not just what to type. I don't want you copying, pasting stuff from this video. By the end of this, I want you to have a better understanding. And with that, my expectation is that you're going to be typing out the examples and following along, or you're probably not going to be learning a whole lot. But maybe I'm getting a little bit too into the weeds. Let's just back it up. How do we even get started, and what even in the world is Python, and why would I want to use it? Well, Python is a programming language, first off, and it's one of the most simple programming languages to get started with. But it's not limited in its power. Its power level is equal to or stronger than all the other programming languages out there. Python is a great language to learn programming principles and data structures and algorithms as well, just because of its really simple syntax and also intuitive way of working with it. If you're coming from another programming language, you'll probably pick it up just fine and be like, hey, this is pretty easy, but there's various approaches that are radically different than the other programming languages out there. To get started, you can go to python.org and you can go into downloads and get it for whatever operating system you're on. I'm on Mac, but if you're on Windows, you should be able to follow along pretty simple. Additionally, there's going to be tons of code samples up on my GitHub account, github.com/CalebCurry/Python. So the beginner Python, that was my previous series, and now we are in Python. So this is going to start with lists, and I'm still working through all of the content. So leave suggestions for the upcoming content, but I pretty much have a good idea of what I want to cover. So you can go into any single one of these and you can get tons and tons of examples of what we've been going through in these videos. So you can copy and paste those, use them in your code, or just tinker with them to try to understand them, whatever you need to do. Now, when you install Python, you can open it in this thing it comes with called the idle, which allows you to evaluate expressions on the fly. So for example, I could say 5 plus 5 and it'll return the value 10. So if you're just learning and you want to test stuff out, this is a great way to do it. But there's also another alternative, and that is to use a text editor and actually build out Python files. That's my preference. If you're coming from another programming language, maybe that's what you're more familiar with or more comfortable with, and that's probably what I would recommend if you're trying to do anything really complex. So for that, I'm going to be using Visual Studio Code. You can download it on the internet, and when you run it, it's going to look something like this. And there's an extension in here called Python, crazy name, I know, right? And this will allow you to run your Python code in the terminal. So as an example, I can go in here and I can say print hello world, run this bad boy, and look at that. It says hello world right there in the terminal. So there you go. You just created your first Python program, senior software engineer. So yeah, that's the end of this series. Hopefully, no, I'm just playing. We got a lot more to go. So stay tuned for the next episode where we're going to start diving into the code. Congrats on making it to video number 2. I always try to say thank you and good job to the people who make it this far, because I understand getting started with programming can be a little bit much. But I'm going to try to make it simple for you guys, and we're going to start learning about lists. So in Python, or pretty much any programming language, you're often going to want to group things together. And the easiest way to do this is to use some sort of collection. Collection is the more general term to describe something that holds a lot of stuff. You know, you can think of, like in real life, you can have a bucket, you could have a bag or a box, and you understand how these things work in real life. You put stuff inside of them. They act as a collection of items. And the same thing needs to happen in programming. So the very first thing is you need to get this Python extension, so you can just search Python and download that. That allows you to run any file that ends in .py. So when you create a file, you can put that extension there. So you can say test.py, and that will put a play button up here, which will run the file in the terminal. So I'm going to stick with hello.py, and I'm going to get rid of test. So we can just right click, delete, and move to trash. Now, when you're working with this, you might get an interactive terminal. So if that happens, it's going to look something like this. So if you accidentally hold shift and press enter, it'll sort of be like the idle with Python, where you can type in things such as 5 plus 5 and it gives you a response. However, when we're executing our code, we don't want to be in this interactive mode. It's just going to complain about everything. So what we need to do is we need to exit that. You can just right click and kill terminal, and that'll bring you back to normal. And now you can run your file. And there you go, it says hello world. So those are the basics, and if you have any issues, you can just go up to the top here and go into the help and search it. So for example, if you're looking for a new theme, you can go to color theme and it'll show you how to find it. So maybe leave in the comments what your favorite theme is and I'll try it out. But other than that, let's get started with lists. I'm going to collapse this just to get a little bit more room, get rid of this line, and then here's what we're going to do. We're going to create a list of healthy foods. So we'll call it healthy, and then use an equal sign, which is the assignment operator, and then square brackets. Square brackets indicate a list, and you can put multiple elements in it separated by commas. So we all know the world's healthiest food, even if you don't want to admit it, and that is pizza. And just as a little bit of a review from the previous series I did, you can use single quotes or double quotes for your strings. That's totally fine. So I can go in here and use pizza with single quotes, and then I could go in and put frozen custard in double quotes. So this is my diet plan. This is why I am so ripped. So if you want to get on my level, just stick to my diet plan. You will not regret it. Now, the important thing to understand about lists in Python is that they are dynamic. So in other programming languages, let's say you're coming from Java. In Java, there is an array, and this array is statically sized. When I say statically sized, what that means is the size is determined when you're writing the code, and you cannot increase the size of the array dynamically. This can cause a problem because, you might want to add data later. So they had to come out with a different variation of an array, which is called an array list. And this one can grow and expand as you add more elements. Well, in Python, there's no concept of a static array or a static list. We just have list, and it's already dynamic for us. So we do not have to worry about numerous data structures. We just have one that can grow or shrink. This seems simple, but it's actually very awesome because it's going to make our lives a whole lot easier. So what we can do is we can go in here and we can say healthy dot append and put parentheses and put some data in here. So we can add another element in here and we can put something in like apple crisp. And I don't know what my capitalization standards are here. I'm just going to put everything lowercase, just to keep it consistent. All right, there we go. So let me explain what's going on here. When we create healthy, the list, it's actually an example of an object. And an object is a very general term, but the main thing you need to understand is that whenever we are working with an object, we can often put a dot and then some other word to access this object's members. So healthy is an object of type list, and lists have some special things they can do, including append, which allows us to append extra data into this list. If anytime you need to see the list, you can just say print and put in healthy. Running this, and it'll show up down here, pizza, frozen custard, and apple crisp. So let's talk about this append here for a moment, just to get everybody on the same page, or at least the same book. This is an example of a method. And a method is just a function that is attached to an object. So it's a lot of vocabulary if you're new here. So again, I have that really beginner series if you need it, but we're just gonna keep going and keep the pace. But essentially a method is a function attached to an object. So a function being a sequence of statements, well, a method is the same exact thing, but it's specifically related to this list called healthy. A method is different than a standalone function because a standalone function is not attached to any specific object. So for example, there's the len function, which will tell you the length of a list or a string. And in this situation, you actually have to pass in your object as an argument. So when you do this, it's going to return a value, and we could assign that to a variable if we wanted, and then we could print it like so. So running this, and we get the value 3 because there's 3 elements in our list of healthy foods. So this is an example of a function. Print is another example of a function that we'll be using a whole lot in this series. And when you invoke a function, you often have to pass in data. which is known as an argument. So healthy is an example of an argument. With print, we're passing in length as an argument, but we could pass in multiple arguments as well. So for example, I could pass in a string and then separate these by commas. So now we have two arguments. We have a string called length and then the actual length data. So running this, and it says length is 3. So that is your basics, getting up to speed with creating lists and adding data to the lists, as well as invoking methods and functions. Now we're going to get some practice working with the list and seeing some of the different things we can do. So stay tuned for that. Now I promise I'm not going to run this into the ground the whole series, but I really don't want to have to explain all of the absolute basic things over and over again. So if you found this video to be challenging and you're not sure you're going to keep up, don't quit. Don't do that. Don't be lame. Instead, go to the beginner Python series and watch through that, because that's going to talk about every single thing from the absolute beginning. So that is all I got for you in this one. Stay tuned for the next one. I'm pretty excited, so hopefully you are as well, and let's get learning. Hey everyone, this video we're going to be talking about how to check if items are in a list. So we could consider this in a lot of different scenarios. Maybe you have a shopping list and you want to check if something's already in there so you can add it if it's not. Or maybe you have a backpack and you need to check if an item is in there so you can use it. So we can do all kinds of variations with this. Right now we're just focusing on the logic part, but this can be applied to numerous different applications. So how do you do this? All you have to do is say what you're looking for. So we're going to look for chicken pot pie. And then you say in healthy. And what we can do is we can surround this and press the left parentheses to put parentheses around it. Hit the left arrow key a few times and say print, and this will print true or false. And right now we get the value false. And the reason it's false is because this value is not inside of this healthy list. So you can consider this going through and saying, is chicken pot pie equal to pizza? And that's going to evaluate to false. So then it does it again and says, is chicken pot pie equal to frozen custard? And it goes through each element to see if chicken pot pie is part of that list. Ultimately, it's not found, so the entire expression chicken pot pie in healthy will evaluate to false. Using this capability, we can actually branch our software. So we can say, if chicken pot pie in healthy, what are we going to do? Well, we're probably going to throw it out because chicken pot pie is disgusting. But other than that, let's say we're actually looking for something good, such as pizza. If pizza isn't healthy, then what are we going to do? We're going to eat it. And this pound sign, or the hashtag as you youngsters call it, this here is an example of a comment, and you can put anything you want here and it's fine. It's not going to affect your code. So whenever we need to describe something, we can use a comment. So instead of just a comment saying eating it, we could actually just print a message. We could say eating the pizza. So running this, it says eating the pizza. That's because pizza is found inside of the list. So this evaluates to true and the indentation is executed. If we did put something that wasn't healthy, it's not going to work. How do you even spell broccoli? Broccoli? All right, it is spelled broccoli. Obviously, that's not in there, right? So this is not going to execute. We run this and nothing happens. All right, maybe I need to go set up an appointment with my local dietitian, but you guys get the point. We can check if an item is in a list by saying if item, whatever it is, in healthy. And you can also do the opposite. So you can say not in, and in that situation, we could go buy some. And in this situation, it will pass as true because broccoli is currently not in healthy. Stay tuned for the next video. We're going to continue our discussion on lists. Hey everybody, so good news. I recently visited my local dietitian and they gave me suggestions on what my new diet plan should be, which I put it up here on the screen. Kale chips and broccoli, that's all I'm eating for the rest of eternity. But we have a big problem, you see. I got a backpack and it's full of a bunch of junk. So what I want to do is I want to remove a food from this backpack, but I only want to do it if it's not healthy. So what we're going to be doing is we're going to be teaching you how to remove elements from a list and also how to check if it's healthy or not. So first, to remove, all you do is say backpack, and there's a method on here called remove. And this takes the item to remove. So we're going to remove pizza, and then afterwards we are going to print backpack. So running this, and you can see pizza was successfully removed from the backpack. Now I can go in here and I can see that pizza is not in the healthy list. However, what if healthy actually had hundreds of items? I wouldn't want to use my eyeballs to like look through that, right? I want to check to see if it's in healthy, and if it's not in healthy, then remove it. So here's how you would do that. So we're going to say if pizza not in healthy, then if that's the case, we're going to remove it, and make sure you indent that. So running this, and we get the same exact result, but it's a little bit smarter, because if we went in here and put something like kale chips, well, we know that's in healthy, but we can still run this code and check it out. It doesn't remove it from the backpack. So that is how you remove data from a list, as well as check to see if it's in a list. The next logical step would be to go through Backpack and remove any of that junk we don't want in our life, right? We want to be healthy. We don't need to be eating that junk food. So we're going to go through our Backpack and remove anything that's not healthy. And I'm going to show you how to do that with a cool trick in the next video. In this video, I'm going to be teaching you how to remove numerous items from a list. But there's one condition. We're not going to remove everything. We're only going to remove items that are not found in another list. So we're going through this contrived example with this backpack full of junk, and we only want to keep the healthy food, but this could be generalized to lots of different examples. Just consider this healthy here to be like this lookup table of things we want to keep, and we're going to remove anything that's not that from this backpack list. It doesn't just have to be food, it could be items you have and valuable items. Maybe you only want to keep things that are valuable. Whatever the example may be, I'm going to be teaching you how to do it. So we're going to get rid of the code we have here, and what we're going to do is we're going to take Backpack and reassign it. I will be teaching you how to change Backpack itself and not reassign it, but I'm going to save that for the end here. So for now, just follow along. And we're going to use something called list comprehension, which we're going to get into that in detail probably later on, but essentially for this example, we're going to go through all of the elements of Backpack, and we're going to keep them if they're in healthy. So here's what it's going to look like. We're going to say item for item in Backpack, and then we will check if item is in healthy. So this is some weird syntax, but you can kind of think of it like this. We're going to keep an item, and the item comes from Backpack, but only if the item is in healthy. And we can print Backpack after this. And running this, and you can see now we only have kale chips. So it worked. Now there's one gotcha with this, and I'm going to show you that now, and that is it has to do with IDs. So if we print ID of Backpack before, and then I copy this and paste it after running this, and I'll just expand the terminal just a little bit, you can see we have two completely different values. So if you were referencing this list somewhere else, that connection is going to be lost. It's not going to be this new updated list. We lost that. So if you need to just modify the same list, all you have to do is put square brackets here with a colon. And if you remember this syntax from the first Python series, this is how you slice a list. And this allows us to replace all of the elements in a list without actually creating a new list. So running this now, and you can see we have the same exact ID, so the original list is modified. That's all I got for you guys in this video. Stay tuned for the next one. Hey everybody, this video is going to be dedicated to understanding the list comprehension syntax. And I would say this is probably more of an advanced feature, so if you're brand new, don't really feel like you have to have it mastered, but if you're following along, let's try to conquer this and understand every single piece. So we used it in the previous video, but we kind of glossed over it. But first, let me just refresh what we were trying to do, and then we'll see how it works. So we had this backpack of items, and it has pizza, frozen custard, apple crisp, and kale chips. Then we have this other list, healthy, and it has kale chips and broccoli. And in my mind, I was like, I don't want to eat this junk food. I want to remove everything from my backpack that is not healthy. And then I just want to keep the kale chips. So you can think about it going through this list. Is pizza healthy? No, it's not. Toss it. Is frozen custard unhealthy? Nope. Toss it. Is apple crisp unhealthy? Nope. Toss it. Lastly, kale chips, that's unhealthy. We're going to keep that. So a shortcut to do that is this line right here. And when we run this, the only item left in backpack is kale chips. So to show you a pretty equivalent example, let's create this using a loop. So let's try to repeat this. And what we're going to do is we're going to keep the list comprehension syntax here, but we're going to do it using loops. And this is what it's going to look like. First thing is we're going to create a new list. So we'll just call it healthy_backpack for now. And we'll assign it an empty list. And we'll say for item in backpack, we're going to check to see if it's healthy. So if item in healthy, what are we going to do? We're going to say healthy backpack dot append and pass in the item. So this should do exactly the same thing. And then what we can do is we can print healthy backpack here at the end. So running this, and we still get kale chips. So we achieved the same thing, but this is a more concise syntax. Every piece of this loop structure here coordinates to a piece in this list comprehension. So let's go through it, and first we'll look at for item in backpack, and that coordinates to the loop. That's going to iterate through and grab each item. The next part coordinates to the if statement, if item in healthy, right here. And the last piece is a little bit shortened for us. All we have to put is item here at the beginning, and that coordinates to appending it to the list. If we wanted to modify the element, so for example, we said item dot lower, or maybe we did upper just to make it a little bit more visual here, you could do the same thing in the list comprehension, like so. In the loop variation, we're assigning it to a new list, which we could do exactly the same thing here with the list comprehension by saying healthy_backpack. So either one should do the trick, and just to prove it to you, we can run this now. We get kale chips, upper letters, and then if we were to get rid of this and go back to the list comprehension, run it now, and we still get kale chips in all capital letters. So it might take a little bit to get used to the syntax. I honestly stumbled over it when I was first learning it, and we can actually do a lot of different things with this here. So an example is, let's say we wanted to create a list of squares, and we made a loop for I in range up to 10, and we're not going to include 10, and what we're going to do is we are going to say I ** 2, which will square the number, and we can take this and we can append it to squares by saying squares.append, and at the end we could say print squares. So running it, and you can see we get 0, 1, 4, 9, all the way up to 81. Notice our for loop doesn't have any if statements, so our list comprehension is going to be a little bit thinner than the last time. And this is what it's going to look like. We're going to get rid of that loop, and we're going to say for I in range up to 10, and then all we want to do with I, which we put at the beginning, is square it. So that's the syntax for that, and running it, and we get the exact same output. So that's your introduction to list comprehension. The very first thing in here is the expression, the result you want to get. Next up, we got the list or the iterable that it's coming from, and then optionally we have the condition to see if something is met on what elements you want to work with. So if you just wanted to work with even numbers, you would say if I modulus 2 is equal to 0. And when we run this, you get 0, 4, 16, 36, and 64. So that coordinates to 0 squared, 2 squared, 4 squared, 6 squared, and 8 squared. So we'll probably touch on that more in the future, but for now, we're gonna move on to some more basic stuff. Just wanted to give you a little bit of taste of that, and I'll see you in the next one. Hey everyone, in this video, I wanna talk about the length of lists. And yeah, it's pretty simple. You've probably seen this already, but there's this function, len, you can pass in a list and it will return an integer that is the size. So to see an example of this, we could actually pass in a list directly, and we can just say hi, just throw some random greetings in here. Hello, what's up? And this is gonna return a number, so we can assign it to a variable, or what we can do is we can just print it like so, and running this, and we get the value 3. Yeah, it's pretty simple, but the main thing you need to watch out for is that when you have a list, it is 0 based. So the first item in the list, or the first element in the list, has index 0. So when we create a list separately, we'll just call it greetings, and I'm going to take this list and I'm going to cut it and paste it up here, and now we can just pass in the greetings variable here. But the main thing you need to understand is that when we print and grab greetings index 2, that's going to grab the last element there, and running that, we get what's up and 3. So if we wanted to generalize this, so like, get it all mathy and stuff, we could say n is the list size. We could say the highest index then is actually n minus 1. So when you're studying algorithms or data structures, you'll often see n, and it just means the size of the list or the input for an algorithm. So we're not in an algorithm class right now, but essentially you could think of it like this. Let's say we created a loop for item in greetings, and then we could just print that item. So running this, we get all of the data. How complex is this algorithm? If you want to call it an algorithm, I know it doesn't do a whole lot, but pretty much any sequence of statements can be considered an algorithm. Well, this has the complexity of n, or what you might see big O of n, because if we increase the list size, the number of times this has to execute is the same as the list size. This executes 3 times. If we increase this to 4, well, now it's going to run 4 times. So we'll probably be touching on a little bit of algorithm analysis or just understanding how complex things get as the size of lists grow. This one's not so bad because if we double the list, the time it takes is just going to be twice as long. But for some processes, it's going to be more than that. It might be n squared. So if we double the list, it actually really affects the performance negatively. The only other thing I have to say about list lengths is that you can use them in a range. So you can say for I in range, and when you pass in the length of something here, length of greetings, you can use I to access via index. So we could say print greetings of I. Make sure you don't forget a colon there in running this, and it works exactly the same way, but now we can work with this I, so you could say I, comma, greetings index of I, and it'll print 0, 1, 2, and 3. Range is nice because it already works really well with the offset. So for example, if you grab the range 5 to 10, well, the 5 is included and the 10 is excluded. So it really helps prevent you from going out of the bounds of a list, and it helps you start at the right position. So this would start at index 5, and it would stop at index 9, but 9 included, 10 excluded. So that's how when we pass in the length here, we're passing in the value 4, but we actually get 0 through 3. It starts at 0 included, and it goes up to 4 excluded, so stopping at 3, and we get 0 through 3. So yeah, I'm rambling now, so let's move on to the next video. Hey everyone, welcome. In this video, I'm going to be teaching you how to count a particular element in a list. So right now we have a list where everything is unique, but we're going to create a list with some duplicates and count them. First, you should understand how len works. Len is a function that will give you the length of a list, which is the total number of elements. So this is going to return an integer, so what you can do is you can print it, and when you do this, you should get the value 4 for this list. So that is how you count all of the elements. We know there's a total of 4 elements. But we don't want all the elements, we just want one of the elements. So we can be a little bit more specific, and instead of using len, we can actually use a method on this list by saying backpack.count. Count here is going to take one piece of data, and that is the string in this case that you are looking for. So if we are looking for sword, we can put that in there, and when we run this, we should get the value 1. That's because there's one sword in our backpack. If we decide to go in here and add more swords, which I don't know why you have a bunch of swords in your backpack, but whatever. You put 3 swords in here now, and we get the value 3. So this can be used if you want to cap the number of items in a list. You can do a condition. You can say if backpack.count of sword is, let's say, less than 5, then if it is less than 5, what we will do is we'll add another sword to the backpack. So we just say backpack.append and pass in sword. So this is how you can dynamically cap the number of elements. Anytime you want to add, you can check to see if it's under some number. I'm not entirely sure why you'd want to do this, but just throwing that out there. If you wanted to cap it to just 1, well, in that situation, there's actually another data structure you can use, and that is a set. And we're going to be talking about that really soon. The only other thing I wanted to throw out there is that if you're ever doing a check to see if the count is greater than or equal to 1, well, there's actually an easier way you could do this, and all you would have to do is say if sword in backpack, which we already talked about earlier on in the series, but this is basically going to see if the count is 1 or higher. Basically, it'll just go through the list. If it sees sword, it's going to break. So you can do this if you don't care how many there are. As long as there's one, then this will pass as true. With count, you can be a little bit more dynamic because you can actually check for a different number than just one. So maybe you want a list where the cap is 3 of each item. You could do that using the count method here. So that is how you count for a particular element. We're going to do some variations of counting in the upcoming videos. So I'm pretty excited and it should be pretty fun. And I'm going to teach this really well. You can count on me, I guess I should say. But I swear I'll spare you guys the terrible jokes for the rest of the series. So stay tuned for the next one and we'll get into it. See you there. Hey, what's up, you freak bags? In this video, I'm going to be teaching you the introduction to sets. Or another way you can think about it is how could you prevent duplicate items in a list? It's actually not going to be a list data structure we're going to use as set, but it works in a similar way. It's like a list with no duplicates. So this is a list, and we can have sort in here 3 times, and that's totally fine. As we learned in the previous video, you can do something like backpack.count and check for a value. This will give you 3, so all of those exist in the list, and if you went ahead and just printed the list as is, you would see that all of them exist in there still. So you get sword, rubber duck, slice of pizza, parachute, and then 2 more swords. With a set, it works a little bit different, and here's how you create a set. So we'll just say backpack 2, and instead of using square brackets, you use curly braces, and then you use it the same exact way. So we can throw a sword in here, we can throw in a rubber duck, we can throw in a slice of pizza, which I don't know how you guys could just throw it, it's so disrespectful. And then we'll go ahead and add a parachute, and then lastly, another sword, and we'll just keep off that last sword because this one's gonna be ignored anyways, and I just wanna show you that. So when I go ahead and print backpack 2 and run this, you can see it says slice of pizza, sword, rubber duck, and parachute. Sword is only in there 1 time. So adding an extra one doesn't cause an issue. We don't get an error. However, it just doesn't get added. Another thing you should note is that the order does not stay the same. So slice of pizza actually shows up first, even though we put that in here 3rd. So you should use sets if you need a unique list and also if you do not care about order. So the purpose of sets is to basically see if something has been added or not. It's a yes or no kind of thing. So when we're working with this, we're not going to be able to do backpack2.count because it doesn't really make sense. We know there's never more than 1, so getting the count doesn't really make sense. So instead, what we would do is we would say sword in backpack 2. And in this situation, it's going to tell us true. So that is how you check if something is in there. So to conclude, one more time, sets are useful if you don't want duplicate data and the order of the data does not matter. We're going to be using sets throughout the rest of the series, so stay tuned for that. Hey everyone, in the previous video we touched on sets, and they're very similar to lists except they don't have any duplicates. We can use this difference to our advantage if we're working with lists and we want to count each type of element. So, we want to know how many swords we have, we want to know how many slices of pizza we have. Well, I'm going to show you how to do that, and we're going to use list comprehension and sets. So this is what we're going to do. We're going to make a list of counts. And where is this list going to come from? Well, we're going to generate it using list comprehension. So we're no longer going to work with this backpack 2 set. So what we're going to do is we're going to get rid of that and just worry about backpack, which is a list. And for every single element in this backpack, we want to count it. So we say backpack.count and pass in, we'll just go with item for the variable name. So we want to count each item in this backpack. Then we put the for loop to get this item. So we say for item in backpack. So if we want to see what we get so far, we can just print counts and run this. And look, we get a list of numbers, 3, 1, 1, 1, 3, 3. So it's basically saying we have 3 swords, 1 rubber duck, 1 slice of pizza, 1 parachute, 3 swords, and then lastly 3 swords. So this seems to do the trick. It's counting how many of each item. However, the problem is that for every item of a particular type, it counts them again. So how in the world do we say, oh, we only need to count sword 1 time? Well, all we have to do is say set and put backpack in parentheses. If you remember, the attributes of a set is there's no duplicates, so it's only going to count sword 1 time. Running this now, we get 3, 1, 1, 1. You could also put the item name here if you want. So you could put comma item and then just put this inside of a list itself. Like so. And now we have a list of lists each one with the item count and the name. So we have 1 slice of pizza, 1 parachute, 1 rubber duck, and 3 swords. To test this with a bigger list, I'm going to replace backpack with this. So now we have sword, rubber duck, slice of pizza, and parachute, but we have that repeated a bunch of times, and then a few other items, a cannon, a laser cannon, a Canon 90D, and a can of soup. So it's kind of like a video game where your backpack can carry literally anything. And let's run this, and it seems to do the trick too. We got 4 rubber ducks, 4 swords, 1 cannon, 1 can of soup, 1 laser cannon, 4 slices of pizza, 4 parachutes, and 1 Canon 90D. If you didn't want to put these in a list and you just wanted to print it or something, you can do just that. You're pretty free to do whatever you want. So for example, we can print the count and the item and get rid of the list and run this now. We get a bunch of print statements and it says the number and the item. And then obviously here, the list is none, 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 because we're printing counts. So you would just get rid of this and get rid of this. So that's another way you could do this. However you want to do, it's really flexible. So that is another way we can count elements in the list. Now I want to do the same style of thing, but I want to do it in a different way in the upcoming video using something called counter. So stay tuned for that and I will see you there. Hey everyone, welcome back. This video I'm going to be teaching you a new way to count elements in a list. So given a list like this, you should get an output something like this. And this is a completely unique way that I thought of actually entirely by myself. So let me just take a quick look at my notes and we will get started. Oh yeah, we went through that one. Ah, cool, yeah, this looks nice. All right, so here's what you gotta do. All you gotta do is, you can do it at the top or wherever you need, but we're gonna say from collections, import counter. And we can use this counter class to our advantage by saying counter and then just passing in backpack. And then what we can do is we can print this. So we can say print and we'll just see what this gives us. And you can see it gives us actually a dictionary where we have the item and then the number of occurrences in the list. And it goes through every single item, no repeats. So this solution is faster and it is easier. If you're completely new to dictionaries, you might need to learn a little bit about how to work with those, but we're gonna be getting into that in this series. So compared to the previous video, this is probably what would be the recommended way to count elements. And for pretty much any time counting elements in the future, I would recommend this method. That being said, it's still good to get practice with list comprehension. Even if it's not the recommended way, it's still something that you might see and you should understand how it works. So that's all I got in this video. Stay tuned for the next one. We're gonna review everything we've talked about in this series so far, make sure we got everything figured out before we move on to the next topic. So stay tuned and be sure to subscribe. Hey everyone, welcome back. This video, we're gonna review everything we've talked about so far in this series. So if you want the code that we're gonna go through, which I would recommend you do yourself, then what I would do is go to github.com/CalebCurry, go into my Python repository, and then go into Python. I might change it to Python programming, FYI, but we'll see. And then we're gonna go through 01 intro, and you can just copy all this and go through it in your text editor. All right, so here is the code, and this is pretty much what we started with in video number 1. And the whole goal here is to become more familiar with lists, counting, and list comprehension. So it's a lot of stuff, and we should be able to get through it pretty quickly though. Since, it's review, you guys should have all this memorized, right? So the very first thing is how to create a list and how to add elements to the list. Obviously, I need to really figure out my diet plan here because I keep going back and forth between what foods are considered healthy. But right now, it looks like we're gonna go with some junk food. I'm gonna consider that to be healthy here. And when you print that, it comes out as a list in the square brackets. You can print the list all together, which is actually pretty convenient. In other languages, you might try that with an array and you might just get a memory address. So you don't have to iterate through the data, which is nice. Now, checking if an element is in the list is actually super easy. All you have to do is put the element you're looking for. We're working with strings here, so we put the string and then say in healthy. So we're asking, is chicken pot pie in healthy? And considering it's disgusting, I'm not going to consider it as healthy, and we get false. And the reason it's false is because in that original list, we only have pizza, frozen custard, or apple crisp. Chicken pot pie is not one of the elements. You can use this within an if statement, so you see that here. We wrote out the backpack here. And pretty much if the pizza is considered healthy, then we print that we're eating it. Here's another example where we remove data from a list. So what we do is we have a backpack of items and we check if pizza is considered to be healthy, and if it is, we remove it from the backpack. So those are the basics of lists: how to create them, how to add elements to them, how to check if elements are inside of them, and how to remove elements from the list. Next up, we have list comprehension. We just talk about the basics here. So what this does is we use list comprehension, and just to break this down, we look at this part first. For item in backpack, so for every single item in the backpack, if the item is considered healthy, so if it's in the healthy list, then what we're going to do is we're going to keep that item. And that's where we get this output right here, kale chips, because it got rid of everything except either kale chips or broccoli. Yum, right? Another thing to call out is we have this slicing syntax after the list. When you do this, you're basically saying, hey, we want to replace the entire list from beginning to end, which will ultimately keep the same object ID. So if you have any aliases for this, it's all going to update across all those aliases. If you don't use this, then you're actually going to be creating a new backpack object, and the old one is either lost, or if another variable points to it, then it's going to have the previous data of this right here. So that's getting into the details a little bit if you're fairly new, so we'll get into some of that stuff later on. Now we have another way we could do something like this, and in this scenario, we are creating a new list and pretty much iterating through every item in the backpack, checking if it's healthy, and if it is healthy, we're going to append it to this backpack list. And for some reason, I felt it necessary to put it in uppercase. So that's why it says kale chips in all caps right here. Next up, we have some more list comprehension essentials. We just have an example where we square a series of numbers from 0 to 9, and we're only going to do even numbers. So again, how to read through this: for I in range 10, so that's going to get 0 to 9. If I is even, or another way you could word it is if the remainder of dividing by 2 is 0, then what we're going to do is we're going to take that element, but we're going to square it. So the result is 0, 4, 16, 36, and 64, which coordinates to 0 squared, 2 squared, 4 squared, 6 squared, and 8 squared. Next up, we took a break from this list comprehension garbage and started counting elements. So here we're printing length, which will tell you the total number of elements in a list, and we're doing that for the healthy and also for the backpack list. As a result, we get 2 and 3, which makes sense. We got 2 healthy items and 3 items in our backpack. Just to call out, you might think of trying something like healthy.size or healthy.length, or you might even think healthy.count. None of these are going to work, and in fact, count does something totally different, which is counting a specific element. So for example, if you're trying to look for pizza, you can do it like so, and you're going to get the value 1 because backpack currently has only 1 pizza in it. Another example of this is counting pizza slices after we put 3 pizza slices into our backpack, and we get the value 3. You can use this count method to limit the number of items in a list. So in this situation, we say if backpack count pizza slice is less than 3, then we're going to add a piece of pizza, and you put a piece of pizza in your backpack for later. Otherwise, it suggests maybe you go to the gym. Next up, we talked about sets, and with these, you don't care about the order, and you don't care about the number because it's going to limit to just 1, so there's no repeating data. All you want to know is if the item is in the set or not. So you'll often do stuff like this: sword in backpack 2, and yes, it is. We use sets to our advantage in this next list comprehension example to count, and basically we're going to get all of the unique elements in the list, and for each one of those items, what we're going to do is we are going to count it and then print the name of it. So as a result, we get this output: 4 rubber duck, 4 slice of pizza, 4 sword, and so forth. Next up, we try a new variation, which is using counter, and you import this from collections and just say counter and pass in the list. It's actually a lot simpler in syntax, and it is better performance, so this is the recommended way of doing it. And in this situation, it's going to give you a dictionary that looks pretty similar to our list. So rather than having a list of lists, we have a dictionary with key value pairs where the key is the name or the thing we're looking for, and then the value is the number of times it was found. So that is your review. Make sure you understand at least pretty good everything in this list before moving on to the next section. If there's anything that you're really just struggling with, go watch the video again and write out all the code and try to understand it. And trust me, just doing it a few more times will make the difference and help you understand the concepts. So thank you guys, and stay tuned for the next one for the next section. Don't quit, stay with it, you got this. Hey, everybody. So you managed to pass stage 1 of this process, and now we're moving on to stage 2. We're going to start with some simple things just to work with more lists. Maybe you're sick and tired of working with lists, but lists are pretty foundational for a lot of stuff. So we're going to really try to understand them for what they are. Lists. All right, so let's just go with a new list, and we're going to call this Workdays, and we're going to try to insert data into the middle of this list. So let's say we work Monday, Tuesday, and heck, I should probably be consistent with my capitalization here. So we're going to capitalize the first letters, and then we'll just go to Thursday. So we skip Wednesday, Friday, and we're probably going to have to work Saturday. All right, so now what I want to do is I want to insert Wednesday into this list. And here's how you do it. Workdays.insert, and this is going to take 2 arguments. The first is the index you want to insert it at, and then the next is the actual data you want to insert. So let's think about what index we want to put it at. We want it to go right here. So imagine it was here for a second, Wednesday. So I'm just going to add that in there. What index is this at? 0, 1, 2. So that is the index we want to use to say where it's going to go. So back in this method call, we're going to say 2 and then pass in Wednesday. Wednesday, Wednesday, whatever you want to call it. Geesh. All right, print Workdays. Running this, we get Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. When you insert data, it shifts everything over, so the indexes are going to update. So keep that in mind if you're trying to refer to a particular element. If you start inserting data, that index is going to change. So to show you guys that, what we're going to do is, let's say we want to reference Friday. Well, before this, we're going to say 0, 1, 2, 3. So we're going to say Workdays index 3. If we take this and paste it after the insert, let's take a look at what happens. At first, it refers to Friday, but then after the insert, it refers to Thursday, which makes sense. If the length of the list increases by 1 and the last index is always length minus 1, well, then there has to be some shifting of indexes in order to fit that data in. So Monday and Tuesday is going to stay the same. It's going to be 0, 1. And then all of these are going to shift over 1 to give room for Wednesday. So that is how we insert data, but I don't particularly want to work Monday through Saturday, so let's talk about how we can remove some of those days, and that's what we're going to be talking about in the next video, so please be sure to slap that subscribe button, and I'll see you then. Hey, what's up, you workaholics? This video, I'm going to be teaching you how to remove workdays from your workdays list. So right now we're working Monday through Saturday, and okay, honestly, I probably do that, sometimes even more, but in reality, we should probably cut that down. So what I'm going to be doing is I'm going to be taking days out using a really cool method. Check it out. All right, so we'll print workdays before, and then after we print it, we're going to say workdays.remove, and this is going to take the element you want to remove. So in this situation, you need to know what the data is exactly for it to be removed properly. So you can say remove and type in, let's say we want to take Saturday off, like so, and then we'll print workdays after as well. So let's run this and see the output. Here it is at first. We got Monday through Saturday, and then we got Monday, Tuesday, Wednesday, Thursday, Friday, Monday through Friday. So that's cool. And with this method, when you say workdays.remove and put the left parentheses, you can see this little arrow here in Visual Studio Code with this IntelliSense pop-up window thingamajig. It says none, and that means it doesn't return any data. I will be talking about an alternative in the next method, but for now, just know the data is lost into the nether. That's where it goes. Another alternative is to use an operator. So what that's going to look like is you say del, and then you say workdays, and you use slicing. So what do you want to get rid of? Now we can do it by index. So we have 0, 1, 2, 3, 4, 5. So we can pass in a 5 here and run this, and it works the same way. The cool thing here, though, is you don't actually have to know what the data is. So there's different scenarios in which you might want to use one. If you have the data and you want to remove that exact data, but you're not sure where it is, you can just say .remove, pass that data in, and poof, it's gone. If instead you know what position you want to remove, but you don't necessarily want to put that exact data in, or you don't know what it is, then you would use del and pass in the index. So now what I want to do is teach you another method that will actually return the data you're trying to remove, so you could save it for later or do something with it if you would like. So stay tuned for the next video, and it should be pretty fun. Hey everyone, in the previous video I taught you how to remove data either by passing it into the remove method, you would pass the exact data, or you could use del and use an index to remove the data. But now I'm going to teach you another method, and that is actually the pop method. So if you say workdays.pop, you can see this takes an index. So it's similar in nature to the del operator that we just learned. So let's go ahead and throw in a 5 here. But the magical thing here is it returns some data. And what is that data? Well, it's actually whatever data is at the index you pass in. We're passing in a 5, so we're going to get the value Saturday. So what we could do is we could do something with that data, such as assign it to a variable. We can say popped, and we can do something with that data that's returned. So for example, we can print it by saying something like this: we just removed, and then pass in popped. Running this, and it says we just removed Saturday. Later on, I would like to try to use this technique to do something called backtracking. So imagine you're going through a maze and you go the wrong direction, and then you end up going back to where you started and going somewhere else. Well, this concept can be described in programming as backtracking. And using the pop method and stacks, we can do something very cool like this. So I actually did this in Java in another series where we created a maze solver, and pretty much if you took a wrong path, you would back up and pop that data off of the stack and go a different way. So you can see that code if you want in my GitHub, in my maze solver class, in my 30 days of Java, but pretty much it looks like this. You pop some data off and say we moved back, and you can keep doing that within a loop while true. So if it's not a valid path, then you just go backwards. So that's just kind of a future sight of what we might be doing in this Python series. But don't feel like you need to understand all that right now. We'll get into it later. Just for now, know that this can be used to get rid of data out of a list and return it so we can assign it to a variable, or we could just print it directly by taking this and putting it inside the print statement. Next up, I want to take a step back and talk about del again, so we can actually use this to remove slices of a list, and it's actually pretty useful, so stay tuned for that and be sure to subscribe. Guys hear that train? Probably not, it's far away, but there's a train outside. Hey everyone, in this video we're going to be talking about how to remove slices from a list. So we've been working with this data here where we have this workdays, and it's a bunch of days of the week, and then we added in Wednesday. I decided I'm just going to manually add this in just so we don't have to think about that extra step. So now we can get rid of this and just have to worry about one line here. And what we're going to do is we're going to say del workdays and then use slicing. So like I've mentioned, you can pass in an index here, and what that'll do is it'll remove the element at that index. So if we print workdays here, well, it's going to get rid of Saturday because that's at index 5. So we're left with Monday through Friday. But you can put a lot of different things in here. Similar to how we talked about indexing just with the list like normal, well, you can do the same thing. So for example, you could put a -1 in here to remove the last element. Running it now, it's another way to get rid of Saturday here. There is a lot of variety, so you can decide what you want to do, but the benefit of doing a -1 over a value such as 5 is that if we ended up inserting data into the list, that index 5 might point to something else than you're thinking, you know what I'm saying? But if you do a -1, you know it's always going to grab that last element. I mean, in theory, it could still point to something other than Saturday if you added something to the end of the list. So you could say workdays.append and pass in Sunday, and that's going to put Sunday at the very end, and then we would be removing Sunday. So there you go. But pretty much my point is you have options, right? You do whatever makes the most sense to you. You could also be a little bit more complex. So let's say you wanted to start at Wednesday and then take 3 days off. Here's how you would do that. Inside of the square brackets, you could say workdays.index, pass in Wednesday, and then that's going to be your starting position. And then you could put a colon, take this same expression, copy that, paste it here, and then say +3. So that's going to be the stopping position exclusive. So running this now, and we get Monday, Tuesday, Saturday, Sunday. So it got rid of Wednesday, Thursday, and Friday. So if you wanted to take 3 days off, that's how you would do it. You say what day you want to start on and how many days you're going to take off total, and boom, you get rid of 3 elements. Heck, maybe you just want to take the whole week off after Wednesday. In that situation, you could just get rid of everything after the colon, running it now, and we get Monday and Tuesday. So you have a really super long weekend, enjoy yourself, and then get back to work and start slapping booty. You know what I'm saying? That means working hard, by the way. Gosh, get your mind out of the gutter. So that's all I really wanted to do working with days of the week. I mean, you could generalize this to work with all kinds of different things, but it's really clear when you're talking about days of the week. Now what I want to do is I want to work with a list that possibly has some repeating data, and I want to go through that data and remove all of a particular element. So, maybe we have a backpack full of junk. We want to get rid of all of the paper clips that have been floating down in the bottom. That's a stupid example. So that's just a stupid example, but let's go through something like that in the next video. Be sure to subscribe and I'll see you then. Hey, welcome back everyone. In this video, I'm going to be teaching you how to remove an element from a list using a loop. So we might want to remove pizza slice from this because we got pizza slice in here like 4 times and ain't nobody need to be carrying loose pizza slices in their backpack. That's gross. Speaking of, one time my girlfriend... Would I say my girlfriend? Speaking of just carrying food around with you, one time I was with my girlfriend at the time and she was getting her ear pierced and I pulled out a sandwich from McDonald's out of my pocket and started eating it, and she was like really grossed out for some reason. So I think she was really questioning her decision and was like, ooh, maybe this guy's like a sociopath. I don't know. I thought it was fine, but anyways, that's just a little fun story, so don't do that. Just a little bit of dating advice for you guys. And now what we're going to do is we're going to remove pizza slice. So using the skills that we've been talking about, all you would do is say backpack.remove and then pass in some data such as pizza slice. It needs to match exactly with casing. So pizza with a capital P and a lowercase p are 2 different pizzas. And this is fine and all, but if we print backpack afterwards, we can see we still have a bunch of pizza slices in here. So what we need to do is we actually need to do a loop. And here's how you would structure this. You would say while backpack.count, pass in pizza, and if this for some reason is greater than 0, we got problems because we're going to get rid of all those soggy pizza slices. So then what you would do is you would say backpack.remove and pass in pizza slice. And make sure you got your words right. We got pizza slice, not pizza. So this should do the trick. So we can get rid of these lines here, and then at the end we can print the backpack. All right, let's run this, and you can see it effectively gets rid of all of the pizza slices. So this does the trick. The code is pretty, however, it might not be the most performant. And what I mean by that is every single time we want to remove a pizza slice, we're going to look through our backpack. And imagine if we had just one of those huge backpacks that we could just fit everything we ever wanted in there. We might have 10,000 items or 100,000. Let me just kind of explain what I mean. When we do backpack.count, it's going to go through there and count all of the pizza slices. So 1, 2, 3, 4, and it's greater than 0, so it's going to remove a pizza slice. So it has to find the first pizza slice, takes it and removes it, and then it does the process again, but this time starting with button. It scans through all the items, counts the pizza slices, notices it's still greater than 0. So then what it does is it'll go through and remove that pizza slice. So it finds it and removes it. And it repeats this process, pretty much iterating through our list tons and tons and tons of times, depending on how many pizza slices we have. So if you're just working with a small list, it's really not that big of a deal. I don't really worry too much about algorithm complexity for most of my applications because I'm working with such a small amount of data. Keep in mind that a computer processor is extremely, extremely fast. So iterating through this is like nothing. But if we have a large enough list, that repetitive iterating can actually cause our program to be slow, and we do not want that. So this is not really a scalable solution, but it does the trick. Hey everyone, in this video, I want to clarify one thing, and that is what it means to use square brackets after a list with a colon on the inside. And what you're trying to achieve with this depends on the context. I'll show you what I mean, but first let's just talk about normal slicing. So when you put a colon here, you can say where you want to start in a list. So you can say index 3, and you want to go up to index 6. That's going to grab the elements at index 3, 4, and 5. 6 is exclusive. So what we could do is we could actually print this. And running this, and you see we get fishing pole, pizza slice, none chicks, which is supposed to say nunchucks, but yeah, not none chicks. Anyways, a fishing pole, pizza slice, and nunchucks. If we leave off a number, we're pretty much saying, hey, we want to start at the absolute beginning. And if we also get rid of the ending number, we're saying we want to go to the absolute end. So running this now, and we get the entire list again. So it's effectively a way to make a copy of a list. This means that instead of printing this, we could actually assign it to another list. So let's say we have a backpack 2. These are going to have the same exact elements, but they are not the same object in memory. They're going to be pretty much a copy of each other. And I think we'll understand that in greater detail as we get into object-oriented programming, but for now, just know that these are separate entities. They just happen to be exactly the same in terms of contents. It's kind of like when you go through a house community and you see 2 copies of the same exact house. Well, when they were building these, they're not the same house. They just happen to have the same exact structure. So that's how this works. And I can prove that to you by using ID and passing in backpack, and doing it again by passing in backpack 2. So running this, and you get 2 separate numbers, meaning they don't take up the same area of memory. They're copies. So that's the first use of this colon here. You can do it on the right side of this expression to make a copy of the original list. The other use is if we put it on the left side, and that switches things up a lot. So let's get rid of this and go through an example like that. If I said backpack and just put a colon in here, here's what's going to happen. If I assign data to this, it's going to replace anything inside of that backpack list. So if I just made a list of 1, 2, 3, and then printed backpack, we can run this and we get 1, 2, 3. We can do this if we don't want to replace the object, we just want to change all of the data on the inside. So I can prove this to you here by printing the ID after, as well as before, to see if it changes. So running it, before it's a number, and then after it's the same exact number. So it's the same list, and if we went ahead and printed backpack, we can see that all of the data is replaced with 1, 2, 3. If instead we got rid of this and just said backpack, well, now we're going to replace the list altogether with a brand new object, a new list 1, 2, 3, and now we get 2 separate objects. So 2 widely different things happen whether or not you put that square bracket and a colon there. And right now it might seem like, it's not that big of a deal, like does it really matter? But later on you'll understand why this is important. If you're working with a list and you want to make a copy, or you don't want to make a copy, or you need to replace a list or just change the insides of a list, that's all going to be very important. And we're going to be using that throughout the series, so I thought I would just make a dedicated video to clear it up. So if you're using the slicing on the left, it's going to be the same object. If we're using it on the right, then it's going to make a copy of that object. If any of this seems a little bit fluffy or it's just kind of hard to work through in your brain, stay tuned for the upcoming videos because I will call out anything when it comes to the slicing just so we're all on the same page. So stay tuned and see you in the next video. Hey everyone, in this video I'm going to be showing you how to remove all instances of a particular element from a list, but specifically we're going to be using a for loop. So I'm going to do this in the way you would think to do it, but there's actually one issue, and I'll get to that in a second. So you would say for item in backpack, what are we going to do? We're going to say if item equals pizza slice. So we're going to check to see if it's that value, and if it is, we're going to say backpack.remove, and then pass in item. So running this, you can see we get exactly the result we want. But are we done? No, not quite. And that's because we're breaking one of the fundamental principles of being a not terrible developer, and that is you never remove items from a list when you're using a for loop in Python. If you're in another programming language, it would be the same thing, but with a for each loop. When you remove items from the list, it janks up all the indexes, and it's not going to work the way you would expect. And just to show you guys this, I want to print item here. So when we do this, we should see each item as we iterate through this list. But as I do it, we're only getting pizza slice here. What's going on? Well, it just so happens that I set up this list in a way that it looks like it's working, but it's really not working. And that was totally by coincidence, actually, because every other item is pizza slice, it's working fine. But if I went in here and added another item, so I went in here and said pizza slice here, well, now we run this thing And now we get pizza slice in the final result. Why is that not being removed? So when we remove, we're actually going to be shifting each item over one, so we're getting every other item here in this print here. So the fix for this is actually to use a copy, which is why I taught you guys how to do this a video or two ago. You put a square brackets and a colon, and now the indexes are going to be based off of this copy, and as we remove the items, the indexes don't shift. So now when we run this, hey, look at this, we get all the elements and the final result is correct. So whenever you want to remove items from a list with a for loop, you need to use a copy. Another common thing is to assign it to another list, and I'll show you guys how to do that real quick. So you could say new backpack, make it empty, and then for items in backpack, get rid of the square brackets. We don't need the copy anymore. We could say if item is not pizza slice, then we can append it to this new backpack dot append and pass in item. And then lastly, once we're done, we reassign backpack all of the stuff that was moved to new backpack. And printing this, we get the result we want. So you will see probably both of those variations out in the wild, so make sure you understand how both of them work. Stay tuned for the next video. I'm either going to show you another variation or move on to something else. See you then. Hey everyone, welcome. I'm going to be showing you how to remove all instances of a particular element from a list using list comprehension. Yeah, it's a bit of a mouthful, but essentially I want to get rid of all these pizza slices floating around in my list. I don't want a backpack full of pizza, that's gross. So what we're going to be doing is we're going to be reassigning backpack and use list comprehension. So the way I do list comprehension, or the way I think about it, might be a bit weird, but first I start with the loop. We're going to go through all of the items in the backpack. So for item in backpack, but we don't just want any of these items. We want only the ones that are not pizza slices. So if item is not equal to pizza slice, and then the only other thing is over here on the left, what we want to do with the item, and we're just going to keep it the same. So just type item. All right, that should do the trick. Running this, we get exactly what we want. Now, one thing to watch out for is this is going to give backpack a new object, a new list. So if you print the ID of backpack before and then again after, you're going to have two different numbers here. So running this, you can see we have two different numbers here, and that's because they are two different lists in memory. If you need to keep the same list in memory and just change the contents, you need to do slicing and put a colon, which is to say replace everything from the beginning all the way up to the end. In this situation, we're going to get the same number there, and there you go. That is how you would get rid of all the items from the list without replacing the list. So yeah guys, that's all I got for you on how to remove elements from a list. Stay tuned for the next video where we're going to be talking about something new. Hey everyone, in this video I'm going to be teaching you how to reverse a list. So there's probably two scenarios when you need to do this. One is you're doing it for some work project and you just need it reversed, and in that situation there's a very simple method you can use. Or the other option is you can actually implement a reverse function on your own, and I'm going to be showing you the algorithm on how to do that in the next video. So this one's going to be the real simple one, and if you need the extra juicy details, then go check out the next video. Alright, so when you have a list, each thing is sequential, right? So the order does matter for a list. This is different than the other data structures such as a set, which are unordered. So when you are working with a list, you might need to reverse it. And if you want to do that, all you have to do is say data.reverse, and it doesn't take any data and it doesn't return anything either. So because it doesn't return anything, it's safe to assume that the actual list itself is modified. So when you do this, you can then print data like so, and you will get the reverse list. Nice and simple. Now, if for some reason you had a list inside of this list, so let's just say 1, 2, 3 inside of another list here, running this, notice that that list itself does not get reversed. It stays 1, 2, 3, so it just takes that list as an entire entity and moves it to the front. Just keep that in mind. If you need to reverse everything, maybe there's a special function out there, or you might just need to iterate through any sublist, checking to see if it's a list. But we're not going to get into that right now, so we're just going to stick with a simple list. And the thing that I just wanted to call out here is that when you have a method that doesn't return anything, which you can see in Visual Studio here with this arrow none, you can't use that within a print because the thing passed to the print is whatever is returned. So if you were trying to run this to print the reverse, and you tried this here, and we'll just temporarily comment this out, running this and you get none. That's because the actual list is modified, not a new list is returned, and then you're pretty much just printing nothing. If instead you wanted to work with a copy and not modify the original, first just make a copy. So you'd say data copy, and then just make a copy of it by doing this. And then you would say data underscore copy dot reverse. And now you have both available to you, so you can get the original or you can get the copy. Running this just to prove it to you, here is the original one, 0 through 5, and this is the updated version, the copied version, where we go 5 to 0. So that is the reverse method. In the next video, I'm going to be creating a reverse algorithm, and that should be pretty cool because algorithms is a pretty fun subject. So stay tuned for that, and I'll see you there. Hey everyone, in this video, I'm going to be teaching you how to swap an element. And this is useful if you need to switch two locations in a list, or if you need to swap two variables. So let's just work with a variable for now, and then we'll show you how to do it in a list. This is foundational if you want to reverse a list manually. We're going to be doing that in the next video, so stay tuned for that if that's what you're looking for, if you're into the algorithm stuff. But for now, we're just going to work with swapping. So let's say we have two people, so me, and we'll go with you. And of course, you are a subscriber, right? That's what I thought. So if we wanted to switch these pieces of data, here's how you would do it. To do this, you can say me, comma, you, and assign it you, comma, me. And then after this, we're going to say print me and you. And what the heck? Let's go all out. We're going to print that before too, so we can see the magical transformation. And there you go. To start, it says Caleb and then subscriber, and then afterwards it says subscriber and Caleb. So doing it in Python is actually very simple, no harder than that. But there's actually another way to swap elements that I want to teach you that maybe you will see in code, or if you want to adapt this to another programming language. And that is using a temporary variable. So what we can do is we can say temp and assign it me, and then replace me with you, and then assign a value to you, but we can't use me because we replaced it, right? So we would just use temp. And this should do the same exact thing. And there you go, you can see the data is swapped. Now let's talk about how to do this with a list. It's a very similar thing, except we're gonna use indexes now. So let's say we wanted to replace some data in here, and I'm actually gonna add a little bit more. All right, so I expanded our list, and let's say I want to swap B with G. And this is the basis for a reverse algorithm. We're pretty much going to take all these elements and swap them with these elements over here, one by one, almost like a mirror, like flipped over. So let's just try to do this a little bit more dynamically. So to grab that B there, let's say we're going to grab it by index, and I'm going to use a variable for this just to generalize it. We would say index is 1. So data of index, that's going to be B. If we wanted to grab the second element from the right here, what we can do is we can actually say data of negative index minus 1. So maybe this sounds like black magic to you, so I'm just going to print this out so we can see it. We will print both of these elements like so. And printing this now, we get B and G. So that's how you grab those elements. You can see they're both 1 from the edge. If you wanted to swap them, here's how you're going to do it. Data of index, comma, data of negative index minus 1, and then flip them after the assignment operator. So data of negative index minus 1, comma, data of index. So yeah, very verbose, but it should get the trick done. And then we're going to print the data after as well. So I'll bring that down here and print it. And running it, before we got BG, and now we got GB, so it works. If you're a little bit confused on this whole negative index minus 1 thing, let me just explain real quick. Well, this here is index 1, but we can't just use negative 1 on the other side because it actually starts from negative 1 when we're going from the right. And the whole reason behind that is because if it was the same as on the left, we would have negative 0. But negative 0 and 0 are actually the same thing. There's no concept of negative 0 here. So since it's 1 base coming from the right and 0 base coming from the left, we actually need to shift it over 1 left by subtracting 1. So that's where the -1 comes from, and it should work for pretty much anything. So if we wanted to swap the first elements, all we would do is say 0 here. And running that, we get A and H and A. We can use this technique to our advantage by pretty much iterating through half of this list to swap the data. So that's what I'm going to be talking about in the next video, how to reverse this list, and maybe you can figure it out on your own. Give it a try and I'll show you the solution in the next one, so stay tuned. Hey, what's up everyone? This video, I'm going to be teaching you how to reverse a list manually. If you're just looking for the reverse list, you can just use the reverse method, so data.reverse. However, if you're doing this for an algorithm or data structure class, or you just want to know a little bit more detail of how this works, that's what this video is for. So we're going to be doing it manually, and we're going to be building off the principles of what we taught in the previous video, which is how to swap data. In Python, you can swap data by putting 2 variables on the left of an assignment, and then putting them in the opposite order on the right hand of the assignment. So let's go through an example where we are trying to swap this here with this here. This is index 1, this is index -2, which is why we have data of index, which is 1, and then negative index -1, which should give us -2. We can use this setup in a loop to pretty much swap one element at a time in a loop, going through each one until everything is swapped. So this is what it's going to look like. Let's get rid of these prints here. We're not going to need those anymore. And we'll get rid of that there. We will just say for index in range, and what's the range going to be? We're going to do length of data divided by 2. We only need to go through half of the list, otherwise we'll end up swapping everything back to where it started, which we don't want to do. Now we're using 2 forward slashes here because we want to use integer division. If we ended up just doing 1 here, we're actually going to get an error, and it says, well, first off, make sure you're not dumb and forget the colon. So run it now, and it says float object cannot be interpreted as an integer. So the range is expecting an integer, but when we do division, it makes it a float. So if we want to make it an integer, we just do 2 forward slashes. So that's going to crop off anything after a decimal. So if we had 3.5 as an example, it's just going to be 3. However, it should still be the same. We don't have to worry about an odd number, because if there is an odd number, that middle element just stays where it's at. So as an example, let me add an element here. In this situation, we have an odd number where we have 4 on the left and 4 on the right. We only have to worry about those 4 because this middle one is going to stay exactly in the same spot. So running this here, it should work. And what we're going to do is we're going to print data afterwards just to make sure everything is reversed. And reading it from the right, we get A, B, C, D, E, F, G, H, I. So everything is in the same exact order, it's just in the opposite direction. So that is how you reverse a list. It should work for even or odd list lengths. So if I got rid of one of these here, now we have an even number, we run it and it still works exactly the same way. Now, just as a side note, in terms of algorithm analysis, this is going to run in big O of n because we're just doing a few operations for each element in the list. If the list size doubles, we're not doing exponentially more work. We're just doing double the work. And for space complexity, this is an in-place algorithm. We are not going outside and creating another list. We're just modifying it from within. So stay tuned for the next video because we're going to review everything we've talked about since the last section, and it might just help conclude everything and make it stick in your brain. So I'd encourage you to go through that review. I'll see you in the next video. Hey everyone, in the previous video, I taught you how to reverse a list, and I'm going to be teaching you a new way to do that, and also a new concept known as a reverse iterator. So, I know I told you guys we're going to review, but I want to do one more thing before we jumped into that. So what in the world are we going to be doing? Well, instead of swapping the individual elements within a list, I thought, hey, why don't you just go through a list and copy them to another list, but just go from the opposite direction, you know, starting at the end, take the last element, put it at the beginning, and so forth. So that's what I'm going to be showing you in this video. So here's what we're going to do. You can iterate through a list using a for loop for item in data, and then you can print that item just to see it. So this is how you iterate through all the elements. And you can see it goes from A to H. However, what if we wanted to go from H to A? So we iterate through the elements, but just starting at the end. Well, for that, you can use this function called reversed. Now doing this doesn't reverse the list. It actually just creates a reversed iterator. So documentation, fun, right? but an iterator allows us to go through the elements sequentially. This is going to work the same way. It's just going to go through them the other direction. So looking into Iterator, it's an object representing a stream of data, or in other words, a sequence of elements, yada, yada, yada. We don't really care about all that junk. So here's what we're going to do. We're just going to print the elements now and see that it does in fact go in the opposite direction. So what you could do is you can make a new list, such as data reversed, and then just make it an empty list. And instead of printing the item, we can append it to data reversed. So data reversed dot append item. And then at the end, instead of printing data, we're actually going to print data underscore reversed. And running this, you can see it does the trick. And you can also confirm that data was in fact unchanged. So running this, you can see this is the original list and this is the new list. In terms of performance, this isn't a whole lot better or worse than the previous example I showed you in the last video. However, you do have to create a new list in this scenario. So if you have a really, really huge list that takes up a ton of memory and you have to copy all of that to another list, that might be a problem. So it really just depends on if you need to reverse the elements in place or if creating a new list is okay. In our situation, it's fine. It's probably not going to be an issue until you're working with a ton of data. So either one, whichever's clearer to you, go for it. And there's probably a quadrillion different other ways to do this. There's always a million ways to do things in programming. Hey, what's going on everyone? This video, I told you I was going to do some review, but apparently I am just full of lies and deception, and I just got to teach you another way to reverse data. It's like we're in a game of Uno, and we're in a competition to see who can lay down the most reverse cards, and I am currently winning because this is, I think, my fourth way. But each way introduces a new way of thinking, new programming concept, so it's definitely good practice. So what we're going to do is we're going to print data, and you can slice this thing, and when you do this, you can put the starting position and the ending position here, but you can actually put a third thing in here, and that is the step, the amount you want to go each time, or what direction you want to go. So we could put 2, for example. In doing this, it's going to skip every other element. But you can put negative numbers in here as well. When you put a -1, it's actually going to put this list in opposite order. So this returns a shallow copy, so you can assign it to a new variable. You can replace the variable that we have, or you could even change the content of the list we currently have up at the top here. So that's what I'll do here. So I'm going to get rid of the print, and we're going to use slicing to assign this to the whole list, like so. And before we run this, we're going to print data. Taking a look, you can see it is now in reverse order. So that's probably the simplest in terms of how much you have to write, and if you understand the syntax, then it's really simple. So we're pretty much just counting backwards from the list, and we're replacing the contents of the list by using the slice over here on the left. Again, I've told you this before, but when you do the slicing like this, it does not change the list, it just changes the content of the list. So you can print the ID of data, and you can do that before and after. And when you do this, you're going to get the same number twice. If you don't do the slicing, then it's going to actually replace data with a new list, and we're going to get a new object ID. Right now, it's not a huge issue either way, but later on when you're working with functions or if you have aliases for a list, that can come up and bite you. So just be really careful on whether or not you want to replace the actual list or just replace the content inside of the list. Okay, so I believe that is the absolute final way I'm going to be teaching you how to reverse a list. I don't know what got me all obsessed about this, but I learned the first way, then I was like, heck, we could do this in so many different ways. And every time I did another one, I was like, oh, I got an even better idea. Or I'd find some solution online. There's lots of different examples of reversing lists on Stack Overflow and the internet. And it seems anytime I'd look up a way to reverse a list, I'd find 2 different other ways to reverse a list. So there's just endless ways of doing something so simple. Now, I promise you guys, everything I got in my soul, that in the next video, we're gonna review everything in the last section of videos. So we're gonna make sure we solidify all of that knowledge. I'll see you then. Hey, what's going on everyone? Apologies if my wife in the background making a bunch of noise. She's playing Animal Crossing. Apparently it's really important. So anyways, we're going to be going through our review. I actually thought about teaching you guys how to reverse a list in another way, but then I figured I'd just wait and stop being a troll. So we're just going to go through this notes, which you can find up on my GitHub, GitHub/Caleb Curry. And the very first thing is inserting into the middle of a list. So all you do is you say insert, you put the index and the data you want to insert. So we'll go through this output starting right here. And you can see Wednesday goes in the correct position. If you want to take a day out, all you have to do is say remove. In this case, we removed Saturday and it's gone. We also don't have Wednesday anymore because I took it out of there. So since we're not inserting it, we just left it out, and removing Saturday deletes it and it affects the list. So it doesn't return a new list. You can also remove by index. So we can say del, pass in an index such as 0, which will get rid of Monday. Thank goodness. I'm just kidding. I actually like Monday. Where most people are like, Monday. Like Monday is the day to get fired up and, go into work and get stuff done. All right, anyways, you can also use pop. And the magical thing about this is it's going to return the thing that you popped off of the list. So we pass in the index 1. That's going to say Tuesday. So we can use that and say you removed Tuesday. We assigned it to a variable in this case and then used it later. You can also use del with slicing. So in this case, we remove the first two elements, index 0 and index 1. I've said this probably 37,000 times, but this is not inclusive, so index 2 is not included. It's exclusive. So doing this now, and you're going to get Thursday, Friday, and Saturday. Next up, we can remove the last two elements, starting 2 from the right, and go to the end, and that's going to leave us with just Thursday because we get rid of Friday and Saturday. So if these are our work days, now we're just down to working 1 day a week, which is pretty nice. Next up, we're going to remove all occurrences in a list. And here's what we're going to do. We're going to say backpack.remove to remove one of them. And heck, why don't we just do this in a loop? Looks like we have backpack.count, but I think a better way to do this would actually be while pizza slice in backpack. That way we only have to go until we see one pizza slice. We don't have to count every single occurrence. I'm going to run this just to get the most updated output. This first remove does remove a pizza slice, but only that first one there. If we want to remove them all, we use that loop, which does in fact remove every single occurrence of pizza slice. This is not the most optimized solution, so I teach you a better solution in this example right here. This one we're using a for loop, and we're actually using a copy so the indexes don't get messed up. And when we do this, we remove the element from the original backpack variable. So the items come from the copy, and we remove them from the original backpack. And I'm going to add a print in here so we can print backpack here just to make sure it works. And you can see it does. Now we also have a list comprehension version. So for each item in the backpack that is not equal to pizza slice, we're going to keep that item and we're going to replace the elements inside of the backpack list. So it stays the same object. We're just changing the contents, and we can print this to make sure it works. And it in fact does work. Next up, I teach you how to reverse a list. So we're going to go back to this original backpack list with a bunch of pizza slices. And the easiest is to say backpack.reverse. This will modify the original list, so it doesn't return anything. We just say backpack.reverse by itself, and then we can work with backpack just by using the backpack variable. So that will put it in the opposite order, as you can see here. Now, we just went through some other versions of this. I know I went a little bit crazy here, but we're going to learn all kinds of different ways to reverse. This one, we're actually reversing manually, so this is a reverse algorithm. You could generalize this to work with any programming language, and in fact, if you were working with other programming languages, that might be a good exercise for you. But pretty much, we're going to iterate through half of the elements, and if there is an odd number, we're just going to leave that middle one where it's at. And we're going to do that by using integer division, which is actually required for the range. And then we're going to take the item on the left and the item on the right, and we do that by saying negative index -1, and we swap them. That's how you do a swap in Python. You might need to use a swap variable or a temporary variable if you're using a different programming language. So we started with A through H, and now we end with H through A. So it seems to have worked. Next up, we talk about a reversed iterator. I use this to our advantage to also reverse a list. So for item in reversed data, which by the way, this doesn't make a copy, it's just going to go through that list one item at a time. And then what we do is we actually append it to a new list called data reversed, and then we compare the two right here. And you can see it does in fact reverse that list, which is these two outputs right here. Last up, we have reversed using slicing, and in this situation, you could just slice and just make the step -1, and you can replace the contents of the list using slicing on the left-hand side of the assignment, and then print data, which gives us this value right here. So it goes originally A to H, and now it's H to A. So those are a bunch of different variations of reversing. If you need to reverse nested lists, I'm sure there's a solution on how to do that on the internet. Just do a little bit of research. But for now, I think we've covered a pretty good basis. So that is your review of all the stuff we've talked about, lists and reversing lists. And now we're going to move on to a new section. You're probably sick and tired of lists, but good news, we're actually going to talk about them even more. But in this time, we're not going to be talking about reversing lists. We're going to be talking about sorting, how sorting works in Python, and we're going to end up applying that to lists. So if you're not sick of lists yet, by the end of this next section, you probably will be, but I do encourage you to get through it because as soon as it becomes annoying and you're kind of tired of doing it, that's when you're probably going to be learning the most and using the most concentration. So we're going to get through this and we're going to have a good time. Ain't that right, Aaron?
It's true.
I can't hear you. Come closer.
It's true. Stay with it, y'all. I'm doing all this editing for no reason.
There we go. She has spoken. Don't quit, guys. Be sure to subscribe, and I'll see you in the next one. Hey everyone, welcome. In this video, I'm going to be teaching you how to sort a list. And this is going to be using just built-in Python functions. So we're not going to be doing anything from scratch, no algorithm stuff in this video. So let's create a list. We'll call it Workdays. And we're just going to put the days of the week in here. So we'll say Monday, Tuesday, Wednesday, Thursday, and Friday. So we have a healthy 5-day-a-week balance, and what I want to do is I want to sort these. So we can say workdays dot sort, and this doesn't take anything as an argument here. It actually affects the list itself, so when we print it, we just use the original variable and it is modified. Running this, and we get Friday, Monday, Thursday, Tuesday, Wednesday. So obviously that's not in order, so what is it sorting by? It's actually sorting it alphabetically. So F comes before M, then T, and then for Thursday and Tuesday, it goes to the next letter. So H comes before U, and then lastly, Wednesday. Now, if you need to keep the original, just make a copy, which I've showed you how to do that. You can say copy, workdays, and then a slice. And then instead of sorting workdays, you would do copy.sort. We can go ahead and print copy and know that workdays remains the same. So if you need the original, that's how you would do it. That's one way of making a copy. In the next video, I'm going to be teaching you another function you'll often see for sorting data, and stay tuned for that. Hey everyone, in the previous video, I taught you how to sort a list using the built-in sort method for a list. So you would say something like workdays.sort. And this is fine, it modifies the original list, but there's actually another variation which will create a new sorted list for you. And that is the sorted function. So you pass in the list, so we would pass in workdays as an argument, and it's going to return a new list. So you can assign it to a variable, or as we'll show you, just put it inside of a print. So we'll say print, and running this, you can see that we get it sorted by alphabetical order. You could do another similar thing with numbers, so we could say data and just put some numbers in here. So I'll go ahead and pass data in here just to see what we get. And you can see it's sorted by smallest to largest. So when should you use the sort method as opposed to the sorted function? Well, if you're trying to make a copy of the data, sorted works nice and easily. However, if you're totally fine with modifying the original list, I recommend just using sort. That way you don't have to create a copy. Another thing about sorted is that when you go to invoke sorted, you can see the actual parameter list here is it says it takes an iterable. We haven't talked about iterables a whole lot, but it includes lists. So sorted can be used for lists, but it can also be used for other things such as dictionaries. So it's a little bit more versatile in that it can be used for various things, whereas list.sort is only going to work on that list. Overall, in my opinion, it doesn't make a huge difference on which you use. It just depends on if you need to keep the original data or not. That's all I got for you on how to invoke sorted. Stay tuned for the next video. We're going to get into some variations. So up until this point in the series, we've talked about various things you can do with lists. We talked about how to reverse them and also how to sort them. But do you have the skills required to sort it in reverse order? Well, if you've been paying attention up to this point, which, I mean, you probably haven't been, but if you were, you probably could figure this out. So why don't you give it a shot? I want these sorted from greatest to least, and I want that outputted in the terminal. Well, I'll show you one solution, and then I'll show you another. So the very first solution would be to sort it, and then reverse it. So we could say data.sort, and then data.reverse. Honestly, it's really not that hard. And then we just print data. So hopefully you're able to figure that out. It's not too crazy. And now the largest is on the left and the smallest is on the right. But there's another variation using the sorted function that I wanted to show you. So we can say sorted, pass in data, and another argument, a named argument, is reverse, and it can take either true or false. So obviously we're going to pass in true here, and this is going to return a new sorted list. So we'll just print that, or if you wanted to, you could assign it to a sorted data. And running this, and we get the data from greatest to least. So if you're working with strings, it would be Z to A as opposed to A to Z. You can literally just think of it as however it's sorted normally, and then you just reverse that list. So that is another way to do it, and hopefully not too complicated and that you understand each piece of this. Next up, I want to talk about sorting strings and how to modify the default behavior. Stay tuned. Hey everyone, in this video I'm going to be showing you how to modify the behavior of a sort. So right now we have this list of strings, and you can see there's a bunch of different variations on capitalization. And when we sort this by saying strings.sort, and then we'll just print it afterwards, you can see that the capital letters always come first. So A is top priority here, that's first, and then it just keeps going until the first character is lowercase. And in the situation where we have a match, such as ABC, but the casing of C is different, the capital comes first. And then lastly, we have the all lowercase. If I wanted to ignore capitalization and basically consider A uppercase to be the same thing as A lowercase, I'm going to be showing you how to do that. And to do this, we can pass in a special thing in here called a key, which is basically what function to invoke on this data. So we say key equals and then str for string dot lower. And running this now, the output's a little bit different. You can see here, both of the A's are up front, whereas before, A was after all the uppercase characters. Those come first because it's a single character and A is the first character in this list, so they're going to go up front and to the left. So they're going to be considered to come first. Next up, we have a bunch of variations of ABC, and it doesn't really matter what order they're in because they're all considered ABC. By default, it's just going to keep the order from this list. You can see the lowercase one came first, then the uppercase, then the one with the capital B, and then the BC, and then the A. So that's exactly the same pattern we have here. So that is how you sort by using lowercase. You could also do upper if you prefer, but it doesn't really matter which one you do because the actual data itself stays the same. It's just talking about how we're going to compare the data. So we're not actually lowercasing all of the data. You can see the casing stays the same as the original, but the order when sorted is different. And that's a very important thing to understand. Also notice that we're not invoking the function here. We're not going in here and putting parentheses like so. There's no parentheses, we just put the function name. The only parentheses is the closing for the sort. So just put the function name after the equal sign. Next up, I'm going to be teaching you another variation to sort by string length. Be sure to subscribe. Hey y'all, welcome back. In this video, I'm going to be teaching you how to sort this by string length. So you can see we have a bunch of random data here, and I want all of the single characters to come first, and then the longer strings to come at the end, such as hello. So let's see if you can figure out how to do this using the knowledge we talked about in the previous video. Give it a try, and now I'm going to show you the solution. So we can say random.sort, and this can take a key. So we say key equal, and then len. So the len function, that's going to give you the length of the string, and then that's going to be used to determine what order to sort this data. So running this after, we can say print random, run it, and you can see it works. Another thing is that you can use the key inside of the sorted function as well if you prefer. So I'll show you that now. We'll get rid of this here, pass in random to sorted, and then key is len for the length. Run this and it works. Hey everyone, in this video I'm going to be teaching you how to sort numbers, I'm not even going to try to pronounce this right, lexicographically. In other words, we're going to compare them as if they are strings. So this actually took me some time to really comprehend. So let's just go through a simple example. When you sort these numbers, you're going to get an output like so, where the smallest number is on the left and the biggest number is on the right, and it goes from least to greatest throughout. This is the natural ordering for numbers, and it's the way you would expect it to work. However, if you were to interpret this data as strings, it would be a little bit different because it's going to look at each number and compare them as if they're just a character. So in that situation, 111 would come right before 12 because it's going to look at the ones, put them together, and then it's going to go to the next character and say, oh, this one comes first, next up we have 12. So it's a little bit of a weird ordering, but sometimes it's important and you might just want to get some practice on that. So if you want to see what the output should look like, one thing you could do is you could make all of these as strings and then compare them. If the data type of the data is string, it'll automatically do it lexicographically. So here is the code to do that. I just typed it out ahead of time because honestly, it takes forever to put all these little quotation marks. But pretty much I put every single piece of data in here as a string, exact same numbers. I sorted it, and then I printed that data. So here's what it's going to look like. In this case, we're working with strings, and I want to do it on numbers, but for now we can at least understand the ordering. Going back to the example I used, we have 111 followed by 12 followed by 222 because it's first just looking at the first character. So all of the ones here are going to be grouped together, then all of the twos, then the threes, then the fours, and then the fives. If there happens to be a conflict, such as with these two, the second character, we have a 1 and then a 2, the 1's going to come first. So that was probably the absolute worst explanation on how we're trying to sort this data, but essentially we want to compare numbers as if they are strings. And doing this is very easy using the key parameter of sort. So we can say numbers.sort, key equals, and we can convert it to a string by just saying stir. So this is the equivalent of converting a number to a string like so. So it's going to do that for all of the elements and use that for comparison, and it's going to affect the original list because we're using the .sort method. So we can just print numbers like so and running it, and we get the exact setup we want. But notice here, the actual data here is still numbers. We're not changing everything to a string. It's doing this for the comparison, but not for the actual data when we output it to the console. So that's how you do lexicographical sorting. In the next video, I'm going to be teaching you how to take strings and sort them as numbers. So stay tuned for that. Hey everyone, in this video, I'm going to be teaching you how to take a series of strings, as well as true, false, a few numbers, and even a comparison. And I want to sort this data as if it is all numbers. So how to do it is actually easy, but then we have to understand what's going on. So what we're going to do is we're just going to say stuff.sort, and we're going to use a key of float. So that is how we can convert it to a float, which will be used for the comparison. When we print this data, it's going to maintain its original type. So the next thing we need to do is figure out how this stuff is being compared. You can see we have -1 coming very first, and then we have, false, some zeros, some trues. What is going on here? Well, the very first thing I wanted to show you guys is that we're using a variable. Age is 5, and we're comparing it to this. Well, this is going to evaluate to true because 5 is less than 30. So that's where one of these trues come from. You can see we have one true in the original list, and we have an additional true in the output. So the expressions are going to evaluate. The values are going to stay the same. So if it was a Boolean such as true or false, it's going to stay a Boolean true or false. If it's a number such as 0, it's going to stay a number like so. If instead it's a string such as this one here, 0, it's going to stay a string. Well, this data is going to be sorted from least to greatest, and the important thing to understand is that anytime you have a true, it's considered to be a 1. Anytime you have a false, it's considered to be a 0. So going from left to right, we have -1, 0, 0, 0, 1, 1, 1, and then the rest is just strings that are being interpreted as numbers. So that is how you would do a numerical sort on a bunch of data, but notice in here none of this data is a string that could not be converted. So for example, if I put a string in here such as hello, man, Python is gonna flip. Running this, we get an error, could not convert string to float. So everything in here up to this point besides the hello, get rid of that. Everything now can easily be converted to a number. Thank you guys for watching. I really appreciate it. We've talked about a lot of sorting stuff, so I want to take a moment just to review everything we've talked about in this section before we move on to the next. So stay tuned for the next video because we want to have all the info solid before we move on to the next section on input and output, which should be a whole lot of fun because that's where we can start making actually cool applications. Well, cool is pretty subjective, but I find it pretty interesting, so stay tuned and I'll see you then. Hey everyone, welcome. In this video, we're going to be reviewing everything we've talked about when it comes to sorting in Python. You can get this code if you'd like by going up to GitHub/Caleb Curry in my Python repo and going into the Python or Python programming subfolder and then grabbing sorting. So this is the file that we're going to be going through. So the very first thing is I show you the default sort using the sort method. When you do this, it modifies the original list and does it alphabetically in the case of strings. So F is going to come first, and then M, then S, and then we have two T's, so the next character is considered H comes first. We do the same thing with numbers, so we make a list of numbers, and then what we do is we sort the numbers and print them, and you can see it goes from this completely random order to from least to greatest right here. If you want to sort but you don't want to mess up the originals, you can do it with a copy. So the easiest way to do this is to use the sorted function, pass in the list you want to sort, and you can print it or assign it to another variable such as numbers sorted here, and then go ahead and print it. So we print the original as well as the new to show that both are accessible. I also show a light variation where you can actually just pass in a list to sorted and assign it to a variable. So if you have some data and you just need to sort it real quick, you don't have to put it to a variable first. You can just pass in the list to the sorted function. There you go. Next is to sort in reverse. The most obvious way is to just sort the data and then invoke the reverse method, and that will reverse the actual data so you can print it then and see that the data is now reversed. However, another option is to pass reverse equals true to the sorted function, and in that case we get the same exact result. So either one works. I prefer this. I think it's more concise and easier to read. Next up, we talk about case insensitive sorts, and it also introduces this key parameter. So you can put any function here that's going to modify the data. In this case, it would lowercase the data, but the interesting thing here is the actual data doesn't get changed. It just does that for the comparisons. So the original list data stays the same, but it's sorted as if everything is lowercase. So we get the A's up front together. Next up, we sort by string length, and you can use the len function for that. In that situation, the single characters come first, and then we have the long string at the end, hello. Next up, we talked about lexicographical sorting, and in that situation, we are going to sort numbers as if they are strings by converting them to strings for the comparison. And in that situation, we're going to get an output like here. And then the last thing I showed was how to do numerical sorting with stuff that is not numbers, but everything in here needs to be convertible to a number. So only Booleans or expressions that evaluate to a Boolean or strings that have numbers in them. That's all that's allowed. And then we use float for the key. And that'll give us this output here. As a reminder, false is considered 0. That's why false comes here. And true is considered 1, which is why it shows up here. So that is just your quick review. Make sure you understand everything in this sorting section because we're going to be talking about basic IO in the next video, and that should be pretty cool. I'm pretty excited. Hope you are as well, and I'll see you then. Hey everyone, welcome back. So I was talking to my counselor the other day, and she said, "It looks like you have a serious fear of marriage. Don't you see it?" I said, "I can't say I do." And she said, "Exactly, that's the problem." Anyways, whatever she meant by that, it went totally over my head, so I'm just going to go back to what I was doing with Python. So we're going to start working with strings and how to get user input and work with those strings. To start, we're going to talk about splitting data. So the whole point of this video is how to convert a string into a list. So here's an example. Let's say we have a string. We'll just say message, and we'll just put some words in here. So what you can do is you can take a string like this and you can split it out into individual data pieces inside of a list, splitting it by the spaces. So that was just a really verbose way of saying individual words. All right, so here's what it's gonna be like. Words is assigned message.split. Don't put anything in the argument list, and then what we're gonna do is we're going to print words, and I'm way too zoomed in here. All right, that's a little better. And running this, you can see we get each of the words separated by commas inside of a list. So the list now has 6 elements, each one being a string, and it's a series of words. So the data that it's splitting by is the space. However, you can customize that by passing an argument to split. So on Mac, if you want to reopen that window saying what to throw in here, it's Command-Shift-Space. And it says sep, which is short for separator. What we could do is we could separate by comma. In this situation, it's not going to split anything, but if you're working with, say, a comma-separated list of values, which is a common thing you might need to do, it might look like so, where I'm just going to replace each one of these spaces with a comma, and the important thing here is it only cares about a comma, doesn't matter about a space after the comma. If there is a space after the comma, it's just going to consider that to be part of the next string, and I'll show you an example of that here. So running this now, we have pay, and then we have attention with a space at the left-hand side of it. That's coming from right here, and then the rest of the words here. Now, if you had a bunch of words in here and you didn't want to have to, have a space at the beginning of every single one, all you would have to do is update the split separator to have a space there, and it'll get rid of the space. So now running it, you just have the individual words. Now, a long time ago, I taught you guys how to make strings on multiple lines, and that was in my previous series. So when you're doing that, you're actually going to have 3 quotation marks at the beginning and 3 at the end. And in this situation, you can break anything down to the next line, and it's totally fine. So my challenge to you is to figure out how to break this up by line. So what would you put in here? And I'm going to give you guys the solution in the next video, so stay tuned for that. Also, be sure to utterly smash that sub button. I don't care about the like button. No, I like the like button too, but mainly the subscribe button, right? Okay. Hey everyone, in this video I'm going to be teaching you how to split a string out by its lines. So by default, when you use split on a string, what it does is it returns a list and it splits it by the individual words. So it separates it by spaces. Anytime there's a space, that's considered a new thing to add to the list. So if you wanted to split it by line, you just have to figure out what is dividing the lines. So that way Python knows when to split it. And anytime you go down to the next line in Python, or literally any programming language, there's a new line character. It's represented by a \n. So if you want to split the data by that, then hey, why don't we just pass a new line character into split? And that's exactly what we're going to do. So we pass in a new line character, and hey, take a look at this. We have the first line, the second line, and the third line. So it seems to be working. Now, as a side note, whenever you're using the triple quotes and you want to format it on multiple lines, but you don't want to actually put that new line character in there, you can actually put a \, to get rid of it. So in this situation, we run this, and now pay attention to everything is all together, and it's actually missing a space here because there isn't a space after 2. So you can customize it however you want. One thing you might see pretty commonly is you might see this brought down to the next line, so everything is nice and pretty on the left-hand side, and then just getting rid of that new line character on the first line. So now everything works exactly the same way, but our strings are nice and formatted, all in the same indentation level. So that is how you split a string by line. Next up, we're going to learn to use split to get user input and put all that input into a list. So yeah, that should be pretty cool, so be sure to subscribe, and I will see you then. Hey everyone, in this video I'm going to be teaching you how to get a series of user input without having to use a loop. So the next video I'm going to be teaching you how to use a loop, getting data one line at a time. This one is going to just be the simple solution, which, speaking of, this video is brought to you by... Nah, I'm just kidding. But we're going to get back to it, and here's what we're going to do. We're going to get input, and this is going to be stored in a variable, like so. And whenever we're getting user input, it's good to give them a prompt so they know what the heck to do. So let's give them an example of what the input should look like. So we'll just give them a nice message here. Tell us your favorite veggies. And now let's give them an example input, like so. And we'll say kale, tomato. I really don't know if that's a vegetable, but whatever. Cucumber, broccoli. All right, so you can see the data is separated by spaces, and that is how the input is going to be expected. So running this, you can see the example input down here, and when they put in the data, they should do it by spaces. And if you really want to be specific, you can specify that separated by spaces. So then what we do is we take their input and we split it. So what we can do is we can say faves is data.split. By default, it's going to split by spaces, so we don't have to pass anything in. And then we can iterate through this list and print the data back out. So we say for food in faves, print food. And we could also put a message here. You said, like so. All right, so let's give this a try. Let's exit out of this one and run this. Kale, tomato, cucumber, broccoli. What are my favorite vegetables? Well, I really like pizza, asparagus, squash. Man, I literally can't even think of any vegetables. This is ridiculous. Grapes can be green. Let's go with grapes. All right, those are all of my favorite vegetables, and we hit enter, and it prints them out one at a time. Now, obviously, this is not the perfect solution because, for one, the user has to input everything exactly as is expected. And just as a tip for all you new developers out there, the user never puts the information in correctly. They will always do it wrong. So if you want to get into data validation, you can do that, but we're also going to give a better solution in the next video. Another thing is this does not work with spaces. So if we run this again, check this out. If I put in bok choy, well, hey, it thinks it's two different vegetables. So we get bok and then we get choy. Cute twin names, honestly. So instead of getting all of the data in one string like so, wouldn't it be cool if we could just have them type in a vegetable, hit enter, and then type in another vegetable, hit enter, and just do that until they don't want to put any more vegetables in? Well, hey, I'm going to teach you how to do that in the next video. We're going to create essentially an infinite loop that you can break out of, also known as an indefinite loop. It's just going to keep running until it stops, which, I mean, if you think about it, that's how all loops work, but it's going to stop with a specific input. So stay tuned for that. Hey everyone, in this video, I'm going to be teaching you how to get user input within a loop. So you can consider it an indefinite loop that's just going to keep going on until we tell it to stop. So we can get unlimited user input, essentially. This is a much better solution than what I have here, which is where you get all of the input on one line, and then we split it into its individual parts. All of that works. It's not really ideal because when you're in here, you have to space things out by spaces, not commas. So if I go in here and type some stuff out, if I accidentally put a comma in here, it's going to mess up the data. And if I accidentally hit enter, well then the program ends. So it's really not ideal. And you can see the comma right there attached to tomato. We don't want to be eating no tomatoes with commas. So we're going to redo this code and we're going to use a loop. What are we going to keep here? We're going to keep the for loop at the end to actually print the data because our goal is to get it in a list just like this solution here. We're going to change the prompts here. So let's just go up to the top and we're just going to say something like hit enter after each food, cue to quit. And if you want, you can actually take part of this and put it on a new line if you'd like. And the easiest way to do that is to just use another print. So we'll say print, pass that in, and save it. All right, so now we're going to create a loop, and the way we do this is say while true. And if you don't want the world to explode and then implode afterwards, you need to break out of this loop. So anytime you say while true, that's going to create an infinite loop. Infinite loops equal bad. Don't do that. So we need to have a break somewhere in this. So I'll show you where to do that, but for now what we're going to do is we're going to get user input. So we'll say something like data and assign it input. And just be careful what you name this variable here. My first thought is always to call it in, but that's a keyword and we don't want to do that. So get rid of that and let's just go with data. And what we do now is we actually check the data. So we say if data is equal to Q, if it is that character, we are going to break. That is where the break keyword goes, and that should do the trick. The only other thing is if it's not equal to Q, we need to add it to a list. So we need to create a list and then append it to the list. So we'll say faves.append and pass in data. Up here, we're going to create that list. So we'll say faves and just create it as an empty list. So this should do the trick. The only other improvement I got is to actually lower this data such that if they put an uppercase Q, it also quits. And let's just hope that there's no foods out there called Q because that's just gonna mess everything up. So to lowercase this, we're going to say stir.lower. All right, now I'm gonna zoom out so you can see everything. A little too far there, Caleb. Back it up. All right, so this is all of our code. Let's run it and give it a try. Hit enter after each food. All right, we'll say kale, spinach, and asparagus. Hit enter, and now we're done. So we're going to hit Q, enter. And look, it worked. And the benefit here is we can use vegetables with spaces, whereas the previous example using split would consider those to be two different vegetables. So going through an example of this, we'll run it. And let's say we put in bok choy and then we quit. It says you said bok choy as one element. So yeah, we just won. That's how you get data within a loop and append it to a list. Next up, we are going to be learning about a very important data structure in computer science, and that is a stack. We're also going to touch on a queue after that. So these are kind of fundamental pieces for more complex programs. I'm going to be teaching you how to implement those using a list. And don't worry, I'll keep it simple if data structures seem a little frightening. It should be pretty fun, so stay tuned and I'll see you then. Hey everyone, in this video we're going to be talking about stacks. Now I know this isn't a computer science class, so I'll try not to bore you with the entire background. However, let's just talk a little bit more generally about this concept known as a data structure. So a data structure is just a way of storing data. You know, we've talked about lists. We can use lists to store data. Well, there's other data structures we could use as well. We could use a set, or we could use a dictionary, and so forth. So there's a ton of different ways to basically structure data. And one of those ways is known as a stack. And we're actually going to use another data structure, the list, to create a stack. So consider a list like a fundamental building block, and we're just going to just use it a certain way to create a stack structure. So what is a stack structure? Well, the best way to understand it is to literally visualize it as a stack of something. So let's say we have a stack of plates. You can add plates to this stack by putting them on the top. And anytime you want to get a plate off of the stack, you take it off of the top. Only psychopaths pick up the plates and take them from the bottom. We're not going to do that because that's not how a stack works. Hey, you mind grabbing me that SQL book?
Sure. Let's see, where is it? SQL, there we go. Here you go.
That's not how stacks work. So you can consider it like so. We have some stack and we're going to use a list to represent this. And what we do is we add an element to the stack. So we say stack.append, and then we pass some data in this like a plate. So we will call this plate A. And then what we're going to do is we're going to say stack.pop. And this is going to remove that item and return it. So what we can do is we can print it to see that it was removed. So we run this and it just says plate A. Nothing too crazy. We're literally just using a list like we've been. However, let's go through adding another element just to see the order of this. So stack.append, and we'll say plate B. And we will run this stack.pop one more time. So like so. And running this now, the output is plate B, plate A. So visualize this in your head. You set down plate A first, then you set down plate B on top of it. If you want to remove these plates, you start from the top and grab plate B, then you grab plate A. So now what I want to do is I want to modify some code we wrote earlier where we're basically getting user input to create a list of favorite vegetables. So this is what our code looks like. We ask the person to enter the foods they like, and we do this in an indefinite loop until they type in Q. But what I want to do now is I want to give them the option to remove food from the list as well, not just add food to the list. So instead of saying Q to quit, what we can do is we can actually say R to remove, then Q to quit. And we can check for both of these. So you can see by default we're appending the data, but we could actually check another case. So we can say elif stir.lower data is equal to R. Now we're going to remove the data. So what we do is we say faves.pop. And we can even make a little print statement so it's clear. And we'll just say removing and then whatever the element is. So what's going to happen now? It's going to remove the data, but then it's going to go down to the next line and append data. We don't want to do that. We're using R to remove data. So what we need to do is we actually need to use another keyword, continue. And what this is going to do is it's going to continue to the next iteration, skipping anything that comes after this line. If you want another way to think about it, you could just use an else. So it would look like this. And then just indent this here. So you can think of it as three cases. The first case being where the data inputted is Q, the other one where the input is R, where we remove data, and then lastly is the default case where we don't put Q and R, and that is the data being added to the list. So let's just run this, see if anything is broken, and I gotta get rid of these three quotation marks. So let's just run this and see if everything is working. All right, hit enter after each food, R to remove, Q to quit. So we'll say salad, and I think it's working, but let's just print each time so that way we can see. So at the end of each loop iteration, we'll just update the people by saying print and passing in faves in here. All right, so that way each time we put in data, we can see it. So we'll start with kale. There we go, we got kale, spinach, and you can see it's adding it to the list here. Broccoli. All right, now we want to remove some vegetables because I just added something, broccoli, and I'm starting to second guess. I'm not sure I want that in there. So all we have to do is type R, and you can see it removes broccoli. So where does the stack component come into this? Well, it's which side is being removed. So we add in broccoli, consider putting broccoli on the top of the stack if everything was stacked from bottom to top. So kale is at the bottom of our stack, consider it like a sandwich, kale's on the bottom, spinach is on top of that, and then broccoli is on top of the spinach. So if we want to remove broccoli, we just take it off the top, which is done with pop. And then what we can do is we can continue to add data. So we'll say bok choy, and adds it to the list. And you can see that we can continue to work with this program, adding and removing data until we're completely satisfied. And when we hit Q, it prints everything in the list at the final state, which is this right here. All right, so let's just take a moment to summarize here and make sure we understand everything. The stack is an example of a data structure, and it's a very simple data structure because we don't actually have to implement anything new. We're just using a list that already exists. It just matters how we use the list. We always add data using append, and we always remove data using pop. That is how we use a list as a stack. The stack itself can be visualized as piling things on top of each other, putting kale first, and then adding spinach on top of it, and then lastly adding bok choy on top of the spinach. If you need to remove anything, you have to remove from the last element that was added in, which in this case is bok choy. So another way to think about it is the first item in is the last item out. So it's first in, last out. Or the last item in, bok choy, is the first item out when you're trying to remove data. So last in, first out. So you will hear the stack data structure as first in, last out, or a last in, first out. FILO or LIFO. Kind of stupid acronyms, however, it does express what we're trying to achieve with the stack. Then the only other thing to summarize is just understanding this code. We have essentially three cases, the first being Q, which is just quitting, the next being R, which is to remove data using pop, and then lastly, if neither of those are the case, then we add the data to the list and print it each iteration to see the progress. And then finally, when we're done, we iterate through the whole list, whatever's in there, and print it. Oh, that was a lot, so apologies if I rambled, but I really just want to make sure you understand this fully because we're going to be using this a lot. And if you're wondering when you might do something like this, an example is anytime you take a path and you need to backtrack to where you started, you're going to use a stack data structure. So in this example here, you can see we added broccoli, but then we're like, I'm not so sure I want broccoli, and we backtracked and went back to just spinach. So I actually used this data structure for a maze solving algorithm. So you go down a path and then you're like, oh, there's a wall there. So we need to back up to where we just were. A lot of the algorithms that are classified as backtracking algorithms are going to be using a stack to actually go through the algorithm process. So that's all I got for you in this video. Next up, we're going to be talking about a variation called the queue. And no, not this kind of queue. So stay tuned and I'll see you then. Be sure to subscribe. Hey everyone, this video we're going to be talking about how to use a list as a queue. So the easiest way to understand the queue data structure is actually first to understand the stack data structure. We built all of that in the previous video in pretty good depth, so understand those foundations and then come to this video. So to create a queue, what we're going to do is we're just going to use a list. So we'll create a variable and call it queue. And that's how you spell queue. It's Q-U-E-U-E. It's not pronounced Q-E-U-E, although that is what my wife tends to say whenever she says queue for some reason, I don't know. So what we're going to do is just assign it an empty list to our Q-E-U-E, and then we'll say dot append and pass in data 1. And then we'll do that again, but now we're going to do data 2. Now with a stack, when we removed these, we would do it by saying queue.pop with no arguments, and that is always going to remove the last element. So to see that, what we can do is we can print the queue, and then we can pop off the data and print queue one more time, like so. All right, so we start with this data. We have data 1 and data 2. When we pop the data, it removes the element with the highest index farthest to the right. This is the default behavior of pop, and this is how we would create a stack. But when we were working with a queue, it's actually going to remove from the opposite end. It's going to remove from the left, so the lowest index, which is always going to be 0. So now when we run this, it starts with data 1, data 2. We remove an element, and we're left with data 2. So you can see data 1 was removed from the left. And if you want to visualize this, here's how you think about a queue. It's like a line for a roller coaster. Everybody gets in line, waiting for like 24 hours, and the first person in the line is the first person to ride the ride. So that would be data 1 in this case. We added that data first. When we pop the data, it's going to remove data 1 first. So that is how a queue structure works. So the only difference is that when we say pop, we have to put a 0 in there to grab the item with the index 0. So let's modify our code that we created in the previous video to add vegetables to our favorite vegetable list, and we're going to turn it into a queue structure rather than a stack structure. So get rid of all this junk and go back to our code that we had. All right, so the only thing is instead of pop, we have to say pop 0. And let's run this and try it out. We'll add some food into this, spinach, kale, broccoli. And now if we want to remove an element, the only way to remove is to remove spinach first, and then kale, and then broccoli. So we say R, that will remove spinach from the left. We say R again to get rid of the kale. Now we're just left with broccoli. If we add another element, it's going to add it to the right. So for example, we add bok choy. Now we have broccoli, bok choy. So that is how a queue structure works. Hopefully that was helpful, and now you understand the stack in the queue. For a queue, it's first in, first out, or FIFO. Or you can also think about it as last in, last out, or Lilo, which, you know, if you had a kid named Lilo, you could just call him Q. It's a cute nickname. Save you a lot of time too, because Lilo is 2 syllables, Q is only 1. But not a whole lot of people call Qs Lilos. Rather, you often hear them as Philos, first in, last out. And then for the stacks, you'll hear first in, last out, or last in, first out. So yep, that's all I got for this, and stay tuned for the next video. What's up everyone? In this video, we're going to be reviewing everything we talked about in the last 6 videos or so, whenever we did the last review. So we're going to be talking about split, getting user input, and the stacks and the queues, just to get everything, you know, permanented in our brain so we can move on to the next section. So let's just run through this code and see what we get. So the very first thing is how to split data, and by default, it's going to split it by spaces. So pay attention to each word that I say is split up 1 word at a time coming from this message string. You can change the default behavior by passing in some character or some sequence of characters into split, and that's what it's going to look for. So in this situation, it's looking for a comma. So when we say this is important data, we split it by commas, and this might be what a comma separated value file would look like. And that is how you would get a list like so. You can also split by line. So anytime there's a new line character, it's going to be a new piece of data. And you can do that using \n. We print the message here just to see how it's stored so we can see where the new line characters are. And just as a reminder, anytime we see this backslash here, it's basically saying ignore that new line character. So you can modify how the string is stored by putting the backslashes there. So you can see that everything is on its own line here, and then each line ends up being an element in the list. Next up, we get input using split. So what we're going to do is we're going to tell them to split data by comma and a space. So here's an example of kale, bok choy, Brussels sprouts. And this is where we get input here. So let's go through an example input. Broccoli. And I literally failed because I just hit enter. So there's a downfall. If they accidentally hit enter instead of putting a comma and a space, well, then it just ends. So the obvious fix for that is to use a loop where enter will actually be a new element. So that's what I show you guys here, where we basically make an indefinite loop that's going to end with the letter Q to quit. And we're going to lowercase it such that if they put a capital Q, it works just fine. We're going to get input. And if they put Q, we break. Otherwise, we append that data to the list. So here's an example of that. We can say bok choy. Pretzels. I don't even know if that's spelled right. How do you guys spell pretzels? All right, we good. Sorry, guys, I'm terrible at spelling, so just trying to learn, you know. And then lastly, my favorite vegetable of all is burrito. And then we'll hit Q to quit. And all of the feuds are bok choy, pretzel, and burrito. Now, next up, we go through stacks and queues. So with a stack, everything that we add is going to be removed first. So it's like a stack of plates. We have to take the top one off to get to the lower ones. So we can add foods in here. Bok choy, pretzel. And then if we remove an element, it's going to remove the most recently added one, which was pretzel. We can hit Q to go to the Q variation. And in this situation, it's always going to remove the first one we put in there. So if we put bok choy in here first, then we add pretzel and burrito. If we say eat to remove, it's going to remove from the left. Specifically, it removes bok choy first, and then it removes pretzel, and then burrito, and then R, which I didn't even mean to put in there. And then it's an empty list. And then we eat nothing, and the world explodes. So don't do that. So that is our review. Hopefully you guys understand everything, understand the difference between a stack and a queue. Next up, we're gonna get experience working with 2D lists as well as sorting data. So we got a lot of cool stuff coming up. Stay tuned for that, and I'll see you then. And if you've enjoyed the series so far, please be sure to hit subscribe. Hey everyone, in this video, I'm going to be talking about 2D lists. I know we've talked about lists in this video series already, so there might be some review. However, we're going to get into 2D lists here and how to iterate through them. So a 2D list would look like this. Let's say we have a list of grades, and we're going to put grades for numerous people in here. So we'll put your grades in here first, and these are out of 100. So yeah, you're not doing so hot. Then I'll put my grades. You know, I usually do really good on an assignment, but then I either forget or don't feel like doing the rest of them. So I only turn in like 1 out of 4, and then I do really bad. But you can see I got lots of extra credit, 105 points. Yeah, pretty crazy. So then we'll just put, you know, the average student in here. So they're doing all right. All right, so we have grades, and what we can do now is we can access one of these lists by saying grades index 0. So that'll grab the first list. So we will print this out, and you can see that it just prints one of the lists, and you can go through and print the next one and then the next one. And there you go. If we want to grab a particular element of a list, let's say this 76 here, then we add in another square bracket, and let's say index 1, that's going to be 0 and that's going to be 1. So running this, and we get 76. Now, the lists are dynamic, meaning we can append to the outer list, this one here, or you can append to any of the inner lists. Let's say I turn in some homework late. Here's how we would do that. We would say grades, and then index 1 dot append, and pass in some data. Let's say I got a 70 on something. And now let's just print the whole list to see how it's affected. So run it, and you can see I now have another element inside of my grades list. So that's just some basics of working with lists. It's nice that everything's dynamic and you don't have to keep it square or anything like that. You could consider this the equivalent of a jagged array in other programming languages. Now I want to talk about iterating through this data. So what we're going to do is first iterate through the main list. So it's going to look like this. For inner list in grades. So each iteration, inner list is going to be assigned one of the elements. So the first iteration will be this list, next iteration this one, and then lastly this one here. So just to see that, we can say print and pass in inner list. And we'll clear this out and run it. And you can see we get the output we expected each time one of the lists is printed. Then all we have to do to iterate through that list is do another loop. So it's going to look like this. For grade in inner list, print grade. Now just for spacing's sake, I'm going to say end and make it a space, so that way everything is on a single line here. But if I wanted to break it out by list, what we could do is we could actually print an empty space at the end of each inner for loop. So after that, we print this. Run that, and there we go. You can also use indexes with range. So if you wanted to do that for some reason, here's how you would do it. We just say for I in range, pass in the length of grades. And for each iteration, we're going to have another loop for j in range and pass in the length of grades index I. And then lastly, we just print grades index I, index j. And we can end this with a space just for clarity. And lastly, print a new line after each inner loop. Run this, and there we go, we get the same output again. So you can do either one. Obviously, this one is a whole lot easier to understand and much more clear. So that's the basics of working with loops and how to iterate through them. Stay tuned for the next video because I'm going to teach you how to create a function that does this for us. Hey everyone, in this video I'm going to be teaching you how to create a function to print a 2D list. So we're pretty much going to take this code and wrap it inside of a function. So here's how you do that. You'd say def and then give it a function name. We'll just call it print underscore 2D. I mean, you can call it whatever you want. Call it taco salad for all I care. And then parentheses and a colon. And I'm going to take this code, cut it, and paste it in our function. Just make sure the indentation's right because it always tends to get messed up when you do stuff like that. So you should have 4 spaces right here, 8 spaces right here, 12, and then 8. So just make sure everything's indented nice. And then what we can do is this grades here actually needs to be passed in. So we'll create a parameter for that. Like so. And now we'll invoke it. Print underscore 2D and pass in grades. And run it. And hey, here's our output. So this is a really simple example where we're just printing the numbers. However, you could do all kinds of custom stuff with this. It's basically more versatile than just passing the entire list to print, which just keeps it inside of the list structure. If you don't want to do that, you can create your own function to do it for you however you like. Now it is important to have this definition come before the invocation. If I took this and tried to paste it right here, it's actually not going to work. And this might be different than what you might expect coming from a compiled language, because some compiled languages will actually go through the code, get all of the functions first, so then you can invoke them pretty much anywhere. That's not the case here, so we actually need to invoke it after the definition, like so. So there is your introduction on how to create a function to print a list. Hopefully it was helpful for you guys, and stay tuned for the next video. Hey everyone, in this video I'm going to be teaching you how to take a list of elements and concatenate them all into one giant string. And we're going to do this using the join method. So the easiest way to understand the join method is to first understand the split method. So the split method takes a string and splits it out into a bunch of list elements. We're just going to reverse that process. So first let's create that. So let's say we are working with some data and we will just say this is data. I know, very creative. But anyways, what we could do is we can say data.split and pass in some separator. And you can use this as a literal, or what you could do is you could use it as a variable. So what we can do is we can say D for delimiter. Don't use DEL, that's a keyword. Tried that, failed. So we're gonna go with D because I don't even know how to spell delimiter. We're just gonna make that a space and then we're going to pass in D to split. And the reason I'm spacing it out like this is because it's gonna be easier when we go to join if we have it all set up this way. So this is gonna return a list. So what we can do is we can print it like so, and running it, and we get a list with 3 words in it. If we wanna go the other direction, so we take this list and we assign it to data, how can we convert it to a string? Well, here's what we do. We take the delimiter, D, and then say join, and then pass in the list, data. And running this, we get this is data as a string. And just like you can use a string literal instead of a variable with split, you can also do it with join. It's just a little bit of a weird syntax if you're not used to calling methods on string literals, but it should do the trick running this, and we still get this as data. So we can put whatever we want here. If we want to hyphenate it, we can do it like so. Or if we don't want any spaces at all, we can just leave it empty, and then we get one giant word. And that is how to use join. Now, if you have mixed data, let's say we have a number in here. We'll put two numbers in there actually. Well, this is actually not gonna work. And I was trying to figure out how to do this, right? Because I wanted to do it. And my first thought was like, oh yeah, this is easy. We just have to wrap this in str. But that doesn't make any sense because we're actually converting the whole thing to a string. Running this, and we definitely do not get what we expect. So what we need to do is we actually need to convert each element with this str here. And we can use a list comprehension like syntax to do that. So get rid of this here. And instead of saying join data, we're actually going to iterate through the elements. So for I in data, and then for each I, we're going to convert it to a string. So we just say parentheses and then str. So that will convert each element to a string, and then it works the way we expected. So yeah, this is a completely original solution that I stole off of the internet, and this whole syntax here is known as a generator expression. So when you're using the list comprehension, but without the square brackets, it's known as a generator expression. And it's pretty much the same thing, but instead of creating that entire list in memory, it's just going to allow us to iterate through each element. So it's an iterable, which is what join accepts. If you go back to the beginning here, you can see join takes an iterable. When we use a generator expression, that will work just fine. So if you need to know more about generator expressions, you can read this. However, what we had worked fine, and I think that's good for now. So that is how you would concatenate a bunch of elements in a list. You just say for I in data, and then convert each element to a string and pass this whole expression to the join method, which is concatenated to a string literal. So it's a little funky, but it does the trick. That's all I got for you guys in this video. Now I want to talk about sorting 2D lists. So stay tuned for that. I'll see you then. Hey everyone, this episode we're going to be talking about sorting 2D lists, or in other words, lists of lists. So to first understand this, what we're going to do is we're going to first sort a list of just simple data, no lists inside of it. So it might look like this. Wrong spot, Caleb. Type up here. There we go. So we'll just put some numbers in here. And then to sort this, what we can do is say print, and in here we'll say sorted and pass in data. And running this, we get 3, 5, 5, 7, 10, 11. So you can see it sorts it from least to greatest. Well, a similar thing happens when we are sorting lists of lists. It looks at the data in each of the lists and sorts it element by element. So we're going to replace this data here with a bit more complex list here. Let's just put a couple lists and throw some data in each one of these. We'll do 10, 2, 3, 10, 4, then we'll do 4, 5,000, 6, and it doesn't really matter. You can just put whatever you want in here, but if you want to follow along exactly, go ahead and copy it exactly as I have. And then lastly, we'll just have a list with the number 10. And run this, and we'll see what the result is. So you can see here, this is the sorted output, and when it does this, it looks at the first element of each list. So the very first one, we have 4, and the rest are 10. So 10, 10, and 10. So 4 is going to come before 10, so that is why this entire list is at the very beginning. If there happens to be a conflict where the first element is the same, such as these three, all of these, the very first element is a 10, it will then look at the second element. The first one of these three doesn't have a second element, so that one's automatically going to come first. For these two, at the very end here, the 2 is going to come next because 2 is less than 4. So that is how lists are sorted when you have lists of lists. You can do a similar thing with strings, so let's just create another one here and test it out. Let's just throw some words in here. We got ball, we got apple, we got Amazon, we got A, and lastly we'll just go with Zen, and then we will print data2 sorted to see what we get. So run this, and let's take a look at this sorting now. So same concept here, it's going to look at the first element in each of the inner lists and sort them alphabetically. So A is going to come absolutely first because it's a single character and that is going to be sorted first compared to a word such as Amazon. Similar to the same thing here where we had 10 come before 10 with extra data after it. You can see that the second word inside of this list here is Zen, and it doesn't even worry about that because it's already sorted such that this list comes first because A decides where it goes. Then the next thing on here is Amazon. That's going to come before ball, so that's why Amazon is here, and the one with ball and apple is last. So sorting a list of lists can be a bit confusing, so just make sure you go through some examples and understand how things are being sorted. It first looks at the first element of each list. If they happen to be the same, it'll look at the second element of each list. If the elements are strings, it's going to go character by character. So the first element of each of these lists starts with an A, but the A by itself comes before A with extra data after it. That is why it is sorted in that manner. If we had something on here such as AMZ, now this would come after Amazon because AMA comes first. So we run it now, and Amazon, the list with Amazon comes first. Then AMZ, Zen, and then lastly ball. So hopefully that is nice and clear as mud, as they say. And in the next video, I'm going to be teaching you how you can customize the sort a little bit, so stay tuned for that. And be sure to smack that sub button. Help me get to 1 million. That's my goal for this week. So stay tuned. I'll see you then. Hey everyone, in the previous video, I taught you how to sort a list of lists or a 2D list. And we started off just by first seeing how sorting works without nested lists. So let's go through a simple example of that because I'm going to be teaching you how to customize the sort using a custom sorting technique. So sounds a little complicated, but it shouldn't be too bad. But first, before we jump into nested lists, let's just take a more simple example. We'll just call the list D, and we'll just put some numbers in here. And you guys probably know by now that by default, it sorts it from least to greatest. So if we sort D, we run this, and 1 comes first and 50 comes at the very end. Well, there is actually another parameter defined in this sorted function that can take a function to process this data to decide how it's sorted. So to do that, you can say key and set it equal to some function name. Don't put the parentheses, you just put the function name. So an example would be ABS for absolute value. So far we haven't talked about absolute value in Python, but it works just like in math. If there's a negative number, it considers it to be a positive number. Basically, how far is the number away from 0? So if we went in here and threw some negative numbers in here, throw a -8, doesn't really matter where, I'm just throwing them random places. We'll do a -2, maybe just some more 2s in here just to see how that works out. And what we can do now is we can print this. And what it's going to do is it's going to put all of the numbers from least to greatest, ignoring the negative sign. So 2 and -2 are at the same position. If we were to get rid of the key here, then it's going to put all of the negatives first. So in that situation, it's going to go from -8 all the way up to 50. So that is how customizing the sort works with a list that doesn't have any other lists in it. But when we have a 2D list, we can be a little bit more creative because we can process that list as a whole. So maybe we want to sum up all of the data in the list and sort it by that. So here's how you do something like that. Let's get rid of our simple list here, and now we can start working with this 2D list called data. And let's just say this data contains some points for games, and we're trying to see who won by summing up all of the points. Maybe let's bring the numbers down to a reasonable amount so it's not too crazy. And we'll just change the data just a bit. So let's say there's 3 rounds, and we're going to see who got the most points here. So go in here, add a little bit more data. So let's just see how it sorts by default. When we do this, like we taught in the previous video, it's going to look at the first piece of data. We got 4 versus 10 versus 10 versus 10. All the 10s come to the right because 4 is less than 10. Then what we do, if there's any that are the same, such as these 10s, we look at the second piece of data, which in this case we have 2, 4, and 10. So the 2 is going to come first, then the 4, and then the 10. And at that point, it's completely sorted. We don't have to look at the next number because we were able to figure it out just by going to that second number there. But now let's do it with sums. So the way you're going to do that is you're going to pass in a second argument here, and that's going to be to the key parameter, and we're just going to say sum. So for each element in this data list, it's going to sum it. So it's going to sum this, it's going to sum this, and so forth. So run this and check it out now. It's going to go from least to greatest of the total number. So here we have 15. We have another 15 here. Then we have 16. And then we have 30. So when you're using the key, when we have list of lists, it processes it on that entire list. Since we're working with lists, if instead we try to do something that works with single numbers, it's not really going to make sense. For example, if we did the absolute value, well, running this, look at this. It doesn't work because absolute value doesn't work for lists. So just keep in mind what data you're working with, and ideally, each element inside of the list is of the same type. In this situation, everything is a list. So we'll go back to sum, but I don't just want to do the sum. I want to actually create a custom function to work with these numbers in whatever way we like. So what we can do is we can create a function to process these lists, and that's what I'm going to show you now. So we're going to actually work with the average of the numbers. So pretty much it'll take these three numbers, add them up, divided by however many elements in the list there are, in this case 3. So to do that, we say def, we can just call it average, and this is going to take a list as an argument, so we'll create a parameter there. Then all we have to do is say return. We're going to take the sum of the data and divide it by however many elements there are, which you can get using len and pass in data. And then for the key down here, what we can do is use average. Let's run it, see what happens. We're going to have the same sort as last time because everything is 3 elements long, but let's just change up the data some. So in this situation, I just added a bunch of 10s, which will increase the sum, but it's also going to increase the length here, so it's going to bring it down more than just having a single number like 30 here. Let's go ahead and add a little bit more data. We'll add a 100 there. And in this situation, we're just going to have a 10. So let's see the output. Let's run it. And that's the output, but it's not immediately apparent why it's in that order because we can't just see the average right away. So if you want to just see the numbers for your own sake, then you could print it inside of this average function. But you probably don't want to leave that in there forever. But just for a second, let's do that. We'll assign this to a variable a. And then what we'll do is we'll print a and return a. That's just a different way of structuring it. Running it, and let's take a look. This first list here, calculated at 11.25, which is the third highest number, which is why it showed up right here. Next up, this really long list here, that actually was the lowest at 8.444445. That's why it came here at the very first. Next up, we have 28.75 for this list here. So that one's obviously the highest. It shows up last. And then lastly, we have 10, which obviously that's the average for this one. So that's going to come right here. So hopefully that's a little bit clearer, but I don't think we should leave the prints there. So let's just go back to what we had where we were returning it directly. All right, so that is how you create a custom function to sort lists of lists. That's all I got. So what we're going to do is we're going to do some review, just make sure we got everything solid before we go on to the next section. Stay tuned, and if this was helpful, I'd appreciate that you subscribe. See you then. Hey everyone, in this video, we're just going to do some 2D list review before we move on to the next section. You can find this code up on my GitHub and my Python repo, and it is 052dlist.py. So let's get started. The very first thing is just how to create a 2D list. First thing you need to know is that it doesn't have to be a square, so it can be what you may consider a jagged list, or what would be a jagged array in another programming language. You can access each of the elements indexing just like normal, so you can print grades as 0, which is actually going to be a list itself, and you can check the type using type, and you can see it returns list. If you want to grab one of the elements within that list, you just need to do another set of square brackets. So we're grabbing the element with index 1, which will grab this element right here, and it appears right here in the terminal. Lists are dynamic, so you can append another element to the main list, and we can also rearrange data with popping. That's going to remove an element, and that's going to shift indexes, just as a side note, so just be careful there. See, now when we print grades, it has a different structure. So we popped index 1, which gets rid of this list right here. And we added a list of 4, which comes at the end there. So this is the final structure. Next up, we talk about the length of grades versus the length of grades index 0. The length of grades is the outer list, so we're going to get 3 because there's 3 lists inside of here. When we get length of grades 0, we're also going to get 3 because it's now getting the length for this list inside of it. You can use the length for iterating through it, or you can just use a for loop by saying for inner list in grades, for grade in inner list, and then you can print that data, so you're going to get some output like this right here. It'll break if one of the elements is not a list. You could do a check if you want to, so you can do that with something like this, is instance, and then put the list you're wanting to check, and then checking to see if it's a list. So that's just an example of how to do that here, which we get a similar output, which is where this output right here comes from, coming from this list here. If you're iterating using range, that's where that length can come in. So taking a look at the next section of code, we're using the length of the outer list, and then for each iteration, we get the length of grades of index I. So you use that outer variable inside in the inner for loop, and that'll give us this output here, which comes from this list here. We took this code and we pretty much wrapped it inside of a function. So here's how you could create a function to print a 2D list. We then show an example of invoking this by passing in a list. We have some individual elements that are just strings, and then we have 2 lists of numbers, and you can see all the output right here. Since we're doing that checking to see if it's a list, it's not breaking when we pass in an individual element that's not in a list, which is nice. Next up, we have some other junk in here. Let's figure out what this comes from. We got some join, so we have these strings, and the very first situation we're joining it with a dot, which is where these dots come from. This is the opposite of splitting data. We're now putting data back together, so we take a list and put it into a string. Then I have a situation of joining data of different types, and here's how you do something like that, which I stole from this Stack Overflow question if you're interested. And sorting a 2D list, that's what we talked about next. By default, it sorts element by element. It's going to put all of the first elements that are lower at the beginning, and if there's any conflicts, it'll look at the second element. So printing this data, we get this here. 4 comes first before 7 or 10, and then in the situation where there's numerous 10s, it looks at the next element, so 2 comes before 20. Then I have some print statements just showing individual comparisons if you're interested, but I'm going to move on to using a sum of a list. So you can pass in a function to the key parameter. Don't put the parentheses again. And in this situation, it's going to sort by the sum of the list. So 10 is the smallest, then we have 15, then we have whatever that is, and then so forth. It just gets bigger and bigger. You can reverse the sort by saying reverse is equal to true. So that's going to give us this output here. Then we create a custom function, average, which actually takes the sum, divides it by its length. We have it printing it here if you're interested in the output. But for production, you probably don't want to do that, or you could just check it using debugging tools. However, printing it, that's the easiest way to check. So we print the data just so we can see it, and then we show that it sorts by this average here. So the one with the lowest average, which is this list here, that's going to come first. Then the next one, which is this one here, and so forth. So that is everything we talked about with 2D lists. Hopefully you understand all that at a pretty good level. You can now probably see that we're starting to build some more complex stuff, and it might get a little bit limited if we're just trying to do everything inside of one file. So the next logical thing to talk about is modules. That's what we're going to cover in the next section. We're going to learn how to work with modules, different ways of importing them, and then how to create our own modules for whatever projects we are working on. So stay tuned. I'm excited. Hopefully you are as well, and please be sure to subscribe. Hey everyone, welcome to your next section in this programming series. We're going to start talking about modules, which build the foundation for more complex applications. Because eventually you're not just going to want to program everything in one giant file. You need to break it out into numerous files. Plus there's modules out there that we can import into our project and use. There are some built in, and you can also download some off the internet. So one module we've seen is the math module. So to do that, you just say import math. And that is how you import any modules. You just say import and then the name of the module. This gives us access to a bunch of stuff inside of this module. You access it by putting the module name and then whatever thing you're trying to access. So for example, you could do square root, and that's a method, so you could pass some data in here. And when you import a module, you're going to access all the data using that dot operator. That's because the modules are imported as a special object of type module. So just to show you guys this, you can say print type and then put math. And running this, you get type module here. So anytime we're accessing functions on an object, so math dot something, the word for this is a method. You may also hear them called functions. Really doesn't matter a whole lot. Just methods and functions are essentially the same thing. Methods just come after a dot on some object. So I'm not here to talk about object-oriented programming. Let's get back to modules, but just thought I'd throw that as a side note. There's a lot of different modules you can use. So for example, we can say import Q, that's a module. There's pickle, which is a pretty cool name. We can import, I don't know, random. There's just so many modules we can use. There's heap Q, which is a data structure. You can import JSON for working for JSON data. And I'm not trying to teach you guys all of the modules here. The point is there's lots of different things that we can pull into our code. We don't always have to recreate the wheel. So where are these things even coming from? Well, you can actually find out by saying something like, let's go with random, and then you can print random. So pass random into a print function and hit run, and it says module random from, and then gives us a path. So I'm gonna open this and check it out. It shows us this file. And this comes from this folder here. So what I wanna do is I actually wanna open this inside of the Finder window or the folder structure on Windows, whatever it is. So copy this file path and let's navigate to it. So we'll just go into Finder and go to go to folder, and then paste in that file structure. And then I left off the file name, so we're going to the Python 3.8 folder. Hit enter, and holy crap, look at all that junk. So let's look at this in a little bit cleaner way. So these are all of the different modules that we can use in our code. So as an example in here, we had random. That's the one we're working with right now. It's right there. There's the JSON one I showed you guys, so you can go in here and find that if you want. I always have to start at A to do the alphabet to figure out where it is. So A, B, C, D, F, G, H, I, J. Right there, that's actually a folder. And we're gonna get into the folders, how those work in this section as well. But most of these are just PY files. So let's go back to our code and let's work with this random module for a second. We're not going to go into it in super good detail, but just to show you guys how to use it, you can do something like random dot and then access some member such as rand int. And this is a method, so what we can do is we can pass in a starting number and an ending number. So we could say 0, 10. And run this, and check it out, we get 0. And every time we run this, we get some random number. Anywhere from 0 up to 10 inclusive. So that is how you would use a member of this random module. And if you want, you can go into that module and see how this code works. So let's go into random.py. And I think this is actually, if I recall from memory, what is it? I think it's line 244. So let's go take a look, see if we can find it down there. And, oh yeah, definitely. All right, so this is how it works. It uses this other function here, rand range. So it's really not anything too crazy, but pretty much it takes the number you pass in and it looks like random range is exclusive. So it puts a +1 there. So that way it's inclusive and it returns a random integer in this range. The square brackets mean inclusive as opposed to the parentheses, which is exclusive. So that's how that works. Also note the triple quote comment. That's cool to see. So yeah, you can explore your modules, figure out how they work just like that. Another thing you can do is if you're working with it in your code, you can hold command on Windows and you can hover over stuff and see how it works, or you can click it to open that file. On Windows, it might be control, not entirely sure, but just push buttons until you get some pop-ups and it should work. Now, another thing I want to just make sure is super clear. What is a module? It is literally just a Python file. So we can create a Python file and import it into our code as a module. It only becomes a module once we import it. We don't have to do anything special, create like a new module structure or anything like that. It's just a file. And when you have this file, you can be very specific about how you want to expose all the inner data and what you want to be available. So I'll go through an example of how the internals are abstracted away, by taking a look at something inside of this random module. So I think it's on line 700 something. Right here on 786, you can see that anytime we invoke one of these, such as randint, it's actually invoking inst.randint, which is a new random object. So this is kind of an abstraction. Behind the scenes, it's creating a new random object and invoking a method on that object, but we just use it directly on this module, random.randint. But you can see the description here. It's easier for the casual user than making them instantiate their own random instance. If they didn't do this, the way we would invoke this would be a little bit different. It'd probably look like this. We'd create some variable and then say random.random, create that, and then we would say obj.randint. So it's just one less step we have to worry about because the module took care of that for us. So just know that behind the scenes, some stuff might be happening, and they're going to make it as easy as possible for us to work with these modules. Also, when working with modules, you can control what's visible through a special list. So I'll show you that here. I'm just going to search for it, __ all. And this is pretty much everything that we can use in this module. So you can probably see modules can get fairly complex. Obviously, the ones that are built in have all of the bells and whistles. The modules we'll be creating are probably going to be pretty simple, but we're going to do our best to cover what is needed to start building more complex apps. So I'm excited. Stay tuned for the next video because I'm going to be teaching you another way of importing modules that you'll probably end up seeing. So stay tuned and be sure to subscribe. Hey everyone, in the previous video I taught you the introduction of modules, and I showed you how to import a module like so and access the data in that module. And I showed you that we could get the type of any module we import, so we could say print and say type of random, and when you do this it says module. So this random is an object of type module, and all of the members of this module are accessible by saying random dot and then selecting whatever you want. But you don't always want to do this because you always have to prefix with random. It's a little bit extra typing. What if we just want a very few things from this random module? We don't need everything. Well, that's what I'm going to be showing you in this video. And as an example, we're going to work with random.randint, which is a function, method, whatever you want to call it. So to do this, what we can do is we can actually say from random import randint, like so. And then we can just get rid of this previous line we had, import random. So now we don't get access to everything for random, but we no longer have to prefix with random either. So I can say print and I can use randint directly. So we'll get a random number between 0 and 10 inclusive, and it looks like we got 0, 5. You can see that it's working. Whereas prior we would have had to have said random.randint, now we can use randint directly. But there's one gotcha here, we can no longer access the other members of random. So if I go in here and say print type of random, check this out. Running it now, random is not defined. We only have this one method, randint, which you can see is a method. So in other words, coming from random.py, we no longer can access all of this stuff. We can only access the individual ones we import directly. In this case, it was only randint, which is somewhere in this list, right here. But if you wanted to access any of these other ones, you would have to import those ones as well. So for example, if we wanted to get seed, let's just say we want to get seed real quick, you would just say from random import randint, seed. And now we can use that in our code wherever it would be appropriate. So I could pass seed into this type here and run that, and you can see it works. If we didn't import seed here, let's say we got rid of that for a sec, running this, we're going to get an error. Seed is not defined. So let's just talk about the pros and the cons. The pros here is that we do not have to prefix these members with random. We don't have to say random.randint or random.seed. We just say randint or seed. So they're available directly. The consequence, or the con here, is that because it's available directly, it's going to override any variables that we have of that name. So let's just say we were making some application, and this is totally theoretical, right? We were creating some farming application, and we were working with some variable called seed. and we just said, hey, this is an apple seed, like whatever. Just to store some information, we used a variable called seed. And then after this, we said from random import seed. Well, what I want to do is I want to print seed and see what we get. Running this, and look at this. It says method random.seed. It doesn't say apple. So we just replaced the value of seed with some method. Gross, we don't want to replace our data. That is bad. When we don't say from random import and just say import random, we don't have to worry about that because it's only going to create the variable name random, and all the stuff is accessible through that. So that would only be an issue if we had another variable called random. So that is an introduction to this syntax here, from module import member, and in this case we're using random and rand int. But you'll see this a lot, so stay tuned because we're going to consider different ways of importing and also aliasing, how to fix different problems. So stay tuned and be sure to subscribe. Hey everyone, this video I want to explain aliases when you are doing an import. So the problem with imports is it has the potential to override a variable you've already created. Ideally, you're doing all of your imports at the top of the code so you can know ahead of time what names you should avoid with your variables, but there's always that chance. So when you do something like import math, if you go ahead and assign math something else, well, that's going to replace this variable here. So if we print math, we get 3. And the reverse is true as well. So if I took this and pasted it down here, well, now we're replacing that 3 with a module. So we get module math from this location. So if you need to use a certain variable name, but it's conflicting with a module name, you can use an alias. So the way that looks is import math as, and then you give it some new name such as m. So now when we print math right here in this print statement here, it's going to be the value 3. If you want to get the module instead, you would say m. And there you go. You can see now we're working with that module. So we just prevented a name conflict. You can do the same thing if you're importing members from a module and you're not just working with the module directly. So in the example I gave you guys earlier, we were working with random. So we had import random, but then I wanted to grab rand int specifically or some other member. It looks like this. From random import rand int. And you can say as whatever you want to call it, r. And now what we can do is we can use rand int in our code, assign it some number, and we can print rand int and we can print r. We have access to both of these. So running this, the first is that random number, which we typed in, and then we have the method random.randint. So that is your introduction to aliases with modules. Again, an alias is just another name for something, so we rename the module whatever we want, such as r or whatever. So that's all I got in this one. Stay tuned for the next one where we're going to talk about something that's commonly seen with modules, but is not exactly recommended. So I'm going to give you some warnings. Stay tuned for that so you don't shoot yourself in the butt. Hey everyone, in this video I'm going to be talking about importing everything from a module. So you might see in code something like this. From random, import, and then instead of like rand int, you might have just an asterisk. So instead of importing one thing, you're actually importing everything. And it's imported directly so we don't have to prefix with random. What that means is I can go down here and I can say rand int, pass in some data here, get a random number between 0 and 10. Running this and we get 8. We didn't have to say random.randint. So although this is very convenient, it's also quite dangerous, and I'll explain why. Well, anytime you import asterisk, it brings all of those variables in, so it really increases your chances of naming conflicts. For small applications, it's not really the end of the world. However, as we build larger applications, it introduces potential bugs. You just gotta watch out for it. So to see this, check this out. What we can do is we can print and call this function called dir. And here's what it's going to do. It returns the names in the current scope. So it's going to grab all of the identifiers that are currently available. So when we run this, we get some interesting data. Here's all the stuff we can use. There's nothing in here I immediately recognize because I haven't created any variables. But if I create some variables up here, let's say we had A, B, C, D, and we just assign these 0, 0, 0, and 0. Running it now, take a look at it now, and we have new identifiers in this list. So when we say something like from random import rand int, that's going to add this directly into our identifier list here. So running it, and you can see rand int here. If we say import asterisk, it's going to import everything, making this list very long, adding a bunch of data to this list. And you can see what is added exactly by going into random and taking a look at underscore underscore all. And it's actually in alphabetical order here, so that's why it doesn't match up exactly. But let's say you're looking for random, you're just gonna go to the R's and see it right there. So let's say we continue this habit and start importing a bunch of modules. So we grab a bunch of other ones and we just say import asterisk. And we'll just do a couple more. JSON import asterisk from Q import asterisk. And when we do this, now this dir is going to give us a ton of identifiers. You can scroll through this and just see that the list is overwhelming. And you can see that how this could cause problems. What are the chances that one of these modules has a name the same as another module? Well, in that situation, one is going to replace the other. And if we ever create a variable, we could accidentally replace one of these in here. So you don't want to use import asterisk very often. My rule of thumb is to not do import asterisk unless there is a specific reason you need to, which off the top of my head, I can't think of any. But if that comes up, then do it. Otherwise, do yourself a favor and don't use import asterisk. Just import what you need or just import the modules. So when you import a module just like this, that only adds one thing to this list, random, but you can access all of those members through that random variable by just saying random dot. So it just makes your life a little bit safer to go this route. All right, well, I'm sick of hearing myself blabber, so in the next video, we're going to actually create our own module, which again is just a Python file, nothing too crazy, so stay tuned for that. It should be pretty fun and simple. Be sure to subscribe, and I will see you then. Hey everyone, in this video, I'm going to help you transcend beginner programming because we're no longer going to be programming in one file, we're going to be programming in numerous files by creating a module. And this might sound complicated if you're new, however, it's actually really easy because a module is just a Python file. There's nothing syntactically different. We don't have to say def module or anything crazy like that. So the first thing is, let's talk about how we would use this module if it existed, and then we'll go and create it. So it's going to look like this. Import, and then whatever the module name is, we'll just call it utils. And then we could use the utils module, and let's say this is to store various functions we want to use. Let's say we want to do some statistical processing and calculate the range of something. So the range of something is the highest number minus the lowest number. So if you have a list of data, it'll order them and take the last one minus the first one. So using it might look like this. We'll just pass it to a print. We would say utils dot, and let's just say this is named stats underscore range. And we'll pass in a list just with some data in here, like so. So that is how we would use the module. Now all we have to do is create it, because if we run it right now, it says no module named utils. So to do this, all we have to do is in the same folder, create a file and call it utils.py. So we fixed that first problem because now when we run it, it doesn't say it doesn't exist. It just says that it has no attribute stats range. So we need to create that function inside of this file. So I'm going to be teaching you how to create a range function. So we'll just say def stats underscore range. And then all we have to do is take a list as an argument. So we'll create a parameter here and we'll just call it data. So we'll sort the data by saying data.sort. And then we will take the last element minus the first element. So data index -1 minus data index 0. And we're going to return whatever that value is. So that is how we would create the function, really not that complicated. And now what we should get is 40 minus 1, which is 39. We run it and we get 39. So that is how we create a module. You may have also noticed that this PyCache folder pops up over here, and this is a compiled version of the module. We don't have to worry about this folder at all, just let it do its thing. And in fact, we don't have to worry about it so much, we could even delete it and it'll recreate itself when necessary. So if we run this again, that folder is created. That's just an optimization thing, but we don't have to go in here and touch any of these files. So now we just want to talk about variable scope a little bit, and we're not going to get into all of the details of it, but essentially one of the issues I had was I wanted to call this range. Do you know, instead of having stats underscore range, just call it range. But this introduced a problem because range already exists. You know, if you do something like for I in range, well, I didn't want to override that. That would be bad. But to showcase this, what would happen? We could change the name of this to range. And in our calling code, we would just now use it by saying utils.range. And this is totally fine. We run it, it works just the same. And even in here, we can still use the original range. So we could say for I in range, and we'll go up to 0 through 9. We'll just print I and then just a space at the end. So we'll just do that just to make sure it works. And you can see we're getting the output we expected. The only time this would be an issue, there's two occurrences where this would be an issue. The first one is in the utils file, if we tried to use the original range down here somewhere, such as looping or whatever, that's going to cause a problem. That's because we're overriding range with this function name up here. So we couldn't do that anymore. The other scenario is in our calling code, if instead of saying import utils, we said from utils import range, well now anywhere we use range, it's going to invoke our function that we created. So this is no longer going to work. We can run this and it says error. Int object has no attribute sort. So it's trying to use that function because we essentially replaced range. So that's the only module of using this syntax here, which is why I generally prefer to just say import utils and invoke it directly on that object. So utils.range. And if you really want to be safe, you could change the name of this back to something like stats underscore range. Now we don't have any overriding of anything, so we're definitely good. And we'll just fix that here, like so. Now this file works, and we could go ahead and use range down here in this code as well. So hopefully everything is nice and clear from that. In the next video, I'm going to give you a little bit more info on how modules are found, where you can put them, and so forth. So stay tuned for that, and please be sure to subscribe. Hey everyone, in this video we're going to be talking about the sys module and how to do various things like change where modules are searched for and a couple other things. So this is kind of like a miscellaneous video, bunch of cool tips, and I wanted you to better understand how modules work in Python. So the very first thing I wanted to show you was this document here from the documentation. It's talking about the standard modules, so the modules we've been using. Well, so far most of the ones we've used have probably been available to you. However, some of them might not be. So for example, this winreg or winreg, this module is only provided on Windows. If you're on Mac, you can try to import that and you'll get an error. So you can't necessarily be assured that all modules are available all of the time. However, there is a module that should be available all of the time, and that is sys. And sys is used if you want to interact closely with the interpreter. So a stupid example is given here where we changed the little prompt thing using sys. So if you want to see what this looks like, you can go into Visual Studio Code, or if you're using the interactive mode for Python, great. But what I'm going to do is I'm going to open the command palette and open the REPL. And in here we can say import sys. And we can see sys.ps1, and it gives us a string with these three little arrows. Well, we can actually change this. So we could say sys.ps1, assign it a new value. Let's just make it a couple of squigglies because squigglies are cool looking. And then we'll just put a space and end the string. And now our prompt has changed. It's changed from 3 arrows to a bunch of squigglies. So anytime we put some expression in here, it's always going to give us those squigglies. So that's like a silly fun example you can do, but there's a lot more you can do with sys. One thing is sys.path, which is a list of strings determining where modules are searched for. So I'm going to get rid of the interactive mode just because we haven't really been working with that a whole lot. So what we're going to do is we're just going to go up here and say import sys, and then I want to print sys.path. So run this, and you can see you get a list of a bunch of strings. We got users /Caleb Curry /example, and then a bunch of other places where some of the other modules we've been using might be located. The one I really want to call out here is this first one, which is actually the current directory. So what that means is if I went in here and created a folder, we'll just call it test, and I took our file and moved it to test and hit move, Well, now it's in that folder. So when we run this, take a look at the new output here. It's now example/test. So that's always going to be the current directory, which is why when you create a module, you can just put it in the same directory and it works just fine. That's how we did it in the previous video when we had this utils. But now since I'm in another folder, utils is actually one folder up. So if I try to import that, and I'll show you guys that real quick. If I go down here and say import utils and run this, it says no module named utils. So what we actually can do is if for some reason your modules are located somewhere else or you have a specific place you want to store them, you can append to this path a new location. So what we can do is we could say sys.path.append and pass in a location. So the location I'm going to pass in, I'm actually just going to copy this and then just modify it a little bit. So take that, paste it here, and just get rid of this extra folder at the end. So now it's going to search one folder up in the example folder, which is right here. So now we run this. We don't get any issues, but let's say we didn't do this step. I comment this out, run it. Hey, now we have an error. No module named utils. So that's how you can change the location of your modules. You can do this more dynamically using this example given here. So I'm going to copy this code here. And what this is going to do is rather than hard coding that, it's basically going to dynamically go up one folder. So here's what that'll look like. I'll go up here, paste that, and then the variable d will be used for the append. So all we would do is say sys.path.append, pass in d, hit run, and we're not getting any errors. So now it's a little bit more dynamic in that if we move the file, let's say we create a new folder here, call it test2, and we put that inside of test2. Come on, work. There we go. And we put utils inside of test. This is now our file structure. We have test2 with hello in it, and then test with utils in it. This is still going to work because we didn't hard code any paths. So there's a lot of different things you can do with this, but just wanted to share a little bit more about how modules are found. Hey everyone, we're going to review everything we've talked about when it comes to modules, so you can get this code up on my GitHubs. The Caleb Curry is the name, Python is the repo, and you can just copy this, paste it into your editor, and you are also going to need another file, which is actually utils.py. So this is actually just a function. We're going to work with that, importing modules if you feel you need to do that. So what we're going to do is take this, and you can pull this repo or just create the file yourself, whatever you feel you want to do. And we'll go into our editor, say new file, utils.py, and paste that code in there. So now we should be able to use that module. So let's go over into the code and we'll just go through it and see what everything's doing. So we'll start at the very top, which is right here. So first thing is I show you guys how to import modules, which is pretty simple. You just say import and then whatever the module name is. These are just Python files, or they can actually be folders, and in that situation they're known as a package. However, importing them and working with them works exactly the same way. So when you print one of these modules, what do you get? Well, you get the module name and also the file location. So if you want, you can open that location and see what's in it or see some of the other modules. If you want to just open that file, you can open it inside of Visual Studio Code just by following the link and looking through the code here. So that is how you would open a module to see its code. But we're not going to work with that right now. We're just going to continue our code here. You can also find a link with all of the different modules you can use. Here's a documentation page, and open that and take a look at this. This is the Python module index. Lots of different stuff in here, but you can find whatever you're looking for. For example, pickle, which is what we just were working with a second ago. Next up, we actually talk about using the different members in these modules. So any of the functions or variables in these modules are going to become available to us when we import that module. Now, there is mechanisms to only expose certain members. However, we don't have to worry a whole lot about that. But if you're wondering what that is exactly, if you go in a module, you can search in here for all, and these are the members that are being exposed. So when you import this module, those are the things that are going to be available to you. So an example of using a member is printing math.py, which gives us 3.14159. And then we show here printing the type of math, and you can see it's an instance of module. So we're working with an object of type module. And anytime we have an object, we access its members using the dot operator. So that's where that syntax comes from. Here's another example of getting a pseudo-random number 0 through 100 inclusive. So it could be 0, it could be 100. This comes from the random module. And this is the randint method. So we get 12 in this case. You can see how this works by opening random.py if you were interested. So holding command here, I can click random and scroll through this to find the code. But essentially what it does is it uses another method and passes the data we passed into it. So fortunately, a lot of this stuff is available to us to go look at, so you can see how things work. We talked about that in an earlier video, so go watch that if you're really interested in the details. And here's just some more notes talking about all, that's what's exposed, and how they're behind the scenes creating an instance of random so that the user of the module doesn't have to worry about it. So if they weren't doing that, it'd be a little bit of extra work where you'd actually have to create an instance by saying random.random and assigning that to a variable. However, we don't have to worry about that. Another way to import modules is to say from module name import member, whatever that member is. In this case, we're saying from random import randint and seed. So then those are the only two things we're able to use, and they're available directly, so we don't have to prefix with random. So we could just say randint 5, which is always going to give us the value 5. This replaces anything locally called randint. So if we create this super important string, when we do this and print it, what it's going to do is it's going to replace it, because now we no longer have that string. We get whatever we get when we print the randint coming from the module. Next up, we talk about aliases, which allows us to change the name for a module or a member of a module if we use the syntax here. But in this case, we're importing random as R, so then we would say r.randint. Or if you want to import a specific thing such as randint, you can say as ri, and then that's how you would access it. So just a little bit of a way to protect your variable names or to be specific on what you want to call it. And in this situation, we can still access this randint data because we didn't replace it, which is why we get this value here. Now there's another import option, which is import asterisk, which is going to import all of the members. So from random, import randint is the way we've done it so far, but if you want to just import everything, you would just say from random import asterisk. And that's going to replace any variable. So in this case, we have a variable seed with the value watermelon. That's actually replaced. So when we do a string like today we are going to plant watermelon, what actually comes out is today we are going to plant, and then this output for a method. And then it says seeds, yay. So obviously that makes no sense. So you just gotta be really careful with the import asterisk, as it's a really high chance of replacing things that exist already in your code. Especially if you're working with numerous modules, you might be replacing stuff you don't even realize it. So be really, really cautious. I'd recommend you don't do this for most cases. You can get a better picture of this by printing out dir. So when you do this, it creates a bunch of output here and has all of the identifiers in scope. So for example, I just put a bunch of them here, and you can go in here and find them. So there's A and B and so forth. But yeah, that'll show you that how much information is brought into scope when you do import asterisk. Next up, we talk about creating our own module. You just create a Python file, which we created just a few minutes ago, and you just say import utils. Nothing special about the file. The syntax is exactly the same as any other Python file. You don't have to say def module or anything like that. You just create functions and you're good to go. Now back in here, we can use this by saying utils dot and then whatever that method is called. Next up, we talked a little bit about syspath, which is a module that's always available to us. Here's an example of how you can change the prompt inside of the interactive mode. It doesn't show up here. However, if you were to run this code in interactive mode, you would see this change to the C greater than sign, which you can get that from the docs in this documentation right here. But anyways, the point is this sys is always available to us, and we can actually use it to determine where modules are searched for. So for example, we can say, hey, we want to search for this module in this path here. Or you can be a little bit more dynamic using this example code here, which is used to grab the parent directory. So if your modules were up a folder, then this is how you would do that. Now, once this is appended to the sys.path, it'll automatically search for that. So any imports after here, that location would be valid. So that is your review of modules. It is a lot. I was going to talk a little bit about packages, but I just decided not to do it in this series. But pretty much a package is just a folder with a bunch of different files in it that works the same way as a module. It's just a little bit different, but if you want to know more information on that, then you can research packages. We might get into it later on, but for now, we're going to move on to something new, which is understanding sets and dictionaries and how to work with them. These are two very important data structures, so make sure you pay attention, and I will see you in the next video. Let me know if you've been enjoying the series. I'd appreciate any comments, and be sure to subscribe. Hey everyone, this video we're going to introduce the dictionary data type in Python. So a dictionary is just a data structure to hold numerous elements, but not just individual elements by themselves like a list would work. Instead, it's key value pairs. So there's going to be an association between two pieces of data for each entry in this dictionary. So that's a lot of words, but we're going to go through an example. And if you're coming from other languages, this is very similar to the way you'd create an object in JavaScript. It's very similar to an associative array in some other programming languages. So you might already have some experience with this structure. However, internally, this is a hashing structure, so the keys are hashed, and we'll get into that in these videos. So an example would be something like emails. And you say this is a dictionary by putting curly braces, and then for the data, you put the key on the left with a colon, and then the value on the right. So as an example, we could say Caleb, colon, and then we can put my email, which might be caleb@email.com. So this is a dictionary, very simple to create. In this situation, this is said to be the key, and this is said to be the value. And they're associated, meaning they have some connection. The email for Caleb is this. We can add extra data in here by putting a comma and then putting other values in here. So you can format it however you like, but let's just say we go in here and put all of the emails on their own line. So we'll create another one. And this will just be g@email.com. So that is Gal's email. Now what you can do is anytime just print this dictionary to see how it looks, see the structure, run it, and this is what it's going to look like in an output. It pretty much looks exactly the same as when we defined it. But yeah, that's probably going to come in useful if you're working with dictionaries and you just want to see the values. Very easy to print, similar to a list. Just make sure you watch out for the colons, because whenever there's a colon, the data on the left and the data on the right are associated. The left is the key, the right is the value, key value pairs. Now the key here has to be a data type that is hashable. And we haven't talked a whole lot about that, but when we have objects, they can have an internal method called hash, which basically takes the data and does some processing to convert it to an integer. And yeah, this is weird if this is the first time, but follow along for just a second. Let's say we want to just see what a hash of something would be. We can say hash. It's a function that's available for us to use, and it returns the hash value for a given object. So what we can do is we can pass in an example here, such as Caleb. So this is what's going to happen with the key for this dictionary. And to see what this outputs, we can print it. So when we print this value, we get this number here. The actual number itself is totally irrelevant to us right now. The point is this data is converted to this number. So using this number, the dictionary is going to decide where to store the data. So this is the key, which is hashed, and that determines where this gets stored. So it's a little funky, but let's just imagine we had in memory 8 spots, and we could store 8 pieces of data. Well, it might look something like this. The hash of Caleb modulus 8. We run this, and we get the value 4. So that is where Caleb would be stored, at index 4. So a process like this is going to happen to determine where the data gets stored. Now, we don't really have to worry about that because it's all behind the scenes. The only thing we need to know is that the key here is hashable, which the immutable data types are. So a string is hashable, a tuple or tuple, if you pronounce it that way, is hashable. We haven't really talked about those, but just to show you guys that, we can go in here and put another element just as an example. And a tuple is going to be in parentheses, and it's going to have multiple values, such as 5, 5, and that can have some value. This should work as well, no problems. But if we go in here and add a mutable type, such as a list, that's going to be an issue. So if I try to create a list with the value 5, 5, and give that some value, this is going to cause an error. And you can see unhashable type list. So if you get this error, that's what it means. It's meaning that the key does not have that method behind the scenes hash. So as a general rule of thumb, immutable types are fine. Mutable types are not fine. So stick to the immutable types, strings, integers, tuples, and so forth. So now that we talked a little bit about how dictionaries work, let's talk about why you would want to use a dictionary. Well, obviously, if you need to associate two pieces of data, dictionaries work great. But there's actually another really good benefit of a dictionary, and that is the extremely fast speed to insert data and retrieve data. Due to the way data is inserted and retrieved, the size of the list does not matter. The speed to get data in and out is going to be the same. And this concept is known as big O of 1 or a constant time. So if you increase the size of the dictionary, it doesn't take longer to get data out of it. This is different than a list because with a list, you probably have to iterate through the list to try to find the data. So if you have a really huge list, it's going to take a long time to get that data out. So dictionaries are very, very handy for fast lookups and fast inserts. But we're getting a little bit much into algorithms and data structures, so we're not going to worry about that too much for now, but it's definitely nice to know. Next up, I want to talk about how to retrieve data from these dictionaries, so stay tuned. It should be pretty fun. Hey everyone, this episode I'm going to be teaching you how to retrieve data from a dictionary, and your first thought might be to use indexes like you would with a list. So you would say emails and then pass in, let's say we want to grab the first thing, 0. Well, hey, this doesn't actually work. And we'll just run this and see we get a key error 0, or in other words, no elements were found with that key. The proper way to do it is actually to put in one of these values to grab it. So if you want to grab my email, all you would want to do is pass in Caleb, and we're going to print this just so we can see the output. And we print this and we get caleb@email.com. So that's how you grab data. And the problem here is that sometimes you're going to get an error and other times you're not. So if you want to avoid that error, there's two ways you could do this. So I'll show you the first, which I don't really think is the best option, but you'll see it. And then I'll show you the second. So the first way to do this is to actually check if that data exists. So we can say if Caleb in emails. So if it's found, then we can print the data. So in that situation, it's only going to try and grab that data if it's found in the dictionary. And running it now, it works, but if we put in something completely wrong, so we'll switch the keys here, like so. If we do that now, nothing happens. We don't get any errors, but we also don't get anything printed. So it works. We could put an else in here saying else not found. So there we go. That is the first way. The other option is to actually use a method on the dictionary. And in this case, if data is not found, you will get none, but there's no exceptions thrown. So what we can do is say emails.get, pass in a key such as Caleb, then we'll just print it. In doing this, we get that value. However, if we put in a key that doesn't exist, such as Caleb with a capital C here, it just says none, which is the equivalent of null, nothing found. So whichever one you prefer, that is totally up to you. You can also pass in a second argument to this get method, which is what you want it to return if there's no data found. So right now, it's just doing none, which is the default. However, you could also do a string, so no user found. In this situation, we would get no user found as the result, which if you want everything to be of the same type or you don't want any nuns, that is how you would do it. So that's how to retrieve data from a dictionary. Up next, we're going to talk about inserting data to the dictionary, so stay tuned for that. Hey everyone, in this episode, I'm going to be teaching you how to add data to a dictionary. And I actually have 3 different ways of doing this, so you can do whatever you prefer. The first, and in my opinion the easiest, is to put the dictionary name, such as emails, and then inside of square brackets you put the key. So let's say we added another user in here, and then we use the assignment operator and we put the value. So we can put this person's email here, and then we can print the entire dictionary and see that it is available right there. So to me, this seems like the easiest way to do it, but there are 2 different ways that you'll either prefer or you just might see when working with other people's code. So it's nice to know that they exist. So this is what that's going to look like. We're going to say emails.update and then pass in a dictionary, but just with whatever elements we want to add. So this is ideal if we want to add numerous elements. So what we could do is we can say Josh, and we're going to give him j@email.com, and we can actually go in here and add another one. So we'll go with Ryan, and we'll just give him r@email.com. And then running this, we don't get any errors, and you can see we have Josh here and Ryan here. So that works. So if you're going to add a bunch of elements to this, it might be easier to do it this way than to do it one element at a time using the previous example. Now there's another way you can do this, and that is to get rid of the dictionary and put the key without any quotes or anything. So we'll say Josh, and then assign it a value j@email.com, or whatever the email might be. Running this, and you can see it works fine, and Josh is inserted in there as a string. So yeah, this is the third variation, so you'll probably see any of those three throughout your career. Thank you, and in the next video I'm going to be teaching you how to iterate through the keys of this dictionary, so stay tuned. Hey everyone, in this video I want to teach you how to iterate through the keys of this dictionary. Now it's going to work in a similar way to the way you would iterate through a list using a for loop, but we're going to use the variable k. I mean, you can call it whatever, but we're going to use k for key in emails. And then what we can do is we can print k. So that is the most basic loop, and when you do this, we get Caleb, Gal, and Tim. This works because dictionary is another example of an iterable, just like a list is an iterable. And if you want to get the element as well, I'm going to show you one way to do it in this video, but it's not really ideal, so I'm going to teach you the better solution in the next one. But here's something you might see, and that is where you get emails, and then for the key you just pass in k. So this will get the job done, but it's not the best solution because, for one, the key is going to have to be hashed again, and there's actually a way to loop where we can get that value right away. So that's what I'm going to be showing you guys in the next video, so stay tuned. Hey everyone, in the previous video I taught you how to iterate through a dictionary and grab the key, and you can use that key to get the element, the actual value at that key. However, there's a better way to do it, and that is to actually put another variable here. We'll call it lm for element, and then instead of getting it from emails, you're going to get it from emails.items. And what we can do here is actually just print the element. Run this, and we get the exact same output as the previous example. So I want to go through an example of what we could use a hash table for, and that is to keep track of occurrences through some data. So what we'll do is we're going to create a giant string, and I want to count all the occurrences of certain words. So let's start fresh. We'll clear out this. And what is our dictionary going to be? The dictionary is going to hold the words we're looking for. Let's say we're looking for all of the conjunctions. So the fanboys thing, which is for, and, nor, but, or, I can't even remember them all, but let's just write it out. We'll just say conjunctions. This is going to be a dictionary, and we'll just say the value for. This is, everything's going to start at 0, and it's going to be 0. We have nor, but, or, yet, and lastly we have so. And then next we're going to put a string here, and I wrote this poem that I just wanted to share. It's deep from my heart, so I'm just going to paste that here. So the easiest thing to do is to split this out into words, and then we can iterate through it. So it'll do that. What we could do is just say data is completely original poem split, and by default it'll split it by words. So just to prove you guys, we can print data. And let's run this, make sure we get what we expect. And yes, we have a list of a bunch of words. And then what we can do is say for word in data. And here's where we would check to see if it's within our dictionary of words we are looking for. So if word in conjunctions, we need to update that value. So to update the value, what we do is we say conjunctions. And for the key, we're going to use that word and reassign it what is originally there, but increase it by 1. Another way to write this, which is a lot prettier, is to just say plus equals 1. Now the only other thing that I want to do is just do some lowercasing, because remember that uppercase and lowercase are two different characters. If we don't want to worry about that, then all we have to do is say if stir.lower and pass in word. And then same thing here, we would say stir.lower That's optional, but I just thought that would be a good addition. And then lastly, the thing you just do at the end is just to print the conjunctions dictionary. So we'll just say conjunctions, and it'll tell us how many times these words appear in this poem. So run it and check it out. For shows up 0 times and 1 time. The rest is 0 except but, which is 1 time. This concept could easily be created into a function that takes maybe a list of words that you're looking for and then the data to look for, and then it returns a dictionary of how many times those words show up. And this concept could be applied to basically analyze data to see maybe how aggressive it is, or how many vulgar words are used, or whatever it might be, basically searching through data to figure out what it's trying to say. So that's just one example of how you could use a dictionary, but I'm sure there's tons of different things out there. Another popular use is memoization, which is basically maintaining values that are hard to calculate for functions to optimize code. So for example, if you're calculating factorials, memoization is very commonly used because calculating a factorial is very expensive. Next up, we're going to talk about another data structure known as a set, which works in a similar way, but it's no longer going to be a key value pair. So stay tuned for that. I'll see you then. Hey everyone, in this video, I'm going to be introducing sets. Now we've talked about sets a little bit in this video, but this one's going to be dedicated comparing sets to lists and dictionaries and what you might want to use a set for. So let's first talk about sets versus lists. So at this point, you probably have worked with lists and you understand you put in the data as individual entities. There's no key value pair like a dictionary. Same thing for sets. So that's how they're similar to lists. So we would create a set like so. Let's say we have something called items, and you just put the data inside of curly braces separated by commas. So the only difference between a set and list syntactically is that the set uses curly braces. But functionality-wise, a huge difference between a set and a list is that a set cannot have duplicates. So what that means is I can add another element in here by using the add method, and we'll add in sort again. If we go ahead and print items, there will only be one occurrence of sort. And you can see it's actually right here. There's no guaranteed order with sets, so that's why they're in a different order. Now let's compare sets to dictionaries. Well, you define them with curly braces, same as you would a dictionary, but you don't use a colon with a key value pair. You just put the data in there by itself. They do use hashing behind the scenes, but the thing that is hashed is not the key, rather it's the data itself. So sort is hashed, rubber duck is hashed, and slice of pizza is hashed. This means that the data you add inside of a list must be hashable. So if you try to add a list in here, well, this is going to give you an error because it says unhashable type list. A cool use of sets is to easily check if certain items have been flagged. You know, maybe every time a certain thing occurs, we add it to a set and we can go back and check that set to see what has occurred. So let's go through an example of that. It's going to be similar to the example we had in the previous video if you watched that with dictionaries, but pretty much we're going to create a set of conjunctions. These are words used to combine sentences. So it would look like this: conjunctions, and we're going to say for, and, nor, but, or, so, and also yet. Forgot that one. There we go. All right, so I'm terrible at English, but I think I got them all in there. And here's what we're going to do. We're going to have a message or some data to go through. I'll just paste my completely original poem in here again. You can type out your own string if you want, or you can copy this. And you can split this into a list, word by word, by saying completely original poem dot split. And we will assign this to a new variable called data, like so. Then what we're going to do is we're going to iterate through data for word in data. And then in here, we're just going to check what the word is. So we'll say if str.lower, pass in the word. And if this is in conjunctions, and what we're going to do is if it is in the conjunctions, we're going to add this to a set called seen, so we can keep track of what conjunctions we've seen or not. And to do that, here's how you do it. You would say seen and then assign it set. So you have to do it like that. You can't just do it like this, because this is actually an empty dictionary, which is not what we want. So we want to say set. So we're pretty much just seeing if these conjunctions are found in this string here. So what we would do now is just say seen colors.add, pass in str.lower word. Then at the end, what we can do is we can just print scene like so. So we can see all of the conjunctions that were found in this string, but and. If, for example, we have another one in here, let's just say, or yes, so those will show up in here as well. So notice that the set is very useful for a yes or no check. Was but seen? Yes. Was and seen? Yes. It can't tell us how many times it was seen. If you want to do something like that, then the dictionary is the ideal data structure to use. That's all I got for you guys in this video. That was your intro to sets. Stay tuned. We're going to continue talking about sets and get some more work with them. See you then. Hey everyone, in this video, I want to teach you how to remove duplicates from a list. So let's say we have some list, we'll just call it colors, and I'm going to put some colors in here. And I'm going to put a few in here a couple of times. So we'll have red in there twice, and then I'm just going to have a ton of occurrences of blue. And now what we want to do is remove any duplicates such that we're left with red, green, blue. And a magical tool to do this with is a set. If you remember sets, you cannot have duplicates. So what we can do is pass colors to set, which will create a new set object. And then what we can do is if you want to keep it as a list, we can take this whole thing and pass this to list, which will create a new list. So pretty much the colors list is converted to a set and it'll get rid of any duplicates. Then we're converting it back to a list. And what you could do is you could assign this to a new variable such as no duplicate colors. That should work. Or you could just replace colors if you don't need to maintain that data, like so. And then what you can do is you can print colors. And running this, you get green, blue, and red. Notice that the order is not the same. That's a consequence of using sets because they are unordered. There's probably some solution out there if you really need to keep the order, or you could pass this to sorted to sort it in any way that you like. Now, we have talked about this earlier in the series, but just as a refresher, if you're doing this, you're actually replacing the colors variable. If you need to keep the actual list, the same area of memory, then all you have to do is put square brackets and a colon. And that'll replace all of the elements of the colors, but not actually create it as a new list. And to show you guys this, just print the ID of colors before and after. So doing this, you should get the same number twice. So it's the same list in memory. For most situations, this is not necessary, and replacing it altogether is totally fine. But just keep in mind, if you have aliases, numerous variables pointing to this list, you might get some weird bugs if you're not careful. So just make sure you understand what you're doing here. But yeah, this is fine for me, so that's what we will do. So that is how to remove duplicates from a list. We actually used this trick earlier on in the series with list comprehension. And the thing we were trying to do is count the number of occurrences for each element. So red would be 2, green would be 1, and blue would be 4. And I'll show you what we did. We had a list count, and we were using list comprehension so it looked like so. Very first thing is we were getting each color. So for color in colors, and we would use the set variation of colors so that there was no duplicates. Otherwise, red would show up twice, which we don't want. So we converted to a set, and then over here on the left, all we did was we got the count of that color. So we said colors.count and passed in the color. So that was the solution, and then we printed count. And running this, we get 2, 4, 1. Obviously, that's not very helpful because you would think, oh, there's 2 reds, 4 greens, and 1 blue, but that's not actually what's happening. It's just rearranging the order because we're using a set. So what you could do in here is pass a column. Let's make this a list itself by passing in the color. There we go, and that's all in square brackets. Running this now, and we have a list of lists where we have pretty much the number and the color inside of each list. So that is the solution to counting elements, and you hopefully can understand it a bit better now that we have a more solid background in sets. So that is your video on removing duplicates from lists using sets. Up next, we're going to talk about various set operations, which are super convenient and another powerful tool of sets. So stay tuned, I will see you there. Hey everyone, in this video we're going to be doing various set operations. In this one we're going to be looking at union and intersection. The easiest way to get a grasp on these is to just type them out and follow along. So you best be going through these examples. Don't just be sitting watching. Get on your computer and start typing. So what we're going to do is we're going to create two sets, and I'm going to do colors here. So my colors and my lovely's colors. So I'll call mine my fave and I'll call hers her fave. Alright, so what are my favorite colors? I like red. You guys better believe I know I like green. And I like blue. I'm also a pretty big black fan. And purple. And what are her favorite colors? Well, you know, blue, of course. Also orange, purple, and green. So take a look at these sets, just analyze them for a minute. Notice that we both like blue, we both like green, only I like red, only she likes orange, but we both like purple, so there's some similarities and there are some differences, and that's important. So the way a union works is it combines both of these sets, all of my colors plus all of her colors. And the cool thing about sets is there's no duplicates. So just because blue is in here twice, that doesn't mean there's going to be two blues in the output. There's only going to be one. So we could do all faves and just do my fave, pipe, her fave. And then what we'll do is we'll just print all faves. So running this, and we get all of the colors: black, red, purple, orange, green, blue. A similar thing can be done with lists, although there will be repeating data. If these were lists instead, you would just use the plus operator, which is combining the list, or you can think of it as concatenating the lists. So the union, you can just think of it as combining all of the sets together and removing any of the duplicates. Now the next one is the intersection. If you want to visualize this, if these are my colors and these were her colors, the union is everything in here, whether it's just in the middle, on the left, or the right. The next is the intersection though, and that is going to be the part that is shared between the two sets. So to do that, what we're going to do is we're actually going to figure out our colors that both me and her like. So for this, it's going to be called wedding colors, because this is pretty much how we chose our wedding colors. We figured out of the colors I like and the colors she likes, what ones do we share? So for the intersection, you actually use the and sign, the ampersand, and then what we'll do is we'll just print wedding colors. Running this, and we get blue, purple, green. So these are all of the elements shared between these two lists. Notice red is gone because only I like that, black is gone because only I like that, and orange is gone because only she likes that. So that is how to do a union and an intersection. There are also methods to do this if you want. So for example, my fave dot intersection, and pass in her fave. And running this, and we get the same exact output. There's also a union method which you can use if you prefer. Stay tuned because we're going to be talking about the difference and symmetric difference in the next video. Be sure to subscribe. Hey everyone, welcome to your videos on sets in Python. We're going to be talking about the difference and symmetric difference. So the difference is similar to, the difference in math where you subtract data. So we're going to start with my set here, my favorite colors, and we're going to subtract her favorite colors. So what we should be left with are only colors I like. So this is what it might look like. Only me, and assign this my fave minus her fave. And what we'll do is we'll just print only me and print this, and we get red and black. So red and black are the colors I like, but she does not like. We could, of course, reverse this. So we would say only her. We would subtract me from her, so her favorite minus my favorite, and then just print only her favorite colors, and in that situation we should get orange, because I don't like orange, and she does like orange. Now do keep in mind, this is mostly just for example, so no feelings of these colors were hurt in the process of making these videos. We're just going through some different colors here. So to visualize this, it's going to be all of the data in this circle that is not included in the blue circle. So only this data here. Now the symmetric difference is the next thing we're going to talk about, and the way this works, it's a little bit weird, but we're going to take only her colors and add those with only my colors. So let's create both of those. Only mine would be my favorites minus her favorites. And then what you can do is do a union on these, only her with only mine. And the result here is orange, black, and red. So visually, that's going to be this data here in the green and this data over here in the blue, but nothing where we share. Now there's actually an operator to do this. So what that's going to look like, we'll just call it symmetric. What we would do is say my fave, the capital 6 caret looking thingamajig, with her fave, and then we'll print symmetric. Run this and we get the same exact thing, black, orange, and red. So however you prefer to do it, and just like in the previous video I mentioned there are methods for this as well. So my fave dot, and then there is difference and symmetric difference. So yeah, there you go guys. That is your introduction to union, intersection, difference, and symmetric difference. And that's all I'm going to be talking about with set operations. Stay tuned for the next video where we're going to review everything we've talked about for dictionaries and sets before we move on to the next section. Please be sure to subscribe if you've enjoyed the content, as it really helps out this channel and my self-confidence, so please do it. All right, bye. Hey everyone, welcome to your summary video on dictionaries and sets. As always, you guys know the drill. The code is up on my GitHub, Caleb Curry, and then it's 07 dictionary sets.py. All right, so let's just paste this code in our editor and go through it. All right, we got a long one today, 262 lines, so let's not waste any time. The very first thing is how to create a dictionary. And it works by using curly braces and then key value pairs, and you separate the key from the value using a colon. If you've worked with JavaScript objects or JSON data, the syntax is very similar to what we have here. It's the equivalent of an associative array, and the data structure behind this dictionary is a hash table, meaning the keys are hashed to decide where to store that data in memory. So imagine in memory we have reserved maybe 8 spots to begin with. We take the data, we hash it, and based off the result of the hash, we determine which of those spots to store the data in. So to show you an example of this, what it might look like is we hash the string hello, and we use modulus 8 to get a number between 0 and 7. So let's take a look at the output. So this is the hash of hello, and then using the modulus we get the value 1. So you can imagine storing it at that position, index 1 in memory. Now just to be clear, I'm just using this for illustration. The actual process might be a little bit different for Python, and I'm sure you could figure out the exact details on how we go from a key to a memory position in Python. But for now, this gets the point across on how we take some data and turn it into an index under some number. Now the data on the left needs to be hashable, and it's generally for immutable types, or anyways it should be. And for example, a tuple will work, but a list will not, as a list does not have a hash ability. The reason you might want to use a hash table, or in Python a dictionary, is that it's extremely fast to add or look up data. It's constant time, meaning if the size of the dictionary doubles, the time to insert and retrieve stays exactly the same. To retrieve data from a dictionary, all you have to do is pass in the key to the dictionary with square brackets, similar to how you would use a number with a list, but now instead of using a number, you use the actual key value. If you're using strings, make sure that the casing is exactly the same. Here we have Caleb with a capital C, and that matches up here with this capital C here. If it was lowercase here, then that would not be a match. But that is where we get this output right here. If you want to be careful about getting any exceptions thrown if the data is not found, what you could do is you could case to see if it's in the dictionary, and then if it is, you could grab it. Or a better way is to use this get method, which will return none if it's not found, or you can override the default by passing in a value here, such as not found. And in this case, we get both those results here. Now to add data to a dictionary, the easiest thing to do is just to use square brackets in the key and then assign it some value. If you'd prefer to insert multiple things, you can use the update method, pass in a dictionary here. In this case, we just have one piece of data, but you could go in and put a comma followed by another key value pair. Then there's another variation here where you can put the key like so and assign it a value, all within the update method. Keep in mind the key must be hashable, which we talked about. So here's an example of using a tuple. Here's an example of using an int, but here's an example of using a list, and that's not going to work. If you want to loop through the data, there's different ways of doing this. The first is to say 4K in whatever the dictionary name is. We'll just say emails and then print K. K is short for key, but it's just a variable, so you can call it whatever you want. And then you could actually access the data by saying emails of K. This is one way to do it, but an alternative is to actually iterate through the items and on the left say K, comma, elem to represent the element, and you can print K in the element. So that's where we get this output right here. Next up, we show an example of what you might use a dictionary for. So we basically have this dictionary of conjunctions. We have this string. We turn it into a list of words, and we count all of the conjunctions. Anytime a conjunction is found, we increase that number by 1, and afterwards, but is found once, and is found once. As mentioned, you could easily wrap this in a function to take a message and words to look for, and it could return a dictionary, but you can try that if you want. This works fine. Next up, we talked about sets, which similar to dictionaries, they use hashing, but there's no longer key value pairs, so you just put in the values by themselves. And there's no duplicates. Same for dictionaries, you can't have duplicate keys. So when we pass in sword, again, see sword already exists, it doesn't add another sword, we still only have one sword in the set. So after we print it, you can see it remains exactly the same. We can use sets to do something similar to check for certain things, but it's not going to count, it's just going to be a yes or no kind of thing. So let's say we're looking for these words, we can keep a set to keep track of which ones are seen, and then what we can do is, if it is in there, we can add it to that set. And as a result, and but are seen, but it doesn't say how many times they've been seen. Next up, we're talking about removing duplicates from a list, and this is interesting in that we're basically using the set to our advantage to remove things from the list. So we take a list, we convert it to a set, and then we convert it back to a list, and then we replace all the elements in the original list. So we're left with the same object in memory, but we got rid of all of the duplicates, and now we're just left with green, blue, and red. Now keep in mind, because sets are unordered, the order does not stay the same in the list, and you can't expect it to. You can, however, then pass this list to sorted, or use the sort method to get whatever sort you want. What next? Well, we talked about how to count individual elements in a list. So we would say red would be 1, green would be 2, and then blue would be 3 in this situation. And we did that with list comprehension, using set of colors to make it work. So we only count red one time, we count green one time, and blue one time. And as a result, we get a list of lists where the number of occurrences and the color are in each of the inner lists. Last up, we talked about different things we can do with sets, specifically unions and intersections, and then later on we did differences. So a union is combining all of the elements in the set. So all of these with all of these. And there's not going to be any duplicates. So the result for this is this set right here. You do that with the pipe symbol. An intersection is the elements shared between the both of them. So that's going to be green, purple, and blue. There are also method versions of this. So dot union and dot intersection. So there's examples on how you would use those. Next up, we talked about difference and symmetric difference. So the difference is going to be taking all of the elements of one list out of another list. So we say my favorite minus her favorite to get the colors only I like. You could do it the other way around by subtracting my favorite from her favorite, and that's only her colors. The symmetric difference is like combining both of these. So it'd be like taking the union of only my colors and only her colors. And the way you can do this syntactically is to take the original sets, my favorite and her favorite, and use this caret symbol to get the symmetric difference. And as a result, you're going to get red, black, and orange, which is all of the colors that I like and she doesn't like, unioned with all the colors she likes and I don't like. So yeah, that one's a little bit confusing. If you want to visualize these different set operations, here is a Venn diagram that you can think of. So union is going to just be everything. Intersection is this little piece in the middle here. Difference is taking just one side and nothing inside of the middle or the other circle. And then lastly, symmetric intersection is taking all of this data on one side with all of this data on the other side and nothing in the middle. So yes, that is a lot of information, but try your best to understand how this stuff works and just go through all these examples and understand the code. I know it's not that easy, I'm just telling you to understand it, but go through enough examples such that it makes sense. And that's all I got for dictionaries and sets. Stay tuned for the next section, and I'm actually getting really excited for where this series is going, so I hope you guys are as well, and please be sure to subscribe if you've enjoyed this content. Hey, what's up everybody? Welcome to a very important section on object-oriented programming. So if you're brand new to this, great. We're gonna start from the beginning and give you all of the essentials. If you have some experience, I'm gonna be teaching you how to do it in Python and give you some best practices. Now, what is object-oriented programming and why should you care? Well, what is it? It allows us to represent anything we want in our code. So far, we've represented things using integers or strings or even lists, sets, and dictionaries. But what if we want to represent something specific? What if we wanted to represent a book? Well, there's no data type book. But with object-oriented programming, we can create that type. So essentially, with object-oriented programming, we can represent anything we want in our code. So we can make applications that exactly meet our business needs. That's the basis of object-oriented programming. Now, why should you care? Well, it's actually the foundation for a lot of different things. So after we touch on the basics here, we're going to get into working with databases. We're going to use object-oriented programming. We're going to touch on graphical user interfaces. We're even going to get into web development, and all of these use OOP, which is short for object-oriented programming. Now, there are some other paradigms out there, such as functional programming and other ones, I'm sure. However, object-oriented programming is the most popular, and it's not something you can just ignore because it's probably gonna be there for the rest of your life. So lucky for you guys, you were with the best instructor, and we're gonna be covering everything you need to know. So step one of object-oriented programming is actually not objects, it's classes. And classes act as a blueprint, as you often hear them called. So when people say blueprint, they just mean that they define a structure. If you have a blueprint for a house, it tells you how to build the house, but it's not the house itself. That's how a class works. A better example that I like to use is it's the cookie cutter. When you're making cookies, the cookie cutter just defines the structure of the cookies, what shape they're gonna be. That is what the class is. So to create a class, what we do is we just say class, give us some name such as book, and by convention we use a capital letter for the first word and any word after that. Then a colon, and then inside of here we can put stuff. So for now we'll just put pass. So that means we're not actually adding anything special to this book, but we can still create a book object. So we use the blueprint, the cookie cutter, the class, to create objects. And to do that, we create a variable and assign it a new book. And we just invoke book with parentheses. That's how we create a book. So what you can do is you can actually print the type of this variable, and running this, you can see it's of type book. So this here is a book object. And now that we have that structure defined in the class, we can actually create numerous books. So I could go in here and say book 2 and create another book. This is another book object. So if you were building a library application, more than likely you're going to have a database of a bunch of books. If you wanted to bring those in memory to work with them in the application, you would represent them as objects of type book. And we're going to be doing that in the upcoming applications. We're going to be building like a little reading list thing. So this is the basis. Now, obviously, you're not just going to want to create a book with nothing in it. Usually books have things about them. They have a title, maybe a page number. So I'm going to be teaching you how to do that now. And the syntax here is going to be a little bit weird if you've never done this before, but pretty much we have to create a function inside of this class, also known as a method. When we're in the context of object-oriented programming, functions are known as methods. So here's how we do that. We say def, just like a normal function, but the name here is what's weird. You put underscore, underscore, and then we choose init here, or type it out if it didn't pop up, and then parentheses and a colon. So inside of the parentheses, what we do is we put self, comma, and then anything you want to describe each book. So I'm going to go with a title. So right now, the way we have this structured, every single book is going to have a title. And the last thing you need to do is say self.title is set the value title. So we're going to get into more what this self and all this stuff is in a really soon video. But for now, just think that whenever we say self, we are referring to the object. So we are setting the book's title to whatever is passed into this method here. And I'm going to teach you how to invoke this. So we would create a variable, and to create a book, we just say book, like we've shown you, and parentheses. But now we have the magical ability to pass in a title. And I'm going to be using this storybook I read when I was a kid. It's called Are You My Mother? And now what we can do is we can reference the book title in our code. So I have this book object, and we can access the different things on it, the attributes, by saying dot title right there. So what we could do is we could wrap this inside of a print statement like so. Run this bad boy, and look, it says, Are you my mother? All right, cool. So we created a class, we created an object, and on top of that, not only do we have this object that is a book, but it actually has a title, so we can describe the book. And this is the syntax to do that. So you need to kind of just memorize how to do this, and we'll get more practice with that in the upcoming videos. This method here, init, is often called the initializer, or you might even hear it called a constructor, because it's very similar to the way constructors work if you're coming from another programming language. Basically, it is what is invoked when we create a new book. And just to prove that to you guys, if you don't believe me yet, we can go in here and we can do a print creating book. And when we run this, it's going to say creating book right here because it's invoked when we do this here. So that's your introduction to classes, objects, and the initializer. So stay tuned for the next video because I'm going to be teaching you how to create another method inside of our class so that we can do some more stuff with our book. So stay tuned. Hey everyone, welcome back. This video, I want to talk about methods. So you got your first taste of methods here when we created this init, and this is invoked when we create a new object, such as here. However, we have the ability to create other methods inside of our class. So an example of this might be to check if a book is considered long. And yeah, I know a long book is subjective, but just for learning's sake, we're going to say a long book is anything over 100 pages. Because honestly, my attention span is like the size of, what was I saying? Anyways, we're just going to say is long. And anytime we create a method, we have to put a parameter here, self. Now inside of this method, all we have to do is return true or false. So we'll say if, oh, now I just thought of something. We don't actually have a way to see how many pages this book is. So that's another thing we can set up here. So not only is a book going to have a title, but it's also going to have a number of pages. And then we just say self.pages is set to pages. So that's going to be passed in when we create our object. So comma, we'll just go with 72. So now we have a book called Are You My Mother? And it's 72 pages long. Inside of here, we can reference that by saying self.pages. If it's greater than 100, what are we going to do? We're going to return true. Otherwise, we're going to return false. All right, so now down here, not only can we print the book title, but we can actually print book.isLong and invoke it like a function because methods are just functions attached to objects. So this is a method by terminology. So functions and methods are the same thing, it's just what it's attached to. It's attached to an object. So what about this parameter here, self? We actually don't have to pass anything into that. It's implicit. So self refers to the object we're invoking it on. So we don't actually have to pass anything in here. Same thing for this initializer here. We're passing in title and pages. Are You My Mother? 72. But we're not passing anything to self. We don't have to worry about that. All right, so let's run this. And it looks like we get false. That's because the book is 72 pages. However, if it was 720 pages, better believe I ain't reading that. So now it is true. It's kind of funny though, because literally every programming book is like 1,000+ pages, and I use a stack of them to hold my laptop up. So if you find yourself reading 100-page books, consider yourself lucky. All right, so that is your introduction to methods. Again, this is going to be independent for each book. So what that means is I could actually create another book, book 2. We're going to create it the same way, but now we're going to use a different name. And let's just for a second just say test 200. And now let's print book2.isLong. So notice that this method is available on book and it's available on book 2. Any object of type book is going to have this method. Running it, and we get true for this one because it's 200 pages. So there you go, guys. That's your introduction to methods. Stay tuned because we're going to be learning more about object-oriented programming. Hey everyone, in this video, I'm going to be talking about class level attributes. So first, let's make sure we're on the same page with the word attribute. So right now, every book we create has a title and a number of pages. These describe the book, and therefore they are known as attributes. However, we can create attributes, or just variables essentially, at the class level rather than at the object level. So what's that going to look like? We would create one like, let's say favorites, and this is just going to start as an empty list. And notice we're not saying self like we're doing here. So when we say self, it refers to the object. When we're not using self, it just refers to all books. It's defined within this book class. So when we're talking about a list of favorite books, that does not describe one individual book. That's something that's shared among all of the books. Every book can be a favorite. So how do we use something like this? Well, let's go down here and we're going to get rid of these print statements. We are going to create this book, and we're also going to create another book. So we'll say book 2, and this is going to be another children's book I read. Well, I didn't really read it. I didn't like it, but it's called The Diggingest Dog. I'm pretty sure these are the only 2 children's books I remember, and I'm going to be using them throughout this whole series. So you guys should probably just rent them and read them. They're pretty good reads, at least the first one here. All right, so this one's going to be 72 pages as well. So now what we can do is we can say book referring to the class, see the capital B here. So I'm not referring to the object. We're referring to the class. And then dot favorites. So it's accessible on the class. And then dot append, and we can put our favorite books in here. So we'll put in book, and I'm also going to execute this again and pass in book 2. All right, so both of these are being added into that list, and what we can do is we can print book dot favorites. All right, run this, and it looks like the output is a little weird, and we're going to fix that soon. But for now, just know that this represents that first book that we added, and this represents the second book. If you want it to be a little bit prettier, what you could do is just say for B in book dot favorites, print B dot title. All right, so for every single book in this list, we're going to print its title. So that's what that code does, and running this, and you get the 2 titles. And that is how you create a class level attribute. Next up, I'm going to be teaching you how to make printing an object a little bit clearer. Because if you go in here and you change this to just B, so we're just printing the object, well, running this, we get something really ugly. So this talks about what type it is and where it's located in memory. However, I want a prettier representation, maybe saying the book's title and how many pages it is. So stay tuned, that's what we're going to be talking about next. Hey everyone, in this video I'm going to be teaching you how to override the string method or the str method for a class. So pretty much anytime you print an object, it is going to print the string representation. By default, you get something like this, which says the type and memory address, which is not the most pretty representation, so you can actually override this and create your own. So to do that, it's going to be very similar to the way we created this initializer here, in that it's going to have 2 underscores at the beginning and end. So let's go in here, and we'll just put this after our isLong method, and we'll just say def underscore underscore stir underscore underscore parentheses, and then pass in self. All right, so here is where we can define the string representation of our objects. All we have to do is return a string. So just to show you guys, I'm just going to say return the string 5, and running this, and we get 5, 5. That's because it invokes this stir method every single time we print an object. Obviously, we don't just want to print 5, so let's customize it, do some string formatting, and I'm actually going to do an F string here. So with this, anything that's a variable you can put inside of curly braces. So we'll just say self.title, and then is the number of pages, self.pages, and then I'll just put the word long. All right, run it now, and it says, "Are you my mother?" is 72 long, and I forgot the word pages, so 72 pages long. The diggingest dog is 72 pages long. That is a much better string representation, and that is how you do that. So when we pass an object to print, it's automatically going to invoke this method on the object. Well, there you go, guys. In the next video, I'm going to be teaching you how to override another method so that we can compare books to see if they are the same. Stay tuned. Hey everyone, in this video, we're going to be overriding the EQ method or the equals method so that we can compare books. So when is this method going to be used? Well, let's say we have two books, which we do. We created two books here, and we say book is equal to book 2. So we're comparing two book objects, and running this, it's going to be false. The default behavior of the double equals when working with our custom objects is to see if the books are the same area of memory, the same exact object. So in order for that to happen, we would have to set book 2 equal to book. And now we get true. However, I don't really like that implementation. I'd much rather prefer it compare it by title and page number. So in that situation, it's going to be where we have two books, but let's just say they have the exact same data. Are you my mother? Printing it now, we get it to say false. However, I want it to be true in this situation, because in my brain, these are the same books. Your brain might be different, so you can custom program this however you like, but I'm going to show you how to set it up this way. So what we do is we override, let's make sure we're at the right indent, underscore underscore EQ, and this is going to have self as a parameter, but not just self, it's going to have another one, which is the thing we're comparing against. So I'll just call that other. So in here, we can return true if they're equal or return false if they're not equal. So let's just check if self.title is equal to other.title, and we're also going to check the pages. So self.pages is equal to other.pages. If this is the case, we're going to return true. Otherwise, we're going to return false. All right, so now this comparison should be true, and we get true, so it's working. And just to check it, what we can do is we could put two different books in there, such as these two, not the same. They have the same page numbers, but not the same title. And running this, we get false. Now, if you're having a hard time understanding here what's going on with self and other, what I want to do is I actually want to print both of them. So we'll print, and we'll say self, pass in self. And then we'll print other, and pass in other. So now we should be able to see what these two are when we run this. And you can see self is the one on the left, and other is the one on the right, book 2 in this case. And they're not equal. So I'm not going to leave those prints in there, but just so you could understand what's going on. Now, when you override the equals method, it's considered best practice to deal with another method called hash. So stay tuned for the next video because I'm going to be talking about that. Hello, you beautiful people. This video, we're going to be talking about the hash method. And we're going to scratch the surface of this. This can get pretty complex, but essentially, when we override the equals method, it is best practice to deal with the hash method. And I say deal with it because there's two things we can do. We can create our own custom implementation for it, or we can just say, hey, we're not going to have a hash method. And you'll see what I mean in just a second. So first, let's just take a step back and talk about what the hash method is used for. Well, it's for any of the hashing data structures, which includes sets and dictionaries. So let me show you an example of this. When we go in here and we create a set, and let's say we pass in book, and we'll also pass in book 2. So we want a set of books. Well, we run this, look at this, unhashable type book. So what in the world? This is basically implying that anytime we put something in a set, it gets hashed, which is true. So if instead of books here, we just passed in hello and hi, well, these are two strings. These are hashable. And in this case, we don't get any errors. The same thing applies for the keys of dictionaries. So if I instead made this a dictionary where hello is the key and hi is the value, this is fine. We don't get any errors, and I'm going to get rid of this print because it's annoying me. All right, so now we run this, we don't get any errors. But if instead for this, we tried to use a book, well, heck, now it gives us an error. When it comes to the value part of a dictionary, you can use whatever you want. So I could keep a string on the left here and pass in a book on the right. And in that situation, we're totally fine. We're not getting any errors. That's because the value itself is not hashed. Only the key is hashed. And we talked about sets and dictionaries before object-oriented programming, so if you're jumping in, you can back up to like video 50 something. That's where you'll get that. Another example of a type that is not hashable is a list. So let's say here we tried to instead use square brackets. Well, now we're going to get an unhashable type list. So you guys can now see where hash comes up. Now let's talk about what you actually do for it. Well, if you don't want your data structure to be used for hashing, then all you have to do is, well, one, you don't have to do anything right away, but best practice is to actually put none for hash. So in that situation, you would just say underscore underscore hash underscore underscore and set it equal to none. This is kind of like explicitly telling people, hey, this class is not supposed to be used for hashing. And when would you want to do this? Well, you would want to do this for mutable types. So if you're going to be working with this book and you're going to be updating its title and its number of pages, or if you had some other fields in there, maybe your progress or something like that, well, then you're not going to want to worry about hashing because you shouldn't hash mutable data. That's because typically the hash is derived from the data it's storing. So if you're updating the data, well, then the hash can change, which is not good. Or if you're just really careful, you can use mutable data for hashing. You just shouldn't be changing it. So just don't change objects that are being used inside of a dictionary as keys or inside of a set. All right, but enough rambling. Let's just show you how you would implement hash if you wanted to. Now I got this solution from a book, Mastering Object-Oriented Python, so credit to them. But essentially what you do is you would override the hash method by saying def hash, pass in self, and in here you can actually just hash the individual components of the object and exclusive OR them. So I'm going to show you guys how to do that. What you do is you would say hash of self.title, and then a capital 6 upward caret arrow thingy-majig, and then hash of self.pages. Then all you have to do is put a return. All right, so that should be good. Now you could actually use this in a set. So we could say books, and we could add book 1 and book 2 here. And running it, we're not getting any errors. So let's just take a look at what these hashes would be. So we will print the hash of book. So that's the object we created here with Are You My Mother and 72. And running this, and we get this number here. So what I want to do now is I want to change the data of book. So we'll say book title and set it to something else. And then I want to print the hash again. So it's going to print it once, change it, and then print the hash of the book again. And running it, you can see we get two different numbers. And that's the problem. We don't want our hash to be changing, especially because the hash is used to derive an index location for these data structures. So all of that happens behind the scenes, but we should just not change the hash. Now, a couple of other rules for hashing. If two objects are considered equal based on this here, well, in that situation, they should have the same hash. So in other words, if we had two books, and let's say they had the same exact title and the same number of pages, we should be able to print to see if they are equal. And if they are equal, then their hashes should be the same. So if we pass these to hash, we should get the same value. All right, so let's clear this out and just see what we get. Running this, they're not equal because I did it wrong. All right, there we go. Let's add that question mark in there, run it now, and we get true, true. So the books are considered equal, the hashes are the same value. The other thing is if objects are different, they don't necessarily have to have different hashes, but generally that's a good thing. But if for some reason you have two objects that are not the same, but they have the same hash just by coincidence, that is okay. So again, just to summarize the rules real quick, hashes shouldn't change. An object's hash should remain the same for the entire execution of the code. And two, if two objects are considered equal, then their hashes should be the same. And third thing, a side note, if two objects are different, their hashes do not have to be different, although that is ideal. There's probably some other hashing rules out there, but those are the basis, and hopefully that was helpful and not just a bunch of useless information. But stay tuned, because we're going to continue our discussion on object-oriented programming. Hey everyone, in this video we're going to be talking about the ID of objects, as well as passing objects to functions and if they're changeable inside of those functions. So we're just going to get a little bit more clear on working with these objects. So the very first thing you need to understand is the concept of an ID. So what we could do is we could print ID of book. And what is the ID? It's referring to the identity of an object. And it's guaranteed to be unique among objects in existence. So it uses the object's memory address. So if two objects exist, they are always going to have different IDs. So let me prove that to you here. I mean, I can't prove every single case, but I can give you an example. ID of book and ID of book 2. These should be different numbers. And indeed they are. This one ends with 808 and this one ends with 608. So we got two objects in memory and they have different IDs. Even though they have the same data, they are considered different books. We basically created two of the same books here and they both exist. This is 100% different than if I did this. If I said book 2 is assigned book, well now these refer to one book. We basically created two variables to point to the same book in memory. And running this now, you can see these have the exact same ID. So comparing the identity of an object is a lot different than comparing the values of the object. So if we wanted to compare to see if two objects were the same in memory, here's how you do it. You say book is book 2. And running this, we get true. Basically, it's a shorthand of doing print ID of book is equal to ID of book 2. These are going to give the same exact thing. They both say true. This is different than if they happen to have the same data. So in this situation now, they are the same in terms of their data, and they're even considered equal. Book is equal to book 2. However, they are different books in memory. So we get true, false, false. It's just like what we expected. This is important when we are dealing with functions and passing objects to these functions. So I want to create a function to illustrate some of these points. We'll just give it some useful name like do something. And this is going to take a book. And what I want to do with this book is I want to change the title. So book.title, we'll just set it to something new. After the function definition, we're going to invoke it, do something, and pass in our book. We actually don't need the second book here, so we're just going to toss that out the window. And after this, we're going to print book.title. Or actually, we can just print the book because it'll have the title in there. Running this, and it says something new is 72 pages long. So what you should get from this is, one, functions can change the data of objects. And that was the only thing I had to say, so just one. And what else in here is that we can print the ID of book just to kind of obnoxiously follow it. So let's get the ID of book and we're going to print it. We're going to do that there. We're going to do it when we create it, if I can get the indentation right. And we're going to do it here as well. So we print the ID when we create it. We print the ID before we change the data inside of the function, and then after we change the data. And running this, we get the same value 3 times, exactly what we expected. But now I want to try something different and actually assign this a new book. And it's going to be called something new. It's going to be 72 pages long. Well, in this situation, we're actually creating a new book in memory, and we're basically replacing where this variable points to. So running this, we can actually see a change in numbers right here. So this print is actually printing a different area of memory. And anytime we replace the value of a variable within a function, that does not persist on the outside. So outside of here, we are still getting "Are you my mother?" from the original creation. So lesson learned, just to conclude this, passing objects to functions, we have the risk that the functions change the data. If the function replaces the data with a new object, that does not alter the original object. As soon as we assign this a new object, that original reference is gone. This concept of how these objects are passed is known as pass by object reference. So we're passing a reference to an object, but if we replace that reference, then there's no longer a connection there. So hopefully that was helpful. What we're going to do now is we're going to start reading data from text files, and ideally we get to the point where we can read these objects all from a text file, and then we're going to move to a database and just keep building up the complexity. So stay tuned. I'm excited. Hopefully you are as well. Hey everyone, welcome. This video I'm going to be teaching you how to read and write to a file. So this is the basis for file I/O, and eventually we're going to move to a database. So I'm pretty excited. Make sure you are up to speed with the code we have here. This is like the main important stuff, just a book class with a title and pages. However, some of the stuff might come up as well. And then we're just creating a book object down here. So get up to speed with this. And now I'm going to zoom in a little bit and go down to the bottom so we can write more code. All right. So first thing, writing and reading from a file is actually fairly easy in Python. And the easiest thing to do is actually have Python generate that file for us. So I'm going to be showing you guys how to do that first. This is a lot more convenient than having to worry about where to put it in the file system or anything like that. So all we do is say open and pass in the file name. So we'll just call it input.txt. And to get Python to create it for us, we're going to open this in a special mode called append, which would allow us to append data to this. So just pass a inside of a string, and let's just try this out. Run, go to your files, and what? Look at that, we got an input.txt. You can call it whatever you want. You don't even have to have the .txt. So I could go in here and just put input, run it, and look, it makes an input. So that's how you can just create files really easily. But I'm going to get rid of that one we just made. Just keep input.txt. And now I'm going to be teaching you how to write to this file. So in my opinion, the easiest way to do that is to actually put a W here for write. Anytime we run through this code, it's going to override whatever's in that file. So it just makes it easier, so as we're learning, it doesn't just append a ton of junk to the file. This will keep it fresh every execution. So to do this now, we want to actually keep a reference to the file such that we can continue to work with it. So we'll assign this to a variable like so. Now to write to the file, all you have to do is say file.write and pass in some string. So as an example, I'll put test, execute it, and what we're going to do is we're going to open. I thought I deleted you. Oh, I forgot to change it back. All right, so we'll change this input.txt, run this, and that should go inside of this input.txt, and I'll get rid of this other file. So input.txt right here, and it says test. So congrats guys, you efficiently created and wrote to a text file. If you pretty much wanted to create it if it doesn't exist, all you would have to do is have this open above here and change this to A. So now it's going to open it, and if it has stuff in there, it's not going to hurt it, but if the file doesn't exist, it'll create it. So running this, we don't get any errors, and input.txt has the same exact information. So what would we want to do with this text file? Well, my first thought is to represent data. So let's say we wanted to have a book in here. So we might have, "Are you my mother?" And let's say we separated the title from the number of pages using a tab. I mean, you can represent it however you want, whatever is easiest for you to parse in your code. So I'm going to use tabs, and I'll teach you how to work with those. And then you can have a number of pages. And then it'd be cool if we had another book on the next line, and then a tab and the number of pages. So I think that's the ideal structure. And then you could easily go into the input.txt. You could add books yourself, or you could read what it looks like, however you want to do it. So let's try to do that in code. So we'll get rid of this here, and instead of just typing it out, we're actually going to do it in this write. So, are you my mother? /T 72. I think you could actually just use a tab if you wanted, like so. End that with a new line, and then you could put the next book here, or if you just like to keep your code a little bit cleaner, you could write another one. It's going to be the last one, so I'm not going to put that new line in here. And now we could replace this book. Digging ist dog. That's kind of hard to type for some reason. All right, so let's run this and take a look at input.txt, and look at that. Wow. And check this out. I could actually split these. And now we can see the input.txt while we are working with our code. Next up, whenever you're done working with a file, you want to say file.close. So that is beginning to end, how to open, write to, and close a file. Now let's do the opposite, and I want to read from this file. So we open it the same way. We just say open, pass in a file name, input.txt, comma, and this time we're going to use R for read. Now this is probably the hardest part, which is figuring out how to get the data and parse it properly. So let's just say data, and we'll say file.read, and then print data. So printing it, and it seems to work. And actually this read here will return a string. So that's not exactly what I want, because just having a string of all of the data is a little bit sloppy. I would much rather have a list or some structure like that. So what you can do is you could use a split and pass in the new line character. So now the string is going to be split by line. Running it now, and you can see we got a list, one element here, and then another element here. At this point, we're done reading from the file, so we can just say file.close, and we can continue to work with data beyond the file being open. We read it, get it in a variable, and then close the file. We're done working with it. So this should work just the same, but now what I want to do is actually want to parse this a little bit farther so that we don't just have a string with a title and a number here. So we can actually split based on the tab character, because I assumed there's not going to be very many titles that have a tab character, hopefully. So that, in my opinion, was a good way to split it, although you could put it title on a line, page number on the next line, next title on the next line, however you want to do it. So let's try to get the first book out of here. So what we would do is we would say book one, we'll just say book one data, and we're going to get the first element inside of the data list. So we want to grab this one here, index 0, dot split. It's a string, so we can use split, and we want to split on the tab character. So that's going to return a list and assign it to book one data. We could then use book one data to actually create a book object. So book, we can call it book or book one, it doesn't really matter. I'll just be consistent with what I got here. So book one is a new book object. The title is going to be book one data index 0. The number of pages is going to be book one data index 1. And then we can print book one. So if you want to see this out just a little bit more, we can print book one data here so we can follow along. So let's run this. You know what? I think we're getting an error because Visual Studio Code replaced my tab with spaces. So I am going to get rid of that and put a T there. I think this should work now. So running this, all right, there we go. Man, that could have been a really nasty bug if I didn't think. So we start with this master list, Are You My Mother, tab 72, and then the digging is dog, tab 72. Structurally wise, it still looks exactly the same in the input.txt because those /t's are rendered right here. Then what we do is we grab that first element by saying data 0, calling the split method to split it out into the individual elements of Are You My Mother, and then 72. Then we grab that first member by using 0, so that gets the title, and then 1 to grab the next element, which gets to 72, the number of pages. We pass both of those into a book initializer to get a new book object referenced by book 1 here, and we can print book 1 and get that object. So yeah, like I said, the reading is actually the hard part. Writing is pretty easy. We could do the same thing with another book here. So book 2, and then what we would type in here is data index 1 dot split by the tab character, and then we'll just grab the title of that. And we can actually just do this a little bit shorter here. So we could pass this to book like so, and then again with index 1. So maybe that's a bad way to do it, but either way, it should get the job done. I'm going to drag this text file over a little bit so you can see. And then after this, we will print book 2. Run this, and it works. So hopefully you're able to follow along with that on reading and writing to files. My concluding thought for this is that if you're working with something very simple, a text file can do the job. You don't always need to have a database. If you're just doing a configuration file or something like that, just do it in a text file. However, you can see that if things get pretty complex, parsing the data is going to be a living nightmare. So in that situation, a database is going to be better. We have about 2 more videos to go, and then we're going to start talking about working with databases, which I'm actually really excited for. If you guys know me, I actually started this YouTube channel with database junk. So looking forward to work with that. But for now, we're going to go into this just a little bit more and talk about a very useful keyword, with. So stay tuned, I'll see you then. Hello everybody, in this video I'm going to introduce exceptions. If you've been following along, I said we were going to talk about with in this video, although I decided to move that to the next video because this is some fundamental knowledge for that. So exceptions, it's kind of been the thing I've ignored this whole series, but anytime we get an error pop up in the terminal, that's an exception. So here's a simple example. If we try to open a file that just doesn't exist, we're going to get an exception. Now you can have Python create that file as I showed you earlier. However, if you just try to read from a file that doesn't exist, you get a file not found error. So wouldn't it be cool if you could basically say, hey, I want to try opening this file, but if there's an exception, don't, or like tell the user we can't find it or something like that. So let's try that. So to do that, we say try and indent everything like so. And when you do this, what you do is you say except, and you can build upon that, but let's just start here, the absolute basics, and we'll just print cannot find file. And I'm going to zoom in just a tiny bit here. Too much. So let's try this. And running it, now it just says cannot find file. Rather than just barfing a bunch of junk in the terminal, we get a nice output. So it's much more consumer friendly for the user of the application. And when it comes to databases or reading from files and stuff, we don't necessarily want to give all of the details about errors, as it can eventually become a security risk. So in an ideal world, we always give them a nice user-friendly version of whatever the error is. Such as this here, it just says cannot find file. It doesn't give them a bunch of jargon. Now there's all kinds of different exceptions, and you can look up Python exception types if you want to know that whole list. However, a very general one is actually called exception, and you can specify that here and give it a name. E in this case, that's just a variable name, and pretty much the exception will be accessible through an object called E. So what we could do is we could work with E, and just for now we'll just print E. And running this, we get the string representation of that exception. So that's a very general exception, but there are more specific ones. So for example, we could go above this and say except file not found error as E, and then print E. So this is where you could be a little bit more specific. You could say cannot find file, and then down in the one down here, you could just say something went wrong. You can decide to print E if you're debugging or whatever, but ideally for production, you're just printing nice things like so. All right, so now it says cannot find file because that one is hit before this one down here. If, for example, this text file existed, so we'll call it input.txt, I have it created. You can go and create it if you want. It's just some strings, it doesn't really matter. And let's say we try to read from this and just do something stupid like a bad cast. So we would say file.read, and let's just pass this entire thing to int. So this is going to cause an exception, but now it's not a file not found error, and instead it's going to hit this one here. So it says something went wrong. So there's a few things that is up to you. That's kind of an art, and that is, one, how much stuff do you want to put in the try? Generally, I like to keep it to one whole thought. You know, you're trying to do something, you're trying to read from a file, you're trying to parse some data, whatever it might be, but I like to keep that whole thought in that try. You don't necessarily want to put your entire program in that try, but it's also not very good to have a quadrillion tries throughout your code that are very, very small, in my opinion. So a good average size is nice. If you start adding more and more to the try, you'll find that it's harder to be specific on what went wrong because you're not entirely sure. And if that starts happening, then you might want to restrict the try size and go to another try block later on. That's helpful for the consumer and you because you want to be able to give them more helpful errors than just something went wrong. Now there is another thing you can do in here, and that is a finally, and this will always run. So even if an exception is raised, it will always say this line here. So this is usually done to clean up resources, whatever that means. It's pretty much a general way of saying closing files, closing connections to databases, doing any saving, anything that's important that needs to be done in case your program explodes. So you can close files here by saying file.close. So you can see that we open the file here, we try to open it, and then we close it down here in the finally. And there's actually a shorthand way of doing something like this, which is what we're going to be talking about in the next video. And that is the with keyword. So I will see you there. Hey everyone, in this video I'm going to be teaching you how to use the with keyword to automatically close files after opening them. This is ideal because if you're parsing through the file and an exception happens, it'll automatically close and you don't have to worry about putting that inside of a finally block. So let's take a look at what it might look like. We would say with, and then we open a file, and we'll just say input.txt. We have that file in existence right here. And then you say as and give a variable for the file to be stored in. So we'll say file. And in here we can check to make sure that the file has been opened, just to show you that afterwards it's closed. So we will say if file.closed, and then we'll say if not. So if it's not closed, then what is it? It's open. So we'll print open, and then after the with, we're going to make sure it's closed. So if file.closed, print closed. So if this is working properly, this should print and this should print. So we should get open closed in the terminal. Running it, and we get both of them. So it seems to be working the way we would expect. So now all of your file parsing stuff can go inside of the with indented. So right here is where you would do file.read or whatever you're trying to do. For now, I'm just going to put pass, and we're going to get rid of this code here. So it works, it's doing what we expected, but there's one issue, and that opening the file itself can cause an exception. So for example, if we put something in here that doesn't exist and run this, now we're getting an error. It's a file not found error. So if there's an error parsing the file, it's automatically closed for us. But if there's an error opening the file, it doesn't get opened. So we need to worry about a try catch for opening the file. And I'm going to show you a syntax on how to do this. So what we'll do is we'll actually delete this. And we're going to open a file like normal. So we'll just say file is open and pass in something like input.txt. And now we would wrap this in a try. So we'd say try, like so, and we can catch any exceptions down here. So we'll just put OS error, which I believe will include file not found because it inherits from this. You can say as E or whatever you want if you want to give it a name, but if not, we'll just print cannot open. So let's just check it out, make sure it's working. So we'll put in a file name that we can't find because it doesn't exist, and run this, and it says cannot open. So it seems to be working. And what we can do is we can say else which will execute if the try is successful. So if there's no exceptions thrown when opening, assuming we got a correct file name and everything, then we can do the with. And then we don't have to worry about closing the file. So it's a little complicated. It took me a while to figure this out, but we just say with file, and here is where we would put code to parse the file. So as an example, we'll just print file.read line. And running it, and we get our first line here. So that is the basis, but just as an extra piece of information, if you want to do more tries inside of this with, you can, and that would be used if you want to try to do something that might raise an exception, such as parsing the data a certain way. So if you want to do that, you would put it inside of the with here. You don't have to worry about doing file.close in the finally though, because it's all within a with. So that is your introduction to with. Stay tuned for the next video. We're going to review everything we've discussed since the last review, and then we're going to get into databases. Hey everyone, welcome. We're going to do some review on object-oriented programming, which is up in my GitHub under this file right here, as well as objects and IO, which you can get on this one here. So 8 and 9, let's get started. So going back to when we just started object-oriented programming, we created literally the most basic class that had absolutely nothing defined in it. But this class can still be used to make objects of type book. So book is a variable that refers to a book object, and we print that, and you can see that right here. It's a book object and then the memory address. When you print the type of book, you can see it's of type book. We can check the type dynamically using isInstance, so we pass in the book variable and check to see if it's of type book, and you can see it says it is indeed a book, read it. Using this class, you can create numerous books. So here we create book 2, we set it a title, and this is interesting because we can actually set the attributes after we create the object. So we just add a title to this book and we print that title, and it comes out right here. But since every book has a title, it would make more sense to put this as part of the structure, which we show you how to do by creating this method here called __init__. And this requires a self parameter. We don't have to actually pass anything to that. It's implicit. That refers to the object. So we are setting the object's title like so. And this title here is what we actually pass in. So when we create a book, we pass in that title and it gets assigned to the attribute title on that object. So we can print book title and book 2 title, which gives us this right here. Now, if you were to try to create one without a title, we get an error. So that's why that's commented out. You can also give it a default if you want. So we defaulted it to none. And in that situation, you don't have to give it a title. And doing this will print none. This is different than trying to get a field that doesn't exist, because for example, if we tried to print this book.test, it would fail because .test doesn't exist. So title exists, it just doesn't have a value. So it's like a slight distinction there, but just make sure you understand that. Getting book.title is okay, we just get the value none. Getting book.test or anything that doesn't exist, that's going to give us an error. Next up, we talked about creating our own methods in the class, and to do that, we just define a function like usual, and we put the self implicit parameter in the parameter list. Here we created a log method which just prints to the console. We also did an isShort method which will print true or false depending on how long the book is. So when we create a book that's 72 pages and we check to see if it's short, it's going to say read the book because it's actually less than 100 pages. So that's why it says read book down here. Next up, I got some other code in here, but nothing too important. What we're going to do now is look at class level variables. And in this situation, the variables are tied to the class level. And in this situation, the variables are accessible through the class. So for example, I have this faves list. You can access this by saying book.faves, and then we can append data to it like so, where we append book and book 2. Printing that, and we get this default output here. That refers to the first book object, and this is the second book object. Next up, we talk about how to replace those default outputs with a new, and that is using the str override. So that's going to look like this here, where we actually return the title and the number of pages. While we're at it, we also replace the equals method, which will compare the fields. Self.title is equal to other.title, and self.pages is equal to other.pages. If they all match, then we will return true, otherwise we return false. I don't want to get into it a whole lot in this review because it was a lot of information, so if you want that, go check out my video on hashing. But for this class, I'd probably just go with this, underscore underscore hash underscore underscore is equal to none, which this just explicitly states that book objects are not to be used for hashing data structures, and you can't get the hash of the object. All right, then we go through some more examples where now we take a book and we print it, and we get the output that we created, which is the book title and the number of pages long. We can also compare books, so we have another book, it's a different book object, same data, and they are considered true. Are they the same object though? You can check that with is, and it is false. So that is our introduction on object-oriented programming. Next up, I want to talk about working with these objects. So that is in the 09 file. So if you want to get that up on GitHub, you can. That's going to be right here. Very first thing in here is we just create this class again because we're going to use that throughout. So same exact thing as the class in the previous file. And then we just start working with these objects by passing them to functions. So here we have a function that modifies the title. And when we do this, the change is seen outside. So we change the title to something else and we print it on the outside down here. And you can see the change persists. So functions can change object data. Then we go through this with a little bit more detail of printing the ID, and you can see the ID is the same every single occurrence. Then what we do is we do a variation where we're actually reassigning the parameter. So inside of the function, we are assigning a new book, and when we print this data now, we're going to get a different number. We pretty much replaced that object with a different one. Those changes do not persist. So the original book title, Are You My Mother, is what's going to show up when we print it on the outside here. So in other words, functions can change object data, but they cannot assign new objects. Next up, we talk a little bit about reading from files. So we open a file, input.txt, with the append option. That's going to create it if it's not there. Then we open that file with a write, which will overwrite anything in that file. We write some data, so we write Are You My Mother with a tab, 72, a new line, and then another book down here. So that file is going to look like this here. And now what we do is we read from this file, split the data, and print it, which gives us this right here. This is where it gets a little bit complicated in terms of parsing, and you could do this in literally millions of different ways. I just decided to structure it this way. You can decide to structure it another way, but pretty much we split this first string into its components of Are You My Mother and 72 pages long. And the way you do that is you grab that first list element, split it by the tab, and then create a new book with that data. We do the same thing with book 2, so you can see that there. Then what we do is we print book and book 2, which is where this output comes from. Cool beans. Next up, we talked about exception handling. So ideally, for an actual production application, you put a lot of stuff inside of a try. And then if an exception is raised, you can catch that exception by putting except and then some exception type, and optionally, well, actually the type is optional here as well. You could just put except : but you can catch a specific type and even give it a name to reference it in here. So this does not exist. So an exception is going to be raised and we get file not found, error, and this right here. Additionally, we can be very specific on what type of exception we want to catch to do different things. So in this situation, we would imagine a good amount of code in this try block, and we're catching all different types for whatever could possibly happen. Most of this is dealing with file IO, so file not found, OS error, which actually this inherits from that, so it's just a more general version. And then some other stuff in here, and then lastly exception, which is very general, and then a finally to close the file. if an exception happens during the parsing, which actually would because we're parsing it to an integer, which isn't going to work. So it says cannot parse data, check file, and this always runs, which comes from the finally. Next up, we talk about the with keyword, and I'm just going to touch on this real quickly because we just talked about that. But essentially, you can have your file automatically closed for you, and even if an exception happens within the open indentation, the file will still be closed. You'll probably still be using tries and excepts if you're trying to do things properly, but you never have to worry about that file staying open. And it's usually not a huge concern, but it is just considered best practice to close that file anytime you open it. So here's how you can check to see if it's closed, just to prove to you that it does in fact close by line 145, and that's where this true comes from. And lastly, I just talk about opening the file itself can throw an exception. So here's two different ways of dealing with that. This one would catch pretty much any exception either from opening the file or once the file is open, or what I showed you in the previous video, which would separate those out. So we could catch an exception if it fails to open, then we could do another try inside of the else here if we wanted to just deal with errors from parsing or whatever else we might be doing here. So, wow, that is a lot of information, and honestly, I can't cover all of that in just this quick review. So hopefully that was not just total brain barf, and that you actually got something from that and solidified it in your brain. Stay tuned for the next video because we're going to start talking about databases, and I am literally stoked. I'm excited. So stay tuned, be sure to subscribe, and I'll see you then. Hey everyone, welcome back. This begins your section on databases. We're going to start working with a database called SQLite. And this is actually built into Python, so it's really super easy to get started. And the information you learn here will likely transfer to other databases as well. Now, I do have a bunch of database videos on my channel, database design and SQL. If you need that extra background, those might be good for you, but we're gonna try to just dive in and build an application using a database. So the first couple videos here, we're gonna learn the foundation, how to work with the database and so forth, and then the end goal is actually want to create a very simple reading list that'll allow us to store books we wanna read, and we can delete them from the list as well, or update them, or whatever we need to do. The purpose here is to show that we can maintain the state of the application even if we X out of it. So you close the application and you reopen it, and it still keeps our list of books. That's because that information is stored in the database. We did a similar thing, but it was like much smaller scale with writing to text files. This allows us to write information from the text file and then read that information next time we open the application. However, this is not really ideal for large-scale applications, and if you're going to do anything complex, you probably need a database. Fortunately, it's really easy to get started. All you have to do is say import SQLite 3. Then you make a connection. So to connect, you say SQLite 3.connect, and here you can pass in the name of the database, or you can say that you want the database to be in memory. And this is ideal if you want to keep that database in RAM so that we can work on our application, do some prototyping before we actually create an official database. So we're going to start by working with memory, and then we'll move to a concrete database. So we're going to put this in strings, and to do it in memory, you just put memory, and this is going to be in 2 colons. So a colon at the beginning and a colon at the end. Now, in order for us to work with this database, we actually need to keep a reference to this connection here. So to do that, what we're going to do is we're going to assign this to a variable, and we will just call it con. So anytime we want to refer to that connection, we just say con dot, and then there's a bunch of different things we can do. So we can run this as many times as we want. It doesn't give us any problems or errors, but it also doesn't actually add any files into our open folder here. If instead we put the name of a database here, so for example, we just called it example.db and ran it, well now that's going to show up as an actual database file. So that's the difference between running it in memory and using an actual database file. The actual commands to work with the database is going to be the same. The only difference is memory is not going to create a file on disk. It's just going to have it in memory when the application is running. Now we're actually going to go back to the memory option. So we'll put memory here, and we can get rid of example.db. There we go. Now we're going to be working in memory. And the only other thing you need to do to start working with this database is you actually have to create a cursor, which is a tool used to work with the database. So what we do is we say con.cursor, and then we're also going to store a reference to this. So we'll just call that C. So once we have that cursor, we can say C dot, and then these are the different methods we're going to be using to work with the database. So that builds the foundation to start the next video where we're going to create our first table. Now there's one extra piece of information that I want to call out here, and it's not vitally important that you understand it right now, but just wanted to get it out on the table because it might come back in the future. And that is if you are working with a folder and that has your Python file in there, and let's say we're not working with a memory database, but we actually have an actual file, db.db. Well, when we run this, it creates that database file for us, but it doesn't create it inside of the folder. So it can lead to some confusion as to where the database files go. And this is built off the principle of the current working directory. So where the actual directory we're working with in the terminal is where that database file is going to appear. So you can see right here, we're in this example folder, which is where the test folder is inside. So that's why it shows up in the example folder. If instead I said cd test, now we are in that new folder we just created. And if I run this file again, it creates db.db inside of that folder. So just be clear where you're at inside of the terminal, and you can see that path by saying pwd. This is the path where that database file is going to be created once you start working with database files instead of the in-memory database. I just wanted to call that out real quick because the examples we're going through are up on my GitHub account, and I do have a folder structure on there, so if you're working with that, you might have this situation where the database is showing up in a different folder than you might have expected. But yeah, if you want to get that, it's up on my GitHub in the Python folder, Python, and then we are working with 10 SQL as well as 10 consume SDK, which we're going to work on pretty soon here. All right, so that's all I got on the setup to start working with SQLite 3. In the next video, we're going to create our first table, and that should be pretty fun. So yeah, see you in the next one, and please be sure to subscribe. Hey everyone, welcome. In this video, I'm going to be teaching you how to create a table in SQLite using Python. We're currently working with a memory database. Of course, you could use an actual database file if you just put the name of the file there. The only problem with that is if the table already exists, you're going to get an error. With a memory database, it's going to let you run that code over and over again because every time you launch the application, it restarts and gives you a new database. So I'll show you an example of that in a moment. But for now, get this boilerplate code, import SQLite 3, make a connection, and then using that connection, we get a cursor object, which is going to be used to actually work with the database. So to create a table, what you do is you say c.execute, and execute allows us to execute SQL directly to the database. So what we can do is we can say create table, and we're going to create a table for books, and then inside of parentheses, you can put the columns. So every single book is going to have this information, and I'm going to keep it really simple. We're just going to have a title and a page number. So to create a title, you say title, and the data type is going to be text, and then a comma, and then the page number, we'll just call it pages, and this is going to be an integer. So just to understand the syntax here, if you are fairly new to databases, we, by convention, capitalize any of the commands or the data types. So the create table is capitalized. And then any of the stuff we choose, like the table name or the column names, those are in lowercase. Books is the table name, and then title and pages are the two columns. That's just a convention though, it's not case sensitive, so you can title it however you want, but I think it's a pretty good idea to follow the common conventions. Now this text and integer, these are known as data types, similar to how types work in Python. You can have an integer or a float or a string. Well, there are some data types for SQLite. So those are the data types we're going to use, and then what we can do is we can run this, make sure we don't get any issues, and it works. Now, every single time we run this, it works just fine. If we were using an actual database file, so let me go in here, and I'm going to say database.db, very creative name, save this and run. Well, now the first time it works, but the second time you can see it through an error. And it says table books already exists. If you want to have that same behavior with a database file and not just a memory database, what you can do is you can basically say, hey, we want you to create this table if it doesn't already exist. So what you can do is after table here, you can say if not exists. and then it'll only create it if it does not exist. If it does exist already, it's not going to create it and you don't get any errors thrown. So now we can run this, and look, we're not getting any errors every single time we run it. The table is only being created that very first time. All the other times, this code does nothing. Now the next thing I wanted to share with you guys is that if you have a really large query, it's going to be pretty ugly if you have to put it all on one line. So you can actually do multiple lines by using 3 quotes at the beginning and end. So we'll put 3 there, and then 3 there. And then what we could do is we could bring these columns down to the next line if we want, like so, however you want to format it. So I'm just going to go back to the memory database here, like so, and this will be the code that we'll start with in the next video. And by the way, next up, we're going to talk about how to insert data into our table. Thank you guys, and I'll see you in the next one. Please be sure to subscribe. Hey everyone, in this video, I'm going to be teaching you how to insert data into SQLite using Python. So right now we have this connection set up with a memory database. So we create that table fresh, and now we're going to insert a piece of data. So to do that, we're going to do it similar to how we did the create table, in that we use execute and pass in some SQL here, which I haven't even defined SQL. SQL is structured query language. It is this code right here that we use to talk to databases. And that's what we're going to be using to create tables, insert data, delete data, and so forth. So what we do here is we say insert into, and then what table we want to insert that data into, which is books. So we'll go in here and say books, and then we say values, and then inside of parentheses, we're going to put what we want for the title and the pages. So I'm going to go with my favorite children's book, Are You My Mother, comma, 72, which is the number of pages in this book. And then after we execute this, we have to do one extra step, and that is con.commit. So notice the first time we're working with the cursor object, the next time we're working with the connection object. So the commit is going to be used anytime we want to insert data into the table. So we can run this, make sure we don't have any errors, and it looks like it's good, but I actually haven't taught you how to retrieve that data. We're going to go into that in detail in the next video. For now, just follow along because I'm going to be teaching you another way to insert data, and that is if you don't want to specify a value for a particular field. So for example, let's say we wanted to leave pages blank and we just didn't put a value here. Well, running this, it's not going to let us. It says table books has 2 columns, right, which is title and pages, but 1 values were supplied. So how can we do that? Well, we actually need to specify what column we want this to go to. So to do that, where it says insert into books, you can put another set of parentheses here and put the column you're looking for. So we'll just go with title. And in this situation, it's not quoted and it works. So we run it, and now we're not getting any errors. But what I want to do now is actually check the table to make sure that data is being inserted properly, and that's what we're going to be going over in the next video. So stay tuned and please be sure to subscribe. Hey everyone, welcome. In this episode, I'm going to be teaching you how to retrieve data from a table in SQLite using Python. So far we've created a table, we inserted data, now I want to get that data back out. So to do this, we say c.execute, and we're going to execute a new SQL statement. And this is going to be a select statement. So we say select, and then you put the columns that you want to retrieve. So you might not want to grab everything, you might just want the titles, for example. If you want to grab everything, you can use an asterisk. So select star from, and then you put the table. So imagine we had numerous tables. You know, we might have a table for authors, books, I can't think of anything else, but there could be numerous tables, so we need to specify which one. So we'll say from books. So this is the most basic select statement. That's just going to grab everything. And then what you have to do is c.fetch. And there's 3 options here: fetch all, many, or 1. We're going to fetch 1. And this is going to return the data. So what we could do is we could say data and assign it c.fetch1. Now we can use data throughout our program. So for example, we could print data. And now let's run this and see what we get. All right, so the structure we get back is known as a tuple or a tuple. And the syntax is going to be just like a list, except we're using parentheses instead of square brackets. Now, if we were to say fetch all, in this situation, we're actually going to get a list of tuples, and we only have 1 tuple in there. There's only 1 book in the table. So that's why there's only one piece of data in here. Otherwise, it'd be a bunch of tuples separated by commas. So I'm going to show you how to do that now. So what we're going to do is we're going to comment out this insert and replace it with a new one. And pay attention here, this is a little funky, but pretty much we're going to create a list of tuples. So let's go with 3 tuples in here. So this is going to be the syntax. And the first one is going to be, are you my mother? We'll go 72 pages. My other children's book, The Diggingest Dog. That's going to be 72 pages as well. And then we'll go with another book, The Giving Tree. I actually haven't read this one, so hopefully it's all right. All right, so that is our list of tuples. And we can insert all of these by saying c.execute many. And here we're going to make an SQL statement. So we'll say insert into books, all lowercase books, and then values. And in here, we're going to put 2 question marks, and that's going to refer to the title and the pages. And then outside of the quotes, you just put books. And then lastly, we'll say con.commit, like so. Now, when we fetch all, we should get a list of all 3 of those books that we inserted. So we run this, and take a look, guys, we got all of our books back. Now, you may want to be more specific about which book you want to get, since we don't just want to grab all of them all of the time. And to do that, you can go in here and say where, and then make some kind of expression, and we'll get into all the different things you can do here. But for now, we'll just go with where title equals, and note here, we're using a single equals here, not a double equals like you would compare values in Python. So in SQL, you use a single equals. In Python, you would use a double equals to compare values. So where title is, are you my mother? And then we're using double quotes here since we're within single quotes. All right, so let's run this now. And we just get 1 book back, are you my mother? It's still within a list. So whether it's in a list or not changes how you work with the data, but we're going to be getting into that soon. Now, it might be the case where, let's say, for example, you accidentally put an extra book in here. So in that situation, we're going to have a duplicate. So what I want to do is I want to teach you guys how to delete data, and that's what we're going to be talking about in the next video. So stay tuned and be sure to subscribe. Hey everybody, in this episode, I'm going to be teaching you how to delete data from a table. So right now we're inserting a bunch of books. We're inserting one here at line 10, and then we're inserting more in this section right here. So when we select everything from the books table, this is what we get. We get a list of a bunch of books, 2 of which are the same, and we'll talk about that in a moment. But for now, I'm going to be teaching you how to delete one of these. So what we do is we say c.execute, where c is the cursor. And the SQL to do this is delete from, and then the table name. So we're trying to delete from books. And I recommend you say where, and now put some condition, such as title being equal to, let's go with, are you my mother? And end that quote there. So when we do this, this is actually going to delete all of them that meet this condition. So it's going to delete both of these. So to show you that, here's what we're going to do. We're going to first commit this. So we'll say con.commit, execute that, and then I'm going to select everything from the books table again. So paste that down here. All right, so run this. First time, this is what we had. Then we deleted, and this is what we're left with. So are you my mother's not in there at all. But at least you know how to delete now. But let's see what else we could do. Well, with these books, there's actually a row column that we're not seeing here. So if you want to see that, you could say, let's go up here actually and say select row ID, comma, title. So you can be more specific on what you're trying to get back. You could also do pages here if you want, but just to show you guys, we could leave that off and just have row ID and title. In running this, you can see that each one of these now has a number, and that is stored in the table. It's an auto-incrementing number known as the ID. It's a very common thing with databases, and this allows us to refer to one of these very specifically. So if we wanted to delete this one, what we could do is we could say where row ID is equal to, and set it to 2, like so. And also, it's probably obvious by now, but notice that when we're doing a comparison in SQL, we use a single equals. If we were trying to do the similar thing in Python, we would use the double equals for comparison. So use a single equals with SQL. So run this now, and we have effectively deleted one of the Are You My Mother books. So that is how you delete from a table. And now we're going to be talking about a very important thing, because if you take a look at all of our code, everything is hard coded in here. How would we generalize this to work with data that the user types in or anything like that? How do we use variables? And it's really important that you pay attention in the upcoming sections, because if you do it wrong, you can actually make your data exposed to some common threats. So we don't want to do that. So pay attention and stay tuned for the next episode where we're going to take this up a notch. Stay tuned and please be sure to subscribe. Hey everybody, before we get to generalizing our SQL to work with variables and user input, I want to talk about updating data, because that's one piece we haven't talked about quite yet. So in the code we have here, we are deleting one book from our table. And to show you guys this, is what we showed in the previous episode. We started with this here, where we have the Are You My Mother book in here 2 times, and then we delete it based on the row ID. But what if we just wanted to update one of them to change the title or maybe change the page count of a book? That's what I'm going to be showing you now. So you don't necessarily have to delete the book and then reinsert another book. You can just do it all in one, and I'm going to show you the syntax to do that. So you would say update books set, and we'll go with title. What are we going to set it to? We're going to set it to new book. Now we're going to do a where condition so we can specify what book we want to update, and we'll just say where ID is 2. Alright, so let's try this now. Run it. We actually want to use row ID here. Run it now, and there we go. So we started with Are You My Mother, and then Are You My Mother again, and now it's Are You My Mother and new book. So that is how you would change data in a table. Now the next logical thing would be to generalize this a little bit so we're not hard coding an ID like so. And it'd be kind of cool if we could just invoke a function where we could say something like update book, pass in the book we're working with, and then what we want the new title to be, something like that, where we don't have to write SQL every single time. And this concept is known as an SDK, and we're going to be building that in the next section of videos. And that's going to be a whole lot better because we're going to avoid any hard-coded values. We're also going to be very careful of any security issues. So stay tuned for that, and I promise that's what we're going to talk about next, hopefully. So be sure to subscribe, and I'll see you there. Hey everyone, welcome to your first episode on creating an SDK to work with a database. We're going to be using SQLite, and the whole purpose here is to separate our database code from our application code. And also, it makes it easier for us because if we want to work with the database, we can just call a function such as add book or get book. And we don't have to worry about writing out the SQL code like so. And another benefit is we're no longer going to hard code stuff. We're not going to be like row ID is 2. We're going to get that stuff from arguments passed into functions. So if you have absolutely no idea what I'm talking about, then let's just go through how to create something like this. Basically, make working with the database a lot easier. So we're going to clear this out completely. We're just starting fresh. Now we are going to use some code that I have up on my GitHub. So the very first thing is we're going to create a file, book.py. And this is going to contain our book class. We created something very similar to it earlier in the series, but if you want the exact code I'm going to be using, you can find it here on my GitHub, and you can just copy and paste and bring this into your code. So copy this and paste it here. Now, whenever we want to use this class in another file, all we have to do is say from book import book, and then we can create a new book like so. All right, so that is how you create a book object. Now what I want to be able to do is just say something like books SDK dot add book, and then just pass in our book object. And then what this will do is it'll actually add it to the database. So how are we going to do something like that? And let me just say up front, there's a quadrillion different ways to do this. So if you're looking stuff up online, the examples might be slightly different. And also up on my GitHub, I have this code, which we're going to be building it from scratch. But if you need to just kind of see some of it more in face-to-face, well, you can get it up on here. And I also have some links on just some decision making that I had to do on how to design this. But yeah, let's just go through it. We're going to create a new file. We're just going to call it books.sdk.py. And now we can close our Explorer. Now, whenever we're working with a database, we're going to have to open a connection and get that cursor object. And it's also best practice when you're done working with the connection to close it. So I'm going to be doing that every single function in here. And you could maintain that connection if you want, however you want to design it. But essentially what I'm going to be doing is I'm going to create a function to give us a cursor. And then at the end of each of our functions in this SDK, we're going to close that connection. So this is what it's going to look like. Def cursor. We're going to first import SQLite. We're going to say SQLite3.connect, pass in a database name. We'll just call it books.db. And this is going to be the connection, and we can get the cursor on the connection by saying .cursor. And this is the object we need to work with the database. So we're just going to return this, and then anytime we need a cursor, we can just invoke this function. So an example of how this would work would be like C is cursor. That gives us a cursor object, and then we can just say C.execute. So for example, we can create a table. Create table if not exists books. And this is going to have two columns. So we'll have a title, which will be of type text, and then pages, which will be an integer. All right. And then whenever you're done and you need to get that connection object to close it, you can actually get that through the cursor because it maintains that connection object through .connection. And then you can say .close like so. All of this is going to open a connection, create a table if it doesn't exist, and then close that connection. Now what we can do is we can create some functions in here such as add book, and this is going to take a book object. We can get a reference to the cursor, and then when we're done, we'll just say c.connection.close. And then in between here is where we can add that book to the database, so we can just say c.execute, insert into books values, and to properly do this while avoiding SQL injection risk, we put question marks here and then pass in the values afterwards in a tuple. So inside of parentheses, we would say book.title and book.pages. Now, in order for this file to use the book class like so, we actually need to import it. So we'll say from book import book with a capital B there. So let's test out this add book and just see if we get any errors. We are invoking books SDK, which we need to import. Import books SDK. We're adding a book and passing in a book object, run it, and we're not getting any errors. So in theory, it worked, and it looks like it did in fact make the books.db file. So we're on the right track. Now, another thing we can do is we can actually use the with keyword we talked about a few videos ago, and here's what that would look like. We'll go in here, and here's what we're going to say. With c.connection, and then we're going to execute this code. There we go. We can also do a return, so we'll say return, and we can say c.lastRowID. And that'll give us the ID that was inserted. So let's check it out now. We can take this call and we can actually pass it to a print to see if we get an ID back. So running it and we get the value 1. Awesome. Running it again, we get 2 and then 3 and then 4. Great. So that is how we create the add book function for our SDK. Now what I want to do is I want to retrieve data. So let's go back to our SDK and we're going to create a new function in here, def, and we'll just call it get books, but we're just going to get everything. And here's what we're going to do. We're going to get a cursor object, and then with c.connection, c.execute. And what are we going to execute? We're just going to say select star from books, like so. And then the last thing we need to do is actually return this data. So we will say return c.fetchAll, which will give us a list of tuples, which will contain the data. So that'll get us all the data. Let's try it out. Over here in hello.py, we will just say print books SDK.getBooks. We don't have to pass anything in. We run it. And hey, take a look at that. It gives us a list of books. So it seems to be working. And notice that our calling code is much thinner because we don't have to put any SQL in here. We don't have to even import SQLite 3. Everything is done for us by this SDK. Because this SDK is ours and we can fully customize it, we can make it do whatever we want. So for example, if I'm more familiar with working with list of lists inside of our calling code, then I could convert the SDK to return a list of lists. So let's see what that might look like. Well, what we could do is we could just iterate through the return data. So for book in c.execute, what are we going to do? We're going just to add it to a list of books. So we'll say books, it's an empty list. And then what we can do is we can just append this book to that list. So we'll say books.append and pass in book, but that's still going to be a tuple, so that's not quite what we want. So we can actually make a list of book objects, which I think is what would be the best. So let's pass this to the book constructor, and this is going to take the title, which is the first element, and then the number of pages, which is that second element in there. So index 0 and index 1. So hopefully I got that set up right. All right, and then instead of saying fetch all, since we're iterating through the data here, we no longer need to fetch that. So we can just say return books. All right, so let's run hello.py and see if it works out. Aha, all right, so let's take a look at this. We got a list. You can see that by the square brackets. And then we have Are You My Mother 72 pages long, like 50 times. The reason we have it in there so many times is because each time we run this, it inserts another one. And we're not using an in-memory database, so it just appends it to whatever the data is already in there. So that's why we just keep getting more and more books in here. But it is working properly. So based on the books class, we have this I don't know how to pronounce that, but the representation of what the books look like in a list. If we were to cut this and save it and then run hello.py, this is the output we would get, which is still good. I mean, it's working, but it's much nicer to have this output here, which just gives the underscore stir representation for the elements. All right, so that is how you create an SDK and how to invoke it. Pretty awesome because we can add a book by an object and we can also get a list of book objects by getting the books here. So very, very cool. There's still a lot we can do, so we're going to continue this discussion in the next video. Hopefully we'll get into some of the other CRUD operations. And yeah, stay tuned. Hey everybody, in this episode we're going to continue working on our SDK. We're going to create a function to get a book by its title. So here's what it's going to look like. Def get underscore book by title, and this is going to take a string title, and ultimately we want to return a book object. So we're going to get a reference to the cursor like so, and then we say with c.connection c.execute, and the SQL is going to look like this: select star from books. Then we're going to say where. And that's because we don't want to grab all the books like we did here. We want to specify the title, and we don't just want to do this. We don't want to say plus title. Anytime we're doing like string concatenation with parameters and building an SQL statement, this risks us for SQL injections. So the proper way to do this is to actually put a question mark here and then put title inside of a tuple with a comma right after the title, which is the syntax to do that. So that's a little funky, but it does the trick. And then afterwards, we're just going to return c.fetch1. So that's going to return a tuple, but we'll just see if it's working first off, and we're going to invoke it over here. So we'll say print books SDK dot get book by title, and I'm going to pass in the only book in there, Are You My Mother? And we'll see what we get. So running this, and we do in fact get an extra tuple down here at the bottom, so it seems to be working, which is awesome. But what I want to do is actually want to convert it to a book object, because I want to be working with objects when we're working with this SDK and not always have to deal with objects and then tuples and so forth. So instead of this return here, we could just store this data. And what you could do is you could check to see if there's anything in there. So if not data, we'll just return none, like so. Otherwise, what we're going to do is we're actually going to create a book. So we'll say return book, pass in data index 0 and data index 1, which will be the title and the pages. This matches the initializer for the book class, which takes the title and pages. All right, let's try it now. Let's go back to our calling code and run this. And now we are getting a book object. You could work with it like so. You could assign it to a book variable, and then we could say print type of book, and it'll show you that it is in fact a book. Now there's one thing I want to change in our code. Inside of our SDK, the with here will automatically commit code. So for example, when we're adding a book, but it actually doesn't automatically close the connection. So if you want to close the connection, just go c.connection.close, where C is the cursor object coming from this here. So I'm going to do that for all of these. We'll just say c.connection.close and then c.connection.close. All right, so right now we have the option to add a book, and get a book by title. I think some pretty cool options that you could do would be to update a book. So you pass in probably 3 arguments. The first one being a book object to update, and then a new title and possibly a new pages. Then you could also delete a book. You could do it by object or you could do it by title, whatever you want. This is totally fully customizable. I have some examples of how to do that up on my GitHub, but I think that's good for SDK right now. We might add more as we go. Next up, I want to use our SDK because we're going to actually create first a console application, then a graphical user interface. Oh yeah, working with these books. So stay tuned, it's going to be a whole lot of fun. Wow, I said that's so boring. A whole lot of fun. It's going to be so much fun, guys. See you then. How about that? Hey everyone, in this episode, we're going to be working with our database by creating a console application that will allow users to work with books. So when we X out of the application and reopen it, it's going to remember all of the books because that information is going to be stored in the database, and we're going to be using our SDK we created to abstract away the database layer. So where do we even begin with this? Well, we're going to print a menu and we're going to use a multi-line string just to make our life a little bit easier. So we can go in here and say something like choose an option. And then we'll just create a numbered list. So 1 could be print all books, 2 could be add a book, and then we'll just put some extra options in here that you can decide to implement later if you would like as a challenge. I have the solutions up on GitHub if you need, but for now, we're just going to put the menu options here. And then the last one is to delete a book. All right, so since we're going to be printing this menu numerous times throughout the application, I think it'd be wise to actually put it inside of a function. So we're just going to call this print menu, like so. And then if we want to print the menu, we just have to invoke this function here and take a look. That's what our menu is going to look like. Now, with this function, we can put this in a loop and it's going to be nice and pretty. So what we're going to do is we're going to say while true, we're going to print the menu each time through this loop and then get user input. So pretty much you can think of it's going to ask them for an input. They might choose one and then it'll ask them for an input again and so forth. So what we'll do is we'll just create a variable response and get input. And because this is a number, I'm actually going to cast it to an integer here. Now that we have that integer variable, we can check to see what they did. And for now, we're just going to print what they chose, and then we can go back and fill in the extra information. But just to make sure our menu is working, that's what I'm going to start with. So we'll say if response is equal to 1, what are we going to do? We're just going to printing all books. And then we can say elif response is equal to 2. And you guys get the picture. So just fill this out. And then we'll do it again for 3. elif response is equal to 3. Updating a book, close enough. And then lastly, we'll have 4. So elif response is equal to 4. Print deleting a book. Okay. And then if they don't put anything that is an option up here, 1, 2, 3, or 4, that means they put something else. And I'm just going to assume they're trying to quit. So in that situation, we can do an else here and print thanks for using our sweet app. And we can break. All right, so that'll exit out of the loop and the application will finish. All right, so let's run it. All right, so we can choose an option. We can print all books. And it's funny how it shows up here because it looks like it's not working. And I'm like, oh no, but it's actually working. It's just hiding something. So the terminal is a little bit small here. So we can put a number such as 1, and then it says printing all books. 2, adding a book. 3, updating books. And then 4, deleting a book. So those are our options, and then if you put something else such as 5, it just stops. So maybe you could format this menu a little bit so it doesn't take up as much room, or you could just not. So now we have the menu set up. The next thing is we need to start using the SDK. So let's start with printing all of the books, which will use this get books here. So we're just going to say get, well, I guess we should import the SDK up here. So import books SDK. We're also probably going to be using book objects. So we'll say from book import book. Now in here, what we can do is we can say books SDK dot get books. That's going to give us a list of book objects. So we'll just assign it to a variable books. And then if we want, we could iterate this for book in books, print, and then we'll just print that book object. I would argue that we probably don't need to use this variable. We could just take this function call and paste it right here. And then we don't need that variable at all. So let's try this. We can run it. And I'm just going to bring the terminal up just a little bit so we can see everything. Hit print all books and take a look. It shows all the books, which they all just happen to be the same, but you guys get the point. So it iterates through every single book object in the database. Next up, let's talk about adding a book. So in this situation, we're going to need to get user input. So we will ask them for a name and a number of pages. What is the name of the book? And we'll just say name is input. Then we'll ask for pages. How many pages is the book? And we're just going to say int input. And then we can create a book object. So we'll say book is a new book. And we're going to pass in the title, which is name. Here, let's change that variable to title. There we go. So now we're going to pass in the title and the pages. All right, so we got that book object. Now all we have to do is invoke the function in the SDK. So books SDK dot add book, and pass in that book object. All right, so that is all of the code to add a book. And in theory, we should be able to add a book and then print all the books to see that book in the list. So let's run this. I'll bring the terminal up here. Like so. We got an issue on line 14. Just ignore that. It was from the last one. All right, there we go. So now we can hit 1 to print all of the books, or we could add a book. And we're just going to put a different book in there because I'm sick and tired of seeing this book here. So we're going to put different book, and this is 9,001 pages. It's over 9,000. And then what we can do is we can print all books and take a look at that. It's right there. So the next logical thing would be the option to delete a book. So I'm going to challenge you to implement that in the SDK and then put it inside of this console application. If you need the solution, I'll show you how to find it. Go into my GitHub account, into the Python folder, and Python 10 consume sdk.py, and this is how it's going to be invoked. So we can see what we do to invoke it, and then if you need the SDK, just go to the books SDK file. So that is in here, right here. So here's an example on how to update and delete books. So yep, that's a little challenge for you guys. Try to implement that yourself, and if you're having any struggles, go check out the code there. Hey everyone, in the previous video, we created this menu to work with our book database, and I gave you the challenge to implement the updating a book and the deleting a book, and that's what I'm going to be showing you guys in this video, how to set that up. So here's what we're going to do. We're going to first work in our SDK to create the functions to do those actions. So we'll go down here and we'll say def update book, and we'll also say def delete book. So here's what we're going to do. We're going to say C is a new cursor object, so that's a function that creates a connection and returns the cursor. And then we can say with C dot connection, so the cursor maintains a connection object which you can get through dot connection. And then we'll just say c.execute. And here's the SQL. We're going to say update books set title equal to question mark. And then we're also going to set pages equal to question mark. And then we're going to have where title is equal to something and pages is equal to something as well. So there's a lot of information we're going to have to poke in here. So we're going to get that stuff as arguments. So we'll take a book object and then a new title and then a new pages. So it's up to you if you want to take a book object or if you just want to take a title. Depends on if in your code you prefer working with objects or if you want to work with strings. That's up to you. So then in here, all we have to do is pass in this data. So the new title is going to go for this question mark. So new title, I'm going to bring this down to a new line. Next up we have the pages, so new pages. And then we have to get the original title and pages, so we'll say book.title and book.pages. So that is the basis. If you want, you could get that updated book. So after the with, you can say book is get book by title and pass in that new title. You can close the connection, so c.connection, close, and then return the new book. So let's test that out in our menu. So in here, we will say, and this is where it's a little awkward because since we're using that book object, we actually need to get that since we don't have a book object right here. So here's what we can do. We can ask for the current title and then get that as a response. So title is input, and then we can get the current number of pages and get that from input, and then pretty much do this again but for the new title and the new pages. So that's why it's a little funky because we have to pretty much build the object since our SDK requires that object. So first off, we will use this title and pages to create a new book object. So book is a book, pass in title and pages. We'll use that later. And then we'll get the new title and the new number of pages. like so. And then we can use that in our function call. So books SDK dot update book. We need to pass in the book and then the new title and the new pages. So book, new title, new pages. And just to confirm it's working, what we can do is we can print the return, because that's going to be the updated object. So run this, and we need to put a colon right here and right here. All right, let's try this. Let's run it. And first we're going to print all the books to see what we got here. So we will update this one here. Different book with 900 or 9,001 pages. So update a book. What's the current title? Different book. Number of pages is 9,001. What is the new title? We'll just go with updated. Number of pages 10. Looks like we got a syntax error. We have set in there twice, so we'll go in here, delete that. All right, let's try this again. Update a book. It's called different book, 9,001 pages. New title is hello, 900 pages. Now we can get all the books and see what it is. And you can see it replaced it right there. Now to delete a book, here's what we're gonna do. We're gonna go in here. We're going to get a cursor with c.connection, c.execute, delete from books where, and this is going to take a book object, so where the title is question mark and pages is question mark, and a comma, and then we'll just pass in the book title and book dot pages, like so. You can see how many rows were deleted by saying rows is c dot row count, which we can return later for the caller, but let's just close that connection. So c dot connection dot close, and then return rows. So on the calling side, here's how we're going to use that. If we're deleting a book, we're going to ask for the title and the number of pages. Copy that from the previous prompt. Paste that here. Clean it up just a little bit. What is the title and number of pages? We'll use those to create a book. Pass in the title and the pages. And then we can say book SDK dot delete book and pass in this book. And then we can print the number of rows deleted. So let's run this. Every time I run it, for some reason, it shows an exception there. I think it's just from the previous execution I didn't close out of. So what we're going to do is we're going to print all books. And I just really want to get rid of this book here just because it's all over the place. So when we do this, it should delete all of them. We will say delete a book. What is the title? Are You My Mother? And the number of pages is 72. If you wanted to delete just one, you could create some functions in the SDK to delete by ID. You could also get a book's ID, however you want to do it. So run that. All right, so it gave us 10. So it deleted 10 books. So now when we print all books, all we get is this one other book here. So it seems to be working. So that is one example of how you can update and delete books. So we've covered a lot on SQL and the SDK, so we're going to do a quick review before we move into actually creating a GUI, a graphical user interface, to work with books as well. Stay tuned and be sure to subscribe. Hey everyone, welcome back to your Python programming series. It has been a while since I made a video, I think like 48 days or something. I mean hours. But anyways, it's bright and early. I'm about to crank some videos out, and we're gonna get through some quality content here. But first, we need to do some review before we move on to the next subject. So if you've been following along, this is just a review of what we've covered, as well as some extra notes in here up on my GitHub account. Here is the path. You can follow any of these links to get a little bit extra information, or just read some of my comments. But pretty much the whole purpose here is to do the CRUD operations of a database. We want to be able to create data. We want to be able to read data, update data, and delete data. And eventually, once we got those operations done, we want to abstract that away just a bit by creating an SDK, which is just a bunch of functions that we can use to work with the database. So to begin, we create a database with this line of code right here, and this is how we get a reference to the connection, which we can use throughout our code. Whenever we want to do an in-memory database, we put colon at the beginning and at the end with memory. So colon memory colon. When we do that, every single time we launch this application, we're starting with a fresh database. No tables, nothing. So then I talk a little bit here about paths, which I briefly mentioned, but if you want to know how to get a more of an absolute path or a concrete path, then you can follow this technique here. The next thing, to work with the database, you use this thing called a cursor, and to get that, you say con, whatever you named your connection, dot cursor, and we assign that to a variable, and we're going to use that throughout. So anytime you want to execute some SQL, you just say c.execute, and this is the syntax to create a table with 2 columns, title, pages. The first one's of type text, and the next one is of type integer. These are built-in types to SQLite. Next up, we insert some data. So we say insert into books, values, and then this is the first one, which is the title, and then this is the second value, which goes to pages. So the first one's quoted, the next one is just a number, so no quotes. Then when we want to save our changes, we say connection.commit. So that is how to insert data. That would be the create portion of CRUD, which is the acronym I just taught you. Next up, we want to retrieve data, which would be the read portion. I show 2 different ways of doing that here. So the very first one is to select one element, and in this situation, we use a tuple here with a comma after the first element. So that's just a little bit of funky syntax, but that is what you need to do. And we always want to use a question mark here. We don't want to do any string concatenation, like putting a plus and then whatever a variable might be. Right now, it's not super important because we're actually just hard coding the value. So there's no risk of any kind of SQL injection. But once we get to the SDK where we're taking values from the user, then that situation, we're at risk for people trying to hack into our databases, steal our datas. We don't want people to do that. So what you can do then is say fetch 1, and that is going to get 1 element back. The alternative we show here is fetch all. There's also, I believe, fetch many, which we haven't shown here, but I'm sure you can figure out that if you want. So the next thing we do is we show how to insert numerous pieces of data so we can select all of them. So we create the books here, and we're just having a list of tuples, execute many, and then for values we put 2 question marks, which refers to the columns, and then outside of the quotes we put the books list. So that is how you would do that. Then to get all of the data, you say select everything from books. We're not doing a where clause here, so we're just going to grab everything, and we say fetch all, and we print that data. So that is how you would retrieve data as well as insert numerous elements at once. Next up, we talk about delete. So we can first select the data just to be sure we're deleting what we think we're deleting, and then all you really have to do is change select to delete. So instead of selecting from books, we are deleting from books. We don't need the columns either, so get rid of this portion when you want to delete and replace it with the keyword delete. Then you can select that same data afterwards and confirm that it no longer exists. Next up, we have updating data. This one is pretty simple, so we selected the data just to see what we got there. And then we change the pages to 30, where title is Goodnight Moon. It looks like I used a string here, but I think you could use a number. Yeah. Select everything from books where title is Goodnight Moon after, so we check to make sure that the data is updated, and then we close the connection. I think it would be more appropriate to put this line after the update, so up on line 68. Now, if we wanted to create an SDK of this, this is how we would consume it. So we're consuming it from this file here, and we just say import books SDK as well as a book object, because we're basically working with objects that represent books. So you can see that if you need. So here's some examples, but pretty much we can just call functions that make sense. Books SDK.add book, pass a book object in, get book by title. We have get books, which just gets all of the books, update book, delete book, and you can be totally custom here. You could create one update book by title, update book by ID, get book by ID, delete all books. You can create any function you want. So any database operation you might need in your code, you can create an SDK function to do that for you, and then just invoke that function. But anywho, if you want to see that file, we can go back and check out. First, let's take a look at the book class, which I've shown you guys like at least 1,000 times in this series, but pretty much we have two fields, title and pages, and then a bunch of overrided functions. And then we're going to go in the books SDK and show how to do this. So what I decided to do was create this function that'll give us a cursor. So it pretty much just gets the connection and then gets the cursor object on it. I do some weird path stuff here, but that's just to always create the database in the current directory that this file is in. So that's just a different way of doing that. Alternatively, just change directories to this folder when you're working in the terminal and it should work just fine. So this is going to create the cursor, and then at the end of each of these functions, we decided to close the connection. So it's going to open, close every time you need to do something. And that's what this link is referring to, why I decided that that was an okay way of doing it. Alternatively, you could maintain a connection, but my thoughts are you might not be doing database operations every second or whatever, so why not just open it when you need it, close it when you're done, and then if you need it later, repeat the process. So the whole opening and closing stuff, it's all done for us in this code whenever we invoke one of these functions. And when you have a cursor, you can actually get access to the connection object, because pretty much you use the connection object to get the cursor, but you can actually go back and use that cursor to get that connection with dot connection here, and then you can say dot close. And a lot of these operations will have like a last row ID, which will give you the ID of the thing you changed, or later on there's an example of row count, which will say how many things were deleted. So that's another example of that. So here's how we add a book. We take in a book as a parameter, which has a book.title and book.pages. That's where these question marks come in, just to avoid any SQL injections. We use with c.connection, which is going to roll back if there is any exceptions. You don't have to do the commit after the SQL, although it doesn't close the connection, so we do that after. Here's how to get a book by title. You pass a title in. In this situation, since the function expects a title, you don't have to pass in an entire object. You might not have that object available to you in the code, and you want to get that as an object. So what you do is you just type in what the title might be, and this thing is actually going to get that object for you. So it's going to get one from the database. It's going to then build a book object passing in that item's title and page count. Then you have a book object you can work with. You can modify the data and then save it or whatever you need to do. So you might pass that book, if you were modifying it, you might pass it to this new update book function here, which takes a book object as well as a new title and new pages. So that's an example of what you could do with that object. You do got to be careful though, just because, for example, if you're changing an object you get using get book by title and you say book.title and set it to something else, and then you try to pass it to this function we created, well, it's just going to search by that object's title and pages. So if you change those in code, it's probably not going to find those in the database. So you'd probably want to do the update of the data using this function instead of directly on the object. So hopefully that makes sense, but you could customize this however you guys need. Next up, we have a delete book, which you can see there. It's not really that exciting, but it's pretty exciting. So this is a lot of stuff, and pretty much the best way to learn this is just to go through and build a sample of this yourself, because like that's how I learned all this stuff. I was like, oh, here's what I want to do. Let's try to figure out the code on how to do that. So in my mind, I was like, okay, I want an update book that takes a book object and then the new data you want to replace with. And I was like, oh, I want to delete a book by book object. But you could equally create a function delete book by title. And in that situation, you would change this book object here to a string title that you could then search for, or using the where title. That way you wouldn't need the book.title and the book.pages, you would just need the title. Whatever you need. So fully customize the SDK to work with your application. And if you're in a really good team environment, you might have someone who's building the logic of your program, and then you might be building just that interface layer to the database. So they say, hey, we need an SDK function to get a book by a title. And then you implement that, test it, and then hand it off to them. That's just a setup that might work for you guys if you're in a team setting. And that's all I got for this review. We're going to be talking about building graphical user interfaces now, briefly, because we're running out of videos in this series, but it's something I definitely want to get into, so I'm pretty excited, and that'll be a pretty cool introduction. So stay tuned, and then after that, we're going to be getting into some web development. So we got a lot of cool stuff in the next few videos. Hey, what's up, everybody? Welcome to a beautiful new section in your Python programming series. We're going to begin talking about graphical user interfaces in Python. So this is how to make a standalone window, similar to how Visual Studio Code here has its own window where you can X out of it, minimize it. This is a step beyond just the terminal. Now, the tool we're going to be using is this right here, which brings up an interesting question that I never even thought of until I actually had to teach it on a video, which is how in the world do you even pronounce this word? So what better way to learn than see how everyone else does it on YouTube, right? So I go up on YouTube, play a couple videos.
Kinter or T-Kinter.
So this guy says T-Kinter.
TK-Inter.
TK-Inter.
The TK-Inter function.
This guy says TK-Inter function.
Using Python T-Kinter library.
All right, we got T-Kinter library. All right, but I think the actual proper way to pronounce this is TK-Inter, because the inter is short for interface. So we're gonna go with TK-Inter, but feel free to fight about it in the comments. TK-Inter is nice because it's built in. We don't have to download or install anything. When you download Python, you get this automatically. So I'm going to give you the absolute basic code just to get essentially a hello world application started. And the very first thing is you say import TK-Inter, and then using this module you can say TK-Inter.tk, and this starts it. So invoke that and we can get a reference to this, and you can call it whatever you want. We will just call it TK lowercase t and lowercase k. Then to start your application, all you have to do is say tk.mainLoop. All right, let's run this, see what happens. All right, so it pops up this little window on my super organized desktop. Don't judge me, okay? So what I'm gonna do is set up my windows so it's nice and easy to work in the editor and also see this window. All right, so here we have our code editor, and then here we have our little window. There's probably a really good editor out there that you can do these like in one, but this will do for now because we're only going to cover TK-Inter for the next few videos to build a simple application, and we're actually going to use a database to create an application to work with books. So if you've been following along, we created an application in the terminal to work with book objects and store those and retrieve those from a database. If you're jumping in, that's fine, but we're going to expand on that and basically build out a user interface to work with the same database. So it should be pretty cool. This is getting to the point where you can basically consider your applications as two pieces, a front end and a back end. So the back end includes the database, the SDK, any of the processing. Then the front end is the interface. We could have a graphical user interface like so, or we could have a command line interface in the terminal, which is what we've been doing up to this point. We could also even have a website. And eventually you could build out that backend enough such that you're just working with an API over HTTP. And that is what a common way of designing applications is today. And then you can make things a little bit more fancy by sprinkling in some microservices, or you could do a serverless API, whatever you want to do. But this is just the start of that mindset. So we're separating the front end from the back end, and right now we're building a front end, which is this beautiful graphical user interface. Now in the next videos, we're not going to focus on the looks of this application, so it's probably going to get a little horrendous, but the reason is because, not really because we don't have time, but because my art skills are like from a scale of 0 to 99, like a 0.2. So we're just going to focus on the functionality, which is my specialty, and we'll get something going, and then you can go back and learn how to design graphical user interfaces with tkinter, and then add all that juicy flavoring in later. So let's just stop blabbering because I think I'm going on a rant here. And there's one other thing you can do is you can actually change the title here just to customize it. So you could say tk.title and pass in something creative like hello world. And when you run this, you'll notice nothing happens. This doesn't update, and it's actually stuck on the previous execution. So when you X out of this, it's going to run that new execution, and you can see it says hello world right there. This main loop is going to continue to execute until you X out of that. So for example, if we do something like this, where we say done, watch this. So we close out of this, run the application. So the application is open, but there's nothing in the terminal that says done. As soon as we exit the application, then done appears in the terminal. So this pauses all of the execution, and you can just work with the GUI at that point. Anything after comes once you X out of that window. Now up next, we're going to build a guessing game application. So it's going to pick a random number, and you got to guess that number. And if you're too low, it'll tell you you're too low. And if you're too high, it'll tell you you're too high. So this just gets some practice with different programming concepts. And if you want a challenge, why don't you try to implement something like that in the terminal? Or if you're feeling ballsy, then go ahead and try to figure out how to do that in tkinter. Although there are a lot of new concepts for that, so if you're brand new to this, I'd recommend you just think about how to do this in the terminal, and then switching over to a GUI is going to be a piece of cake. So stay tuned for the next video so I can teach you the main things that are going to differentiate this application from a terminal application. So stay tuned and be sure to smack that sub button. Welcome back everybody. This episode we're going to be building a guessing game in tkinter. Pretty much it's going to pick a random number and you have to guess what it is. I know it's really fun. It's probably a game I would play over Call of Duty. So here's what we're going to do. We're going to need a few things. So not only are we going to use tkinter, but we're also going to use a random number. So you can import random, or if there's a specific piece of random that you want to use, you can say from random import randint, which is what I'm going to do. So the first steps here is first change this stupid title because Hello World's too cliche. So we need to give this a custom name. We're just going to go with guessing game. Even more creative, I know. We can get rid of this print at the end. And all right, so this is the basis just to get it started. But the next step is to get a random integer and get a function to check if a guess is the correct guess. So let's build that, see what that would look like. All right, so first thing is we need a range from pretty much the lowest number it can be up to the highest number. So you could just say low is 0, high is 20. So you could get this from the terminal if you wanted the application to be dynamic. You could say, hey, what difficulty do you want? Choose the lowest and highest number or whatever you wanted to do. Then what we can do is we can get a randint, pass in the first number, low, and then high, inclusive. So that's going to give us a number 0 to 20. And we will just print this to confirm everything is Gucci. All right, run this, we get 5. Next time we run this, we get 20. So you guys can see how this works. So we get a number, and that number is going to be the same for the entire execution, but the next time you play the game, it's going to be a new number. Next up, we're going to create a function to check if a guess is correct. So that's going to look something like this. We're going to say def, give it some name such as check, and this is going to take an integer guess, and here we can just case against the random number. So we'll assign this to a variable that we can use, such as rand, and inside of this function, we just say if guess is less than rand, then we are going to do something, which I'm going to get back to what we're going to do if that's the case, because we're actually going to update the user interface inside of this indent here. But for now, we're just going to say pass. So then we'll say elif guess is greater than rand. In that situation, what are we going to do? We're going to pass. Otherwise, you hit that perfect number. So we'll just say else and pass. So don't worry about implementing these quite yet, because I'm going to be showing you guys, I don't want to comment this, just pass like that. And I'm going to be showing you guys how to update the user interface inside of this function. So have you ever developed in JavaScript? Well, in JavaScript, there is this obnoxious alert box that, you know, when you're on a spammy website, it's like, oh wow, you just won because you're the 200 millionth visitor. And then it pops up and it says, do you want to download this virus? And the only option is like, okay. Well, you can do something similar in Python. Well, why would you want to do that? Well, it's a good way to pretty much showcase different things that is going on in the application. And it doesn't always have to be obnoxious. Sometimes an alert box is good for certain things. So it's actually called a message box inside a tkinter. So you just say tkinter.messageBox.showInfo. And then inside of parentheses, we can put some data here, which would just be a string. So here's what we'll do. We'll just say, and we can actually do some string formatting here. So put an F on the outside and then curly braces. And you could say guess is correct. Or you could do some concatenation if you wanted. I'm also gonna put some at the beginning, so you win. So we're gonna do something similar for the if and elif, and then later on I'm gonna show you a better way to do this where we can add to the user interface. But for now, we're just gonna paste this in here and say too low, and then for this one we'll say too high. So that way it gives us some guidance on which direction to go. So the next thing we need to do is we need to put a place for the person to enter a number and then a button for them to check to see if the number is correct. So here is the code to do that. I'm just going to clear that off just to clean up a little bit. So we're going to say entry, and to create a new entry, which is where you type things in, you say tkinter.entry, like so. And inside of the parentheses, this is where that tk variable we created earlier comes in, which is, think of it as like a reference to the window. So we're saying, hey, we want to add this to the window. And then there's one extra step you got to do, and that is to say entry.pack to pretty much tell it how you want it to show up. So pack is an option, and there's some other options as well. So let's run this bad boy, see what happens. All right, so it looks like we got an input. Now we need to create a button. So let's talk about how to create buttons. So we'll say button, tkinter.button, and this is also going to say tk. And now we also want to say what the button is going to say. So to do that, we say text equals, and we can just say guess. Now there is another argument, which is what do we want to happen when we click the button? And that is called command. So we say command, and all right, just follow the syntax here. We can say lambda colon, then we invoke this check function. So we say check with parentheses here, and then we pass in whatever comes from the entry. To do that, we say entry.get, and we're going to convert that to an integer. So put it in parentheses and put an integer on the left of it. All right, so that is some funky syntax, and we're not even going to get into lambdas or anything, but essentially this is how you would invoke a function while passing an argument to it inside of tkinter. Last thing, we just have to say button.pack, which will just add it right after the entry. And then main loop is at the bottom here. Let's run this. All right, so we got an input, and then we have this button guess. All right, we should probably put something in here. So we'll put 5. I think I broke it. Here, let's try again. Run. We'll just put 5 in there. Hit guess. Oh, get is a method, so we need to put parentheses there. So if we didn't have enough parentheses, now we have 4 closing parentheses on the right here. So let's close out of this, try it again. Run it. Pass in a number 5. Hit guess. Message box. All right, so another thing, message box is not automatically imported. So up here we can say from tkinter import message box. All right, I promise you guys that's all the mistakes I got here. So let's run this again, and we'll put in a number 5, hit guess, and it says alert. The title here is too high. So the value we're putting in here is showing up as the title, not the actual contents of the message box. So to change the contents of the message box, we can pass in another argument. So for example, put in a comma here and then another string. So in this situation, you win will show up at the top, and then it'll say the guess below it. So I'm going to print that random number just so I don't have to guess 20 times. So we'll close out of this, try it again. All right, you can see the value is 17. So what happens if I put 17 in here and hit guess? And it says 17 is correct. Very, very cool. If we put something too low, such as 10, it still says too low here, and we could fix this, but I'm actually going to do a different way of displaying this. I want it to pretty much say our previous guesses in a list here. I think it would also be cool if it told us what to put in this box, because right now it's not really clear. So we could say something like guess a number between 0 and 20. So that's what I'm going to try to do next. To create a prompt or a label so they know what to put in, we can just say label and create a new label by saying tkinter.label. This is going to take 2 things. So the very first thing is the tk object we created earlier, and then a text parameter. We could do a format string to make this easier for us, and then say guess a number low to high. And just to be clear, we can say inclusive, so that way they know 0 or 20 is included in this case. And then lastly, we just say label.pack. So that should make the label show up. Run this, and now it's telling us what to do. Awesome. And you see the 0 and 20 appear dynamically. We're not hard coding those values. Then I pretty much just want to do the same thing, create a new label for too low or too high. So what we would do is just say tkinter.label, pass in tk here, and the text is going to be format string guess is too low. And then we could just call pack on this directly, and we don't even need to assign this to a variable because we're not going to need to keep that reference. So we're going to take this, we're going to copy it, paste it here, because we're going to do a very similar thing, but now we're just going to say too high. So let's run this and try it out. We'll say 5, hit guess, and it says 5 is too low. Say 15, hit guess, 15 is too high. Then we get it right in the middle, which is perfect because that is the answer, 10. Hit guess, and it says 10 is correct. So that was a lot. I apologize if it was scatterbrained, but it takes a lot of brain power to kind of iterate through all of this stuff here. So hopefully all of this makes sense, except maybe this part here because we didn't even talk about it. But pretty much by default, you would pass in a function name, not invoking it. If you prefix it with lambda, it allows you to pass in an argument. And you can look up more information on that if you just research how to pass arguments to command for button inside of tkinter. Next up, we're going to talk about a new component that you can use in the user interface called a list box, which is great for displaying data coming from a database. And that's our ultimate goal here. So stay tuned. I'll see you then. Hey everybody, in this episode, we're going to be talking about the tkinter list box. And you might be wondering what this is, and it's actually a way to display numerous elements inside of our interface. So it's like a list. It's like a box that contains a list. It's not a box of numerous lists. It's not that kind of box. Just one list of elements. So how do we create a list box? Well, we're going to assign this to a variable. So we'll create a variable and then say tkinter dot list box and pass in our tk object. So that is how you create a list box. And then you just say list box dot pack. That'll add it to the user interface, and you run this, and it doesn't look like there's a whole lot of anything here. How do you actually add data to this list box? That is the question. So between this line and this line, we can add data. So you can say list box dot. You see there's a bunch of different stuff we can do. One of which is insert. And here we can put the index. So we'll just go with 0 and then elements. So we'll say hello, hi, yo. All right, so let's run this. And there we go. Now we have 3 elements in our list box, and we can go through them using the arrow keys. So that first argument here allows us to be specific about where we want to put something. So let's say we had another insert statement, and we just said some other greeting, hola. It's pretty much all the French I know. And we can say index 2. So in this situation, we'll close out of the previous time, and now you can see it shows up right here. So 0, 1, 2. You can also remove data, and you can do any of this after the list box has already been created. So just to show you guys that, we can paste that here, run this, and take a look. You can see all that data still gets in that list box. So although it kind of makes sense to put the inserts between these two statements, it doesn't actually matter. So the list box is really dynamic in that we can add elements dynamically and we can remove elements. To delete, you just say listbox.delete and pass in an index. So let's say we want to delete index 0, which should get rid of this hello here. So we run this, and you can see we no longer have that hello. So that is how you insert and delete. Another thing you might often see is instead of a 0, you might see end, which is a value that will represent the end of the list. So that'll always add to the end. So in this situation, we should get hello, hi, yo, and then hola at the very end. In order to use this end here, you actually have to import it. So you can say from tkinter import end. And now we run this, and you can see it goes in order now, and then it still deletes that first one there by using index 0. So that is how you create a list box, add and delete data. We're gonna get some more practice with the list box in the next video, so stay tuned. I'll see you guys there, and be sure to subscribe. Hey everybody, in this episode, we're gonna get some more hands-on experience with the list box inside a tkinter. So the previous video, we gave an introduction to the list box, how to add elements and remove elements, but now I wanna do it a little bit more dynamically. I want to have an area to type in a value and a button to say add to list. And then I want to be able to go select items from the list and remove them from the list. So that's the goal of this video, a little bit more substantial, and it's going to add some complexities, and it's going to get even more complex in the next video because we're going to start working with objects inside of the list. But these are all very practical things, especially if you're doing database applications or just general business applications. Very commonly, you'll need to work with data inside of a database. So the two pieces I think we need are an entry to type in text and then a button. So let's work on that entry. So we'll say tkinter.entry, pass in our tk object from line 4, and just leave it like that. And then we'll just say entry.pack. So let's just run this, make sure it's working, that we have an area to type in text, and we do. So next up we can make a button. So we'll just say button is tkinter.button, pass in our tk object, and then for text we will say add value, and then lastly command, which is what we want to happen when we click the button. And we will not use any lambda or anything in this portion here, since we're not going to need to pass any arguments. What we can do is we can just say a function name, don't invoke it. So we'll just say add to list. and we can create that function. So def add to list, and we'll just say pass for this moment. Let's pack this button and then run it. So button.pack, I always forget that step. Run this, and you can see we have an area to type in and then a button. Let's also create a button to remove a value. So to do that, we're just going to copy this code here, paste it, and this is going to say remove selected value. And I'm just putting selected there just so it's clear that we don't mean to remove whatever you typed in here. We don't want people typing in here and trying to remove from the list that way when there's an easier way. And then the command, we can just say remove from list. So we will create that function as well, def remove from list, and we will say pass. So let's run this, see what it looks like. And we got an add value button as well as a remove selected value button. Inside of the add to list function, what we're going to do is we're going to say entry.get, which is going to get the value from the input. And what we can do is we can use this to add to the list. So let's scoot that down for just a second and say list box dot insert, and we can insert this at the end, and then we could take this, cut it, paste it right there, clean up the formatting, make sure everything is nice and clean. And now let's try it. We type in a value hello, click add value, and it shows up right here. We can keep doing that if we want. And every time we run this application, it's going to have a fresh start. Next video, we'll talk about database use to maintain values, but for now, this is fine. If you want, you can clear out the entry by saying entry.delete, saying 0 to start with, and then all the way to the end to stop. So let's try this, see if it works. Say hello, hit add, and then it clears out that text. Either way is up to you. If you want it to stay there, then that's fine. Otherwise, you can delete it using this code here. All right, cool. Now to remove from the list, we first need to understand how data is retrieved from the list. So to retrieve data, you would say listbox.curse selection, or what does that even say? Curse selection? I'm not sure. Cursor, is that short for cursor selection? Or maybe it's telling you that you need to curse election, whoever or whatever that is. Anywho, let's just print this data. So run this. Let's put some data in here to begin with. We'll put pizza. We'll select that and hit remove selected value. And we get this weird tuple inside of the terminal. What even is this? Well, I honestly don't really fully understand this, but it's a tuple that has the index as the element there. So let's add a couple other values. You know, got to keep it all about pizza here. So let's try the second one, and we remove that. Now it's 1. So you can actually use this tuple to remove data fairly easily. So to do that, all you have to do is say listbox.delete and then pass in that value. So we will take this, cut it, paste it right here, and get rid of that print. So let's just try this. We'll close out of this and run it again. We'll add a value in there such as pizza, select it, and remove it. Hey, it's working! Let's get a little bit more practice adding some other stuff in here. And I'm going to be putting some new foods I've been eating. So yesterday I ate some bone broth. I mean, I drank it, but also some kimchi, I think it's spelled right, which is like fermented vegetables. It's really gross, but super healthy. Oh yeah, also a 12-pack of donuts. My favorite restaurant of all time. Add that. And now let's just delete something in the middle, make sure it's working. Awesome, yeah. It seems to be working. It's not deleting the wrong stuff or not working at all. And yeah, it seems to be good. Now, if you wanted to, you could possibly modify the add value to add at right after the position that you have selected. So as an example, let me add a few other things in here. if you had this one selected and you added a value, it would put it after that. But that's like some minor details. That's the kind of junk that developers tend to put in ahead of time when their application isn't even correct or meeting business requirements. Or to translate that, I don't feel like it. So we're just going to move on to the next video where we're going to start working with objects in this list box and how to store those objects in a database. So a lot of good juicy information in the next video, and we're going to be pulling in some code that we created earlier on in this series. Stay tuned and be sure to subscribe. Hey, what's up everybody? In the previous video, we built this cutting edge application, which is just absolute fire. It allows us to add elements to a list and remove elements from the list. But now I want to take this up a notch. We're going to start working with custom objects because we might not just want to put strings in here. We might want to put book objects that we get from a database, because we're going to be making a summer reading list. So this actually gets a little complex, so pay attention, but we are going to get through it. We already have the basis on how to add and remove data. We just need to add an extra layer on top of this, which is the object part. So it's nothing too crazy, but just a few weird things that I'm going to call out that you need to watch out for. So the first thing is we're going to need some extra code here. So what are we going to need? We're going to need a book class, which we created in this series. You can get this code up on my GitHub or just type it out real quick. So my GitHub is github.com/Caleb Curry. Then just go to /Python. I feel like I'm always selling this link, but really it doesn't help me at all if you go look at that code. But if you want to, you can go get the code from there. And next up we have this books SDK, which this is a little bit more substantial. And we built something like this in the previous videos. You can get this code up in my GitHub as well. This books.db, you're not gonna have to worry about that because the SDK is gonna create that for you right here. So again, you can find those files right here. Caleb Curry /Python again. And then you can get book and books SDK. So instead of just having one input here, we're actually gonna need two inputs. So we're gonna want one for the book title and the book pages. You could expand it out if you want more stuff for the book, but just to keep it simple, those are the two fields we're going to be working with. So here's what I'm going to do is I'm actually going to put a label so people know what to do. So right before this entry, we're going to create a label, and we're going to call this label the title. So tkinter.label, and this is going to take the tk object and then the text, which will say book title, and then we'll say title.pack. And we're going to do something very similar with pages. So actually we'll just copy both the label and the entry, paste this. So now we have a title here, and then we're going to get the pages down here. So pages, and then say book pages. We also need to update the pack, so pages.pack. Whenever you copy and paste, it's so easy to forget to change something and introduce bugs. For example, not updating this entry variable because I'm just replacing this here. So we will call this one title entry. And then this one down here we will call pages entry. So graphically, everything should look right. Run this. All right, so we got a book title, book pages. Then we can add value. We could update that to say add book if we wanted. And then we could say remove selected book. So that is all we need for the graphical user interface. We just need to update the functionality up here because this is no longer going to work. For one, we have some different variable names, so it's going to break it. So for example, we try to add data, we get some exceptions in here. So we need to fix that now. So let's take a look at add to list. The very first thing is we can actually construct a book object using those entries. So the book requires a title and the pages. So the first entry was title entry, and then we can say .get. So that'll get that value. And then we can say pages entry .get, and that'll get the pages. Then what we can do is we can insert that into the list box here. So we'll just pass in book. And this entry.delete was clearing that entry, but now we would need this to say title_entry.delete as well as pages_entry.delete. That'll clear out both of those inputs. And in order to work with this book object, we actually need to do an import. So we'll say from book import book with capital B, and we'll also import the book SDK, which we'll use later. So that's how you do that. Run this. Let's just test it out. We'll say hello, book pages is 5, add that. Hey, and it works. Now you might be wondering, why is this any more valuable than just doing strings? Why do you need to be working with book objects? Well, the whole thing is that we want our objects to be a representation of our data in the database. If we're just working with strings, then there is a disassociation, which I just don't like that. So it would be ideal if we were able to iterate through all of our books from our database and put them inside of this list box. And then we could remove any of the books from this list, and it would automatically delete those from the database. To do that with strings can introduce errors. Anytime we can use objects, I think that is ideal. Although it's probably possible with strings. We did create SDK functions, getting by title. You could probably create one delete by title, whatever you want to do. But enough rambling, let's talk about removing from the list. Honestly, if we're just working with the data as is, this should work. We just remove and it goes away. But if we want to coordinate that with database work, then there's an extra step that's going to be needed. So that's the next logical step in this application, is to start working with the database. So that's what I'm going to try to do now. When we add to the list, I want to create a new book record in our database. So what we could do is we can say books SDK dot add book and pass in our book object. We can confirm if this works because this add book in here will return the last row ID. So that should be a valid number, which will evaluate to true if passed into an if statement. So if it was inserted properly, then we can add it to the list box. So in other words, we're not going to say that it worked until we can confirm that it worked. So run this. Let's just make sure nothing is too broken. Let's close out of this. And let's try it again. Hello, 5, add a book. It shows up here. We don't get any errors, so I believe it's working. So now let's take a moment to look at this remove from list. I don't think there's an easy way to get an object back out. We've added objects, but when we remove, we just get strings. So our SDK does not easily work with strings. So we have books SDK.remove .delete book, and this takes a book object. You could create one that takes a string, or you need to figure out how to convert the string from the list box to an object. So my easiest way of thinking of this was to create a list that's going to keep track of all of our book objects as we're creating this list. So up here we're going to say books is an empty list. And when we add a book, we're just going to say books.append, pass in book. And then down here and remove, here's what we're going to do. We're going to get that tuple, and we'll just call this book tuple. We can parse that tuple to get the index, which we can steal from the books list here. So we can say book is books.pop, and then pass in book tuple index 0. So imagine the tuple is of the form 0, like something like this. Well, we want to grab that element, so here's how we would do that. Then we can try to delete this book, so we can say books SDK.delete book, pass it in, and this should return something. So delete book returns the number of rows, so we can put that in an if statement. If it was successful, then it should pass as true. And in that situation, then we can remove it from the list. So we would just say list box dot delete, pass in the book tuple. All right, let's just run and make sure there's no exceptions. Put in a book here, add it, and then we remove it. All right, it seems to be working. The only logical thing now is to iterate through all of the data in the database and print all of the books in this list box here. So we can do that at the beginning here. We can just iterate through for book in books SDK dot get books list box dot insert. We can put it at the end, and then we'll just put the book. We also need to put it in that books list we have. So books dot append, pass in the book. So run this, and you can see it automatically puts a book in here. That's because that book existed inside of our database already from a previous video. So now we can put some extra data in here, hit add book, close out of it, run it, and the data stays there. We can go in here and we can remove a book, close it, run it, and it stays removed. So now let me just address an area that might be confusing, and that is, what exactly is this books list for? Well, the main reason I am using this is because the books SDK, the delete book, requires a book object. But the problem is, when we are removing from the list, we're only getting a string. So in order to use the SDK, we basically kept track of all of the book objects inside of this books list. That was probably, looking back at it now, kind of like a hacky way of fixing this problem. So a better solution would probably be to create another function inside of the SDK to delete a book by its title or by its ISBN or ID or something that doesn't require a book object. But it's working, so I'm just gonna stop. I'm not gonna touch it. And yeah, thank you guys for watching. Hopefully this was helpful for something. I know it was a little complex, but I think it gets the job done. So thank you guys for watching. Stay tuned for the next video where we're gonna be reviewing everything we've talked about with tkinter. Hey everybody, this is your review on tkinter, which we're just gonna go through everything real quickly before we move on to Django. So tkinter is the Python graphical user interface tool. There are other ones out there if you need, but this one is built in. It's really simple to get started. And we went through two simple applications, one which was a guessing game, and the other which allowed us to add and remove books from a database and list those in the app. So to get started, oh, by the way, there's a bunch of boring notes if you want to read them, but to get started, all you have to do is import tkinter and then call it like so and assign it to a variable. Anytime you're going to create different components for the user interface, you will need to pass in tk as an argument. So other code might use a different variable name, so it'll change all of the calls. You can modify the title by saying tk.title, and then you can start the application by saying main loop. That's going to keep it occupied, and anything after is not going to show up until the window is closed. So the first application we built was a random number guessing application. So we generated a random number like so. We created a function to check if the number was correct. So we pass in a guess. If it's correct, we do a message box. Otherwise, we add a label to the window, which works just fine. Anytime you want something to be displayed, you have to use this .pack, which is one way of displaying data. There's also the grid option if you want to do a little bit more formatting. But like I said, I was just really focusing on functionality here. So this just adds it at the bottom of the application. The main components we talked about here are labels, which are text that show up on the screen, entries, which are text box that you can put values into, and buttons, which you can click to invoke something. We then built upon these principles to do a little bit more of a complex example, which was working with a list box. And the basis of the application was that we had two entries, here, and two buttons. Whenever we clicked the buttons, a function was called add to list or delete from list. And taking a look at this, add to list is pretty simple. We actually have a good check here to see if the title is empty or the pages is empty. In that case, we just return, everything stays the same. Nothing was added to the list or added to the database. So you might want to add that to your code. Now, at this point, you would have a decision to make. Do you want to display this data on the list like strings? Hey, that might work just fine. Very simple. Or if you're heavily involved with working with objects that come from the database, you might just prefer to always be working in object form. Whatever you decide to do, that is totally up to you. We decided to create book objects because that's actually what's happening here at the beginning, where we iterate through all of the data in the database and append those books to the list. Unfortunately, the list box is pretty weak in that it doesn't keep these objects. I'm pretty sure it just keeps the string representation, which is kind of dumb in my opinion, unless there's something I'm missing. But when you add an object in there, it gets the string representation, and that's what shows up in the list. Then when you get that data back out, you just get that string representation, and the object is lost. So in a way, we're doing extra work to create that object, add it to the list just for it to be converted to a string, and then anytime you get that data back out, it's a string and you have to convert it back to an object. It's kind of like this weird conversion thing, but if you want to work with book objects, then that's a step you might want to take. Basically, my ideal here is anytime there are books in the database, we have those equivalent book objects inside of our code. Another cool thing here is that we're using tkinter.end instead of importing it directly. So that is another option if you don't want to import end. And that is used within a call to delete, which will clear out any text inputs. So we're clearing out the title and we're also clearing out the pages. So yeah, that is your conclusion of our section on tkinter. Obviously, we just scratched the surface. My goal here was just to give you a taste of another way of programming. And honestly, I don't do desktop applications a whole lot. I pretty much do web applications or console applications. Desktop applications certainly have their purpose, but I think in general, people prefer the API development with a web application, even if that web application is built in such a way that you can create a desktop application from it, that works too. But I think sole desktop applications are becoming less popular, definitely not obsolete, but not something I focus a whole lot of my energy on because I am rooted in web development. So I'm not so sure I'll be doing a tkinter series anytime soon, but I guess we'll see. If you guys really like this, then maybe I'll try to get interested in it more. Otherwise, we're going to move on to Django, which is the web development for Python. And we're going to do a similar thing where we kind of just touch on a bunch of different things and get a very small scale application up and running. So stay tuned for that. I'm really excited and I hope you are as well. Hey everyone, welcome to a really cool section in this Python programming series where we're going to start talking about web development using Django. So our goal is to get the basics out of the way and get something up and running that will give us enough of a foundation so that you can start building applications on your own. Now, we're not going to get super in depth with it. It's really just scratching the surface. If you think an entire series on this would be cool, leave me a comment in the comment section below. But other than that, let's just get started and try to get this tool installed. So you can go to the website djangoproject.com and there is this download tab which will teach you how to do it. And you can follow the guide here, or you can follow the one and only Caleb Curry, who's going to give you the step-by-step instruction on how to do this. So the very first thing we're going to do is we're going to install a tool called pip, which is a tool used to get packages in Python. So that will allow you to get Django, because you can see they're using pip here. So I am on Mac. If you are on Windows, rest in peace. I'm just playing, but you might need to do a little bit of research or figuring it out on your own, because I don't have a Windows machine set up. So if you've made it 90 some videos into this tutorial series, I imagine you should be able to figure it out. So you can find this page at pip.pypa.io/en/stable/installing. And you can just copy this. And then inside of a terminal, paste this. That'll get you this Python file here. Then all you have to do is say python get pip.py. Oh, and see, look, it says Python 2.7 here. So you might need to run this with Python 3. So I'm going to do that here. All right. So that'll install pip. It looks like it uninstalled an older version here. And now I have 20.1. So now what you're going to do is you're going to use pip to install a tool called virtual env or virtual environment. So you're going to say sudo pip install virtual env. Hit enter. password. All right, so this virtual env or virtual environment thing, well, different projects in Python are going to require different packages. So the virtual environment allows us to have basically an isolated environment for each one of these projects. So instead of installing everything globally and trying to get all your projects to use the same version of everything, you can have different versions for each project. So that's where the virtual environment thing comes in. So we are currently in the folder that we're going to be developing in, and what we're going to do is we're going to say virtual env, which is the command to create a new virtual environment. So hit enter. And you can see this folder pops up. It says env and it has some junk in it. And also, you can just X out of that. We don't care about that. All right, so we did a few things. We installed pip, we installed virtual environment, and then we created a virtual environment. Next thing is if you want to use this virtual environment we created, we actually have to activate it. So I'm going to show you how to do that now. You're going to say source, and there's a particular file in here, bin activate. So source, we're going to enter the env folder, and then the bin folder, and then activate. So anytime you want to use your virtual environment, this is what you would do. Hit enter. And now you can see it says env on the left here, and it just changes the terminal just a little bit. So now we're working within that environment. If you need out, you can say deactivate, and that'll get you out. But we're gonna stay in. So enter that code again, and now we're back in the environment. Now we can install Django in this environment. So what we can do is we can say python -m, and then pip install Django. Let it do its thing, give it a couple minutes. So now we can create a project in Django. So to do that, we say Django-admin, start project, and we can just call it books. That'll make a folder appear over here, which is our books project. Inside of our project folder, there's this manage.py file, which we will use for various things. So why don't we just change directory into our project folder by saying cd books, and then we can work with this manage.py file by saying python manage.py, and then we can run our server by saying run server. We get some red stuff up here. Don't worry about that. We're going to talk about that soon. But for now, it says the development server is available here. So you can follow that link to open it. If you open it and you get this screen, then congratulations. You got Django installed and you are ready to start making websites. In the next video, I'm going to be showing you how to do the equivalent of a Hello World application for Django. So stay tuned. And if you've enjoyed this video so far, please be sure to subscribe. Really help out my channel. Hey everybody, in this episode, I'm going to be teaching you how to do the equivalent of a Hello World inside of Django. Now Django is interesting because you create a project, but within that project you can have numerous apps. So we're going to create an app inside of that project. So what we're going to do is we're going to leave this running because that is going to allow us to access this page. So what we can do is we can hit this little button and that's going to open another terminal here. And what we can do is we can activate our virtual environment from here. So here's what we can do. We can go up a directory. So we are looking for this env here, and then just say source env slash, and I believe it's bin slash activate. Hit enter. Now we're in that virtual environment. Now what we can do is we can change directory back into our project. Inside of here is where our manage.py file is. So we can say python manage.py start app, and we'll just call this reading. Hit enter, and that's going to create another folder inside of here. So it's a little funky on the file structure. We have this outer books, this inner books, which contains stuff about our project, and then we have this reading app. Now the goal here is to be able to go to our app and visit /reading. When we go here though, we get page not found. To fix this, what we're going to do is we're going to go over to our app, and inside of reading, we're going to create a new file, urls.py. Now I'm going to paste some code in here. Nothing too crazy though, so you should be able to type it out. We're going to need path because we're going to use that here, and I'm going to explain what this does in just a second. Basically, when we visit reading and we don't pass in anything after this /, we are hitting an empty path here. And what we want to do is we want to hit an index page. So that is in views.index. So what we do now is we go into our views file and we can create that view here. So a view can just be a simple function. So here's what it's going to look like. We actually don't need this line here either. So def index, and this is going to take a request. And then we just say return HTTP response, which we're actually going to import. So bring this down a line and say from Django URLs import HTTP response. And all we're going to pass in here is just books and stuff. Let's keep it really vague for right now. So we've done two things so far. We created this view here, the index view, and then we created the URLs and told it to use that view. So is it going to work yet if we refresh? Not quite. There's one more thing we got to do. At the project level, we have to define a URL. So go into books, URLs, scroll down a little bit, and we're going to add a new path in here. So instead of admin, it's going to be reading, like so. And then what we need to do is we need to say include, which we actually need to import, of course. So that's going to be right here, import path. Include is another option. And then inside of parentheses, here's what we're going to do. We're just going to put the URLs for our app. So it's going to be reading.urls. So yeah, if you're totally overwhelmed with stuff to do, yeah, I get that. I had the same experience, still trying to figure out some of this stuff sometimes. But as of now, it should work. Cannot import HTTP response. So that's in our views. And that's because we should be importing this from django.http. There we go. All right, let's try this one more time. Go back to our page, refresh, and boom, books and stuff. So that is how you would do a hello world essentially inside of Django. So let's just review because that was a whole lot of stuff. So let's start at our project URLs level. So that's right here. And here's what's going down. Anything to reading in the URL, we're just going to forward that over to the reading.urls. So it basically crops off anything on the left and sends anything extra. Since we're just going to the blank page, there's nothing extra, which is why inside of reading, we just have an empty path right here. Then we say what view we want hit. That's views.index, which comes from right here. Here's that index view. And all we're doing is returning an HTTP response that says books and stuff. So there's three components really here. The view, the URLs for the app, and then the URLs for the project. Well, that's enough routing and junk for this video. I'm getting a migraine. So what I want to do now is I want to talk about database stuff, which I prefer, and we're going to talk about that in the next video. So stay tuned and be sure to subscribe. Hey, what's up everybody? So I'm an idiot. I have a Blue Yeti microphone and there's like this mute button on the front and I pressed it and I recorded well, I didn't mean to press it obviously, but I recorded a whole video with it on mute. And this video is at a point where I can't easily redo it. So I'm just gonna voice over. So let's just get to it. So the whole purpose of this video is that we're going to be working with database migrations, talk about what they are and how they work. Basically, it's how you can represent a database structure in code. And before you start working with this stuff, you should take a look at the settings. First thing you'll notice is you got this secret key, which you shouldn't share with anyone. Oops. And then you got this installed apps. And this is pretty much all the components that Django is going to have by default. You can get rid of some of those if you don't need them, but just leave them in there for this video. And we're going to actually add our app into this list just down here, and you're just going to type reading.apps.readingconfig. So that's going to go into this apps.py file and find this reading config. So that is how you add your app to your project and basically say that, hey, we have some database migrations too. So we want to define a database structure that we can automatically have created for us. When we do this, it will allow us to easily migrate our code from one system to another. Let's say we deploy our application, we can just say, yo, generate the databases. When your server is running, you'll notice you got like a red thing that says you have 17 unapplied migrations. Yeah, well, that's talking about the migrations that already exist from these installed apps. When we first generate our project, those migrations are not automatically executed. So let's talk about how to run those. All you got to do is say python manage.py migrate. That's going to do a bunch of OKs, and that's going to apply those migrations. Next up, we can define a database structure to create our own migrations to generate database tables. We do this in the models.py file. Models are just classes that represent our data. So we can create a model in here. We're going to create a class called book, and this is going to inherit from models.model, which you put in parentheses there. Inside of here, you can put any fields that we want in the table. So for example, we can have a title. That's going to be a character field, and you can put different attributes inside of parentheses. An example would be max length being 200. The other field we're going to have is pages, and this is going to be an integer field with a default of 0. Now, to make this into a migration, all you have to do is say python manage.py make migration. So let that run, and you'll see in the terminal you'll get something blue, and then it says 0001 initial.py. So that's the first migration for our application, and we created the migration similar to how the 17 other migrations existed, but we haven't applied the migration yet. You can open up that migration file to take a look at what it looks like, or you can just not, but don't worry about that for right now. So we're just going to apply this migration, and here's how you do that. You just say python manage.py migrate. That'll apply the migrations, and then it will say OK. So that's your introduction on how to add your app to the settings, how to apply migrations, and how to create migrations of your own using these models. So the models are going to be used to structure all of our data, and we're going to talk about how to work with this data in the next video. So stay tuned, and again, apologies about my microphone. Stay tuned for the next video, and please be sure to subscribe. Hey everyone, in the previous video we talked about how to create migrations and generate a database from those migrations. So now I want to work with that database. So it's real simple, but the recommended way to get practice is actually to use an interactive mode. So what you can do is you can say python manage.py shell, and that'll open an interactive mode. I'm not entirely sure how it's different from the normal interactive mode, but that's what the documentation suggested to do, so we're just going to go with it. And in here, we can start working with books. But by default, it's not just going to work because we actually have to import it. So to do that, we say from, and then your app name reading dot models import book. Now it should work. So to create a book, here's what we're going to do. We're going to assign it to a variable and pass in some data, and we're going to use named arguments here. So the title is "Are you my mother?" comma pages. We'll just go 72, hit enter, and now we have a book object. Is this in the database? Not quite. We have a book object in memory in our application that's running, but we need to store it on disk. So we say book. It's actually really super easy. .save. Boom. That simple. So now you might be wondering, Caleb, is this like legit in the database, or are you just fibbing with us? Well, I'll prove it to you. To get all the data from the database, what you do is you say book, capital B here, so the class, .objects.all. Hit enter, and we get a query set. And there's actually two things in here. I apologize because I did this example once already and I screwed it up. So I'm doing it again, but that's why we already have one book object in here. So yours will probably just be one in here. Now you might be wondering, can we get any prettier output than this? And actually you can. This is just based off of the string representation of the book. So we can override the stir method. And I'm just going to do some string formatting here. So we will say title is pages long. Now this isn't going to do anything different. By default, you actually have to exit and reopen. So we exit, and then we reopen the shell. We don't have to create a new book object. It's already in the database. So we just have to get the data from the database. So first import, so from reading.models import book. Book.objects.all. My bad guys, I'm a noob. Go self.title and self.pages. Geesh, come on Caleb, we're like 200 videos into this Python series. All right, let's try this again. So from reading.models import book. Book.objects.all. There we go. Now we're getting somewhere. Now you might be confused because we changed some of the code, but we didn't have to do any migrations. Last time when we changed this code here, we had to do a migration. Well, this doesn't actually change the database structure at all, so we are fine. We don't have to worry about it. If we were going in here and changing the actual columns, that's going to be a problem and we would have to create a new migration. Now, when you're working with this query set and you want to get a specific book, you can do that. So just say book.objects.get, and you can pass in PK and then a number. So that stands for primary key. So this will grab the first book in there and it'll return it. So you can assign it to a variable if you want, or in this case, we just printed it. So let's assign it to a variable. We'll say book.objects.get, PK equal to 1. And I think you can also use ID equal to 1. It'd probably help if you didn't say booge and said book instead. So make sure it says book, and let's try this. And there we go, it seems to work, so we can say book, and that's the information. So you can easily update any of the database objects just by setting values. So book.title, say new title, book.pages, set it to something else, and then we just say book.save. So you see it's pretty simple to work with objects. Then we can check the database, so book.objects.all, and check it out, it's totally updated. Now that you know the basics of working with data inside of a database, in the next video I want to talk about querying this data and hopefully display it on a web page. That would be pretty awesome. Stay tuned, I'll see you in the next one. Hey everybody, in the previous video I was teaching you how to work with the database, but this was all within the interactive mode, and now I want to do it in our code so that we can actually get the data from the database and display it in HTML. So there's a lot of new concepts in this video, so pay attention. And really honestly, once you get through this video and the next video, maybe the next one, you've pretty much touched a bunch of different concepts in Django, such that any of the new Django series or videos we do, it's just going to be expanding on that. So if this seems totally overwhelming, that's good. That means you're learning and you're getting a lot of different experience. So, and if it's totally easy and you're like, what the heck? Well then, you're just too pro for me. So here's what I want to happen. When you visit this page, I want it to list the books that we have. So we need to update the view, which is what is giving us this data here. So go back to our code and go into the views file, and you can see books and stuff is right there. So we need to replace this. And I got an upgraded version that I'm going to paste here. So you can type this out. So this render here is said to be a shortcut in Django because it does a lot of stuff for us. So we actually need to import that, and we no longer need this HTTP response. And I know you guys don't really like when I paste code. I try not to do it too often. However, very syntactical, I don't want to screw it up 80 times. So now we're going to import this render here. So you can say from Django.shortcuts import render. Also, if we want to work with this book here, we need to import that. So we can say from, and instead of saying reading.models, since we're already in that folder here in this file, we just put a dot, which is the current directory, and then models import book. And my spelling is like a third grader's, except worse. So, oh, there we go. All right, here is kind of similar to what we were doing earlier where we did book.objects.all. Well, another option is this order by. So we're ordering by title, which is going to put them alphabetically, which is kind of cool, but we could just do .all. And then this render function, it returns an HTTP response. So that's why it's like a shortcut. Instead of working with the HTTP response directly, we use this function here to do a little bit extra work for us. So the first argument here is the request, which is passed in when this is hit. So we just put that here. Then we have, what is this, huh? Well, this is actually a template, and we're going to show you how to create that in a second. Then here is the data we want to be available on that template. So books is going to contain this list of books here, this query set. So if you're still following, great. What we're going to do now is we're going to talk about templates and a little bit more about the Django structure. So this is kind of dumb and confusing, but just hear me out for a second. So there's a popular design paradigm, MVC, Model View Controller, where the model represents the data, the view represents how it's presented, and then the controller is kind of the interface between the two. Well, Django has a similar structure, but the naming is totally different. So we have the model, which we talked about. This defines the structure, so that's the same. But the views are actually the equivalent to controllers in other web development frameworks. This is what is hit when you visit a web page. So the templates determine how things are presented, so what it looks like. So what we can do is we can actually build this index.html, and to do this, we're going to create a new folder. We're going to call it templates. Then inside of this templates folder, we're going to create a new folder called reading. Then inside of the reading folder, we're going to create a new file called index.html. Now, if you guys haven't heard of HTML, it stands for, no, I'm just kidding. I'm sure you guys have heard of HTML, but this is not just any HTML. This is special HTML, in that we can actually mix Python code with this HTML. It's called a templating language, or a templating language, however you would pronounce that. So when we are in this code, we're going to have access to this books list, and I'm going to show you how to display that. You just put two curly braces here and put books, like so. Anytime we put the curly braces, we're going to represent some data. You may also see curly braces with a %, which you can do different structures like loops and stuff. So we'll just start with this. Now let's go to the web page, do a refresh, and check it out. We get that data on this page. Yeah, it's ugly, it's a query set. However, that's a good start. Now what we can do is we can mix this with HTML to make it look pretty. So here's what we're going to do. We're going to create an unordered list, like so. And then inside of this unordered list, we're going to do a for loop. So we'll do curly braces, and then a % to open and a % to close. So it'll look like this. And then we can say for book in books. Then what we can do is do some more HTML. We'll do a paragraph, curly braces, book.title. And then afterwards, we actually have to do something you might not be used to, which is ending the for. So it'll look like so. There you go. All right, let's try this. Refresh. Hey, check it out. We have an actually not disgusting list here. So we're making serious progress. You got data from a database and displayed it in an HTML page. You could actually make these links to go to a more details page or to edit stuff or whatever you want to do. I'm going to show you guys how to make these links. I also realized I need a list item here. So probably want to put that here. Probably do that instead of the paragraph, honestly. Refresh. All right, there we go. So that is a proper list. And now I want to make these links. So we can just make an anchor tag. href. This is going to link to, and you can design a link however you like. We're going to go with /reading, /, and then instead of the book title, we could actually do the book ID. And the quote is going to go outside of the curly braces there. So that's going to create a link for us. Then we need to close the anchor tag, and we can put some text in here, which is where the title can go. So book.title. So hopefully that wasn't too crazy confusing. All right, let's try this. Refresh, and there you go. You can see the link down here. We got reading /1 and reading /2. Clicking them, they don't go anywhere, but it's a good start. That is where an information page would go. This information page is going to be interesting because it should be pretty much the same for each one of the books. So, I mean, imagine if you had 1,000 books. You don't want to have to create a new page for every single one. Instead, you want the same page. You just want to change some of the data. So this one is going to act as a parameter, which will change some of the information in the page. So the info page will be the same, but it'll just be generalized to get the information for that book. So we're going to talk about dealing with parameters in the next video, as well as a little bit more on URLs. So stay tuned and be sure to subscribe if this has been helpful. Hey everybody, in this video I'm going to be talking about how to generate URLs as well as deal with URL parameters inside of Django. So first thing, let's talk about this URL. We're hard coding this here, which isn't the end of the world, but it might be ideal to generate something like this. This allows us to move around our apps a little bit safer without breaking everything. So first thing, go into your urls.py and add in here app name, and we'll just set that to reading. And we can also go into the URL patterns here, add a new one, path, and this is how you deal with parameters. You put less than, greater than signs, you put the type, and then you put what the parameter is going to be called. So book ID. This can be managed by a new view here. So views.info, and we'll just say name is info. So let's create that view. So right now it's currently saying module reading.views has no attribute info. So let's fix that. Go into views and just say def info. It's going to have the request, and it's also going to have the book ID. And here we're going to do something very similar. So copy this, paste this, and instead of all, we're just going to say pk is equal to book ID. So that'll just get one book, and we can just change this to book, just update this to be correct. And this is going to go to a new template, which could be called info.html. Inside of templates, we can right click new file, info.html, and just print the book like so. All right, so let's test it out. Let's go to our home page, and when you click one of these, it's going to pass that ID of 1, which you can see at the URL down there in the corner. It's going to pass it to the view, and okay, we got an issue. Instead of all, I actually want to use .get. There we go. So let's try it now. Do a refresh, and there we go. We get the book information. So imagine there's a lot more in here, like the ISBN, the author info, pictures, maybe like a sample, whatever there might be. So that is how you parameterize, that's a mouthful. That's how you use parameters for your URLs so that we can use IDs and switch it up depending on what book we're talking about. All right, so now the last thing is how to automatically generate the URL rather than hard coding here. And to do this, replace the href portion here, curly brace, parentheses, those aren't parentheses, curly brace, %, curly brace. And in here, you can say URL, and then the name of the URL based off of this file here. So we're trying to grab info, and we also put this app name here, so you prefix that with a colon. So it'll look like this. Inside of single quotes here, reading, info. And then after that, you can say what you want to pass to it as arguments. So we're trying to pass book.id like so. All right, I saved it. Now let's take a look at our web page. We do a refresh, and ideally everything works exactly the same. You shouldn't see any differences. That's because I haven't changed any of the URL structure. But what if we went in here and we went test /. Well, now let's go back, do a refresh, and look at these. They automatically update to reading /test/1, and they still work. So we avoided the hard coding, and it made our app a little bit more dynamic. Very cool. That's all I got for you guys in this video. Stay tuned for the next one. I believe it's the final one in the series if I'm counting right. So I'm pretty excited. See you then. Hey everyone, welcome to your final video in this Python tutorial series. First off, I wanted to say a special thank you to you guys for sticking through it, and would definitely appreciate a subscribe if you liked the series. Also, special thank you to this article series on the Django website. This really helped me build out a lot of the content for the last couple of videos. So if you want more information, you can check that out. Lastly, just again, if you need any of the code, for example, in the Django section, you can get that here. I'm not going to go through it all just because it was a lot of information, and to review it, I'd literally have to redo all of the videos because it would take a while. With that, I pretty much just wanted to conclude and get your guys' opinion on what kind of content you would like to see next. And some of the specialties for Python is, well, obviously web development, if you think a Django series would be appropriate, or data science and analytics is huge with Python. If that's something you think would be cool, let me know. Maybe it's data structures and algorithms. There's all kinds of different things you can do with Python. I think if you're still interested in learning more Python, first off, check my channel. Probably going to release more series in the future. And also, I would encourage you to try to expand on Django and start building an API. So create an API to work with your books database, and then create front-end applications to consume that API. So in that situation, you could have a backend that is shared among a web application, a desktop application, a mobile application, a console application, a watch application, and it could all share the same data. As long as the application can make a web request, then it can use that API and you can have a consistent backend for your applications. Oh, I'm starving. Can you guys hear my stomach? I'd also look into continuous integration. I'd look into deploying to AWS or something like that. I do have a video on deploying Node.js, which is different. However, a lot of the principles are going to be the same if you need to understand the concepts, and it'd also be good practice for you guys. All right, so that's the end of the series. I was going to do some review, but then I realized, hey, I already did 99 videos. I don't really feel like doing any more. What's a good calm video gonna hurt anybody? Alright, so stay tuned for the next series, and again, leave a comment, let me know what you'd like to see. I'm gonna go probably find something to eat, maybe a 12-pack of donuts or some spinach, whichever sounds better. Alright, stay tuned, and I'll see you in the next series.